According to an article by Business Standards, the Indian EV market is about to reach rupees 20 trillion by 2030, creating 5 crore jobs in India, says Nitin Gadkari, Minister of Road Transport and Highways. If you look at the job market right now, you will find that the number of skilled EV engineers is way less than if you compare it with demand. And that's what exactly makes a career in EV a great choice. And I'm not saying this out of my own will. If you search on internet, you will find that the demand for EV engineers has been rising for the last few years. The industry is in need for professionals skilled in areas like embedded electronics, battery management system, cloud computing and data analytics, all of which are critical for optimizing charging infrastructure and enhancing vehicle safety. This skill gap creates a golden opportunity for aspiring EV engineers like you to step into this industry. And to capitalize on this growth and help you make a career in EV, we have created this EV course. In this course, we talk about almost everything you need to land a job as an EV engineer. Let me take you guys through the agenda for this course. First, we will start with what is EV to lay the foundation of our understanding. Next, we will dive into the EV market and growth. Moving on, we will explore the key policies of EV growth and FAME scheme. Following that, we will look at the key players in the EV ecosystem. Then we will look at the block diagram of EV and working. Next, we will discuss the working principle of EV. Following that, we'll move on to the running cost of EV. Next, we will explore the battery pack and motor controller of EV. Then we will dive into electric motor and inverter of EV. Moving on, we'll discuss DC, converter and wiring harness of EV. Next, we will cover communication system in EV which are essential for inter-component communication within the vehicle. Following that, we will look at the charger and its type. Next, we will shift to conventional vehicle. We'll begin with conventional vehicle architecture. Then we will compare different engine layouts such as front, mid and rear engine cars. Following that, we will explore the efficient cooling system. Then we will wrap up by making a comparison between EV and ICE vehicle. And finally, we will conclude with the electric vehicle architecture, reviewing the overall structure and design of electric vehicle. So as you guys are clear with the agenda, let's look at the very first topic.
Electric vehicle and its future in India. An electric vehicle is one that runs on electricity rather than an internal combustion engine which creates power by burning a mixture of fuel and gas. As a result, such a vehicle is being considered as a possible replacement for current generation vehicles in order to address challenges such as rising pollution, global warming, diminishing natural resources, and so on. Though the concept of electric vehicles has been around for a long time, it has gotten a lot of attention in the recent decades due to the increasing carbon footprint and the other environmental repercussions of fuel-based vehicles. Why are electric vehicles boon to India? Does not need many conclusive factors. Here are some important statistics. India has 6 of world's 10 most polluted cities. The main cause of this growth in pollution is the use of fossil fuels. India's oil import. Overall, India's dependency on crude oil imports is 86%, which implies the country meets just 14% of its own energy needs. The rest is imported. Global climate change, heat emissions, the Paris Climate Accord, and the impact of sophisticated artificial technology on self-driving cars are all discussed thoroughly. Electric vehicles market share in India. The Indian automobile industry is the world's 5th largest and it is anticipated to become the 3rd largest by 2030. According to the India Energy Storage Alliance, the Indian EV market would develop at a 36% CAGR. As India's population grows and demand for automobiles increases, reliance on conventional energy supplies is no longer a viable option as the country imports over 80% of its crude oil. By 2030, Niti Aayog expects to reach 70% EV market penetration for all commercial vehicles, 30% for private vehicles, 40% for buses, and 80% for 2 and 3 wheelers. This is consistent with net zero carbon emissions by 2070. The Indian electric vehicle market was worth $1,434 million in 2021, and it is predicted to grow by $15,397 million by 2027 at a CAGR of 47.09% during the forecast period of 2022 to 2027. Obviously, there are also some drawbacks in the transition to electric vehicles. Some of them are electric vehicle charging infrastructure that may need another huge set of investment from the government and other competitive authorities. The higher costs. There will also be a lack of skilled workforce. The technology that we currently hold is very limited, and also the import of electric vehicle components and materials.
Electric vehicles are the wave of the future. Manufacturing businesses are putting in more efforts into transitioning from traditional automobiles to electric vehicles. There are several advantages to owning an electric car with the appropriate level of functionality and infrastructure.
Just a quick info guys, Intellipaat offers electric vehicle course training. Through this course, you will learn vehicle fundamentals, battery technology, battery sizing, mechanical subsystems, charging infrastructure, and much more from the top 1% of industry experts around the world. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, the link of which is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of EV.
Hello everyone and welcome to today's session on electric vehicle design process at Intellipaat. Do you know friends that every great innovation starts with an idea? And electric vehicles are no exception. They are built to head into a sustainable future, removing the rate of carbon emission happening on the roads. The process of manufacturing these vehicles begins with the designers and the engineers brainstorming various concepts to create an electric vehicle that aligns with the needs and desires of the people. Initially, they consider questions like what type of electric vehicle would best suit the urban environment that promotes eco-friendly commuting? Or how can we design an rugged electric SUV that appeals to the adventure seekers and the outdoor enthusiast? These queries guide the team as they lay foundation for a vehicle that will impact the lives of countless people worldwide. Then we move to the research and development. After we have achieved a clear vision, the next process is to gather data and research. Engineers and designers analyze existing electric vehicle technologies, batteries, and motors while keeping an eye on the latest trends in the sustainable materials and energy efficiency. So you can consider asking questions like what materials do you think would be ideal for building the body of an electric vehicle. After this, we move to the prototyping stage, where skilled designers leverage advanced computer-aided design software to create virtual representations of the vehicle. This virtual canvas allows them to experiment with the various shapes, sizes, and contours until the perfect design emerges. Let's see an example. We all know that aerodynamics play a vital role in the efficiency of an electric vehicle. So engineers meticulously assess the airflow patterns and make precise adjustments to minimize the drag, thus optimizing the vehicle's range. This process may involve countless iterations, each taking them closer to the ultimate electric vehicle form. Once the virtual model is refined, it's time to bring the design to the live through physical prototypes, through testing and validation. The testing and validation phase is crucial for ensuring the electric vehicle safety, performance, and efficiency. Engineers conduct crash tests, evaluate range, acceleration, and top speed, and also analyze energy consumption. Real-world simulations are also performed at this stage, which helps to identify potential weaknesses. Extensive road test is also performed, which ensures the vehicle meets real-life driving expectations. This rigorous process guarantees that electric vehicles meet the highest standards, assuring customers of a safe, reliable, and eco-friendly driving experience. After rigorous testing, we move to the battery and powertrain integration. We all know that the heart of an electric vehicle lies in its battery. At this stage, engineers optimize the battery's capacity, weight, and cost effectiveness while experimenting with advanced battery chemistries and cell configurations to extend the vehicle's range. Simultaneously, they design the powertrain for efficient propulsion, considering single or dual motor setups, front or rear wheel drive configurations, and all-wheel drive options. The goal at this stage is to harmoniously unite the battery and powertrain to create a dynamic driving experience while maximizing energy efficiency, thus empowering electric vehicle to perform at its best and pave the way for sustainable mobility. After battery and powertrain integration has been done, we move to the next step in the design process, that is interiors and user experience. At this stage, the interior and user experience of an electric vehicle are carefully designed to provide comfort and convenience. Ergonomics play a vital role in ensuring seamless driving experience. Designers focus on creating an intuitive dashboard layout with an easy access to the essential controls and information. Infotainment systems are integrated to offer connectivity and entertainment, thus making journeys enjoyable. Additionally, charging solutions are integrated into the interior design so that there is a hassle-free access to the charging ports. At this stage, engineers aim to create an inviting and user-friendly space that enhances the pleasure of driving. After successfully completing the interior designing and user experience, engineers give a thought on sustainability and environmental impact of the electric vehicle. As the scientific research states that electric vehicles lead the charge towards sustainability, which aims to reduce their environmental impact significantly. At this stage, manufacturers prioritize the use of recycled and sustainable materials during production, thus minimizing resource consumption and waste generation. With zero tailpipe emissions, electric vehicles contribute to the cleaner air and reduce greenhouse gas emissions, thus promoting a healthier planet. Their adoption plays a vital role in conserving natural resources and reducing our dependence on fossil fuels. After completing all these feasibility studies, an electric vehicle moves into the development phase. It is a very thorough and lengthy procedure. However, the design mostly revolves around the set vision for the product. Now I hope that you guys are clear with the fundamental notion of the electric vehicle design process.
Just a quick info, guys. Intellipaat offers electric vehicle course training. Through this course, you will learn vehicle fundamentals, battery technology, battery sizing, mechanical subsystems, charging infrastructure, and much more from the top 1% of industry experts around the world. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, the link of which is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of EV.
We will take care of electric vehicle markets and growth, basic block diagrams of EVs and working, and little bit of introduction of major components, just a overview of introduction of major components we will see. Yeah, right. Tomorrow, at the same time, we will see about the same introduction of major components in depth. We will see, and charger and MATLAB. We will see this topic. Okay, first, what is electric vehicle? Actually, electric vehicle is powered by electricity. Not we can't say the electric vehicle means it's run by electric motor. Okay, right? Because even the hybrid vehicles are can run by electric motor. So electric vehicle means run by electricity. Motor and battery can be used in hybrid vehicles also. Like hybrid vehicles means there will be engine also, there will be a motor and battery also. So yeah, you can't tell that as an electric vehicle. So the electric vehicle means purely run in the electricity. So that is the thing. Okay, that is the electric vehicle. And if may ask, like what are all the vehicles, like you can say, electric vehicle, and what are all the vehicles you can say that you mean? I mean the powertrains of the vehicle. Powertrain means what you use to power the vehicle, like electric motor, and what are all the vehicles you can see. You guys can see the 4 vehicles. So you guys can type what are the vehicles. A, what kind of vehicle, B, what kind of vehicle, C, what kind of vehicle, D, what kind of vehicle. You guys can type. The first is IC engine, like you can say it's a petrol or diesel. Second is electric vehicle. It's a full battery oriented vehicle. It's no solar or nothing in this, because solar means you can see the outer panels, sonar panels. It should be in the outer. So it's a fully battery electric vehicle, battery oriented vehicle. C is hybrid, as you guys mentioned, because the front there is a engine, and here there is a battery, and in the front there will be a motor also. So this is the thing. This is a hybrid. And D is fuel cell. Like here, why I left this F cell is like mostly not everyone knows about the fuel cell. I just given the hint here. So to guess. It's a fuel cell vehicle. It's not a CNG or anything like because you guys saw the cylinders and guess this is a CNG. But here, this the D you can see right, like the arrow mark. That is the electrolyzer. The gas from this will come and it will convert and it will give the H to the. So it works like that. Yeah, this is the fuel cell. So how we tell this is a fuel cell or this is a hybrid, this is a motor oriented. Here you can see the fuel tank, the fuel filling tube, pump you can see. So this is the fuel cell. Sorry, engine oriented vehicle like petrol engine or diesel. In the B, you can see this charger and you can see the battery on the floor. So it's a battery oriented vehicle. In the C, in the hybrid also, there is a one specific thing you guys have to mention. If you in future you guys can mention that. This is not just a hybrid. This is a plug-in hybrid. So there are the different types of hybrid vehicles. Only through the fuel pump, the fuel pump fuel will comes in, and there will be a battery also. There will be a motor also, but there will be no plug-in. This charging port won't be there. So that is the full hybrid vehicle that we call as a full hybrid vehicle. So if plug-in port is that is the plug-in hybrid vehicle. Like I think Chandra also mentioned the PHEV. So that is PHEV means plug-in hybrid vehicle, and D is FCEV. That's a hybrid fuel cell vehicle. So you will have a fuel gas tank, hydrogen tank, and there will be electrolyzer. It will convert and it will give to the fuel cell, and it will run. So this is the four types of vehicle. There are more types of vehicle also, like in this hybrid itself. Now I said about the hybrid and the plug-in hybrid, and there is a parallel hybrid, series hybrid, like many hybrids are there. So this is the IC engine oriented hybrid. There will be a hydrogen engine oriented vehicle. Both look same. So there are many things for them. So this is the four types of vehicle which I am mentioning about. So clear, right? It's a fuel cell vehicle. You can see the tank over here. So the for that fuel cell vehicle, you have to understand how it works. So there is a tank. This is the fuel pump. That's the hydrogen pump, high pressurized hydrogen pump. So in this fuel tank, like you will fill the hydrogen gas, and this hydrogen gas will come into the electrolyzer, and it will convert the and give out the H2O, water as the exhaust. And another side, it will convert into the electricity. And that electricity will go to the motor and it will run the motor. So there will be a battery also. There will be small battery for a backup purpose, but mostly it will runs on the hydrogen and it will converts the electricity. And that electricity will go to the motor and it will run. That is how the fuel cell works. I will make a separate slides for this, how it works, how the internal it works, and I will explain you clearly. But this is the basic understanding of fuel cell. Yes, chemical energy is converted to electricity. So by that it will separate in the fuel cell chamber. It will separate the electricity, and the another side it will separate the H2O. The exhaust will be the H2O water. So yeah, that's it. Here just what is electric vehicle? We asked right before, like electric vehicle is nothing but it's run by electricity. So proliferation of electric vehicle. What does that mean? Proliferation means it's a rapid growth. Why rapid growth is happening in industry? The EV industry. Why rapid growth is happening? What do you guys think? Why it's happening? Like there are more improvement in the battery technology, and without government the bringing in the electric vehicles and reaching to the customers and consumers, it's very hard. The government has to give out many incentives, many subsidies, like many like grants or something they have to give to push the EV sector up. So those kind of things, and charging infrastructure. Of course, if there is no charging infrastructure between certain kilometers in your place or in near to your place, if there is no charging infrastructure, of course you are not going to buy EV vehicle. So for the charging itself, we have to go travel somewhere else and we have to put the charge. So the growing infrastructure of charging, so that is rapidly growing, and it's like government is pushing everywhere like to the about the charging station. There are high power output of charging stations are there. It's growing rapidly. And one main thing, environmental concerns, like it's for the selling purpose, they will say it's a sustainable and environmental concerns, mainly the emissions, emissions from the vehicle, not the making of it, from the vehicle. It's a zero emission, right? So that environmental concerns and greater range of heavy models are some causes. Like these are the main factor where the why it's growing rapidly. So we can say in the technology and advancement in the battery. So how the technology and advancement, we will go one by one about the technology advancement in battery and the government incentives, what are the incentives they've given, and charging infrastructures, how it's improved. Like one by one, we will go. Like you can say the battery technology, how it is improved. Here, many people have worked in batteries also, like electronics. Many people are from electrical background, so you guys know more about the batteries also. So where it's started and how, where we are in the battery technology. So basically, we started in the lead acid batteries. Yeah, yeah, right. Still, it's exist in the IC engine vehicles. So why they are still the people are using the lead acid batteries? It's cheap. So and the main thing is there are many disadvantages in the lead acid batteries, like low charging cycles, and it will be huge. So these are the main disadvantages of that. But from that lead acid batteries, transition happened in 1980s or 1960s to the nickel cadmium, and it moved to the nickel metal hybrid. Then it moved to the lithium ion. Lithium ion, they were it started in 1990s. They researched about the lithium ion in 1990s. So it was slowly developing, and it was used in by many companies, many in different purpose. We can say in the pouch cells, like in a battery packs, lithium polymers they use. So those kind of small improvement it happened, and when the automotive industry decided to move towards the EV side, so it has the rapid growth because of the chemistry. What the lithium ion can give that any other chemistry doesn't give. But it can give. It's still in the research phase. This is the proven stage. Like there are many chemistries we can say nickel, like NCA, NMC, lithium polymer we can say, lithium LFP we can say. Like there are many chemistry, and these each chemistry is specific for each purpose. Like LFP, if you go for LFP, lithium ferrous phosphate, like you can use that of kind of chemistry, lithium ion cell, in low range vehicles, like because its charge rate also less, and the energy density of the cell also less. It gives the less range, but charging cycle of the vehicle, life cycle of the vehicle is high. So you can use that kind of cells in small mopeds. In mopeds, now they use LFP because its price is very less, and it can withstand life cycles, longer life cycle. But the main problem is the charging will be slow, and high performance you can't expect from this batteries. So each purpose, if you go for NMC or NCA, those nickel, cobalt, magnesium, and nickel, cobalt, aluminum, like those kind of uh, chemistries. So you can use those kind of chemistries for the specific purpose called high performance sector. So that specific sectors has a the battery cells can give high performance, but it can do the charging rate, the charging speed also. But the life cycle of the batteries will be very minimal. If you can say the LFP battery can give 3000 life cycles, this NMC battery or NCA battery can give 700 life cycles. So that is always a trade-off in the battery technology. So yeah, you have to choose what you're going to use, what you're going to do. According to that, you have to choose the chemistry. So like that, the battery technology is improved. So what purpose you're going to use? For that purpose, you can choose the what chemistry in the lithium ion itself. So like that, the battery technology is improved, and so because of that, the many automotive companies and many peoples are adapting to that technology. Can we use other than lithium ion? Ah, yeah, it's possible. You can say like there are many other than lithium ion, like sodium ion batteries. It's in the research phase, the sodium ion batteries, and one more batteries also. Wait, I researched it, so I written it. I will tell you which batteries it is. Sodium ion, potassium ion batteries. So, and there are the supercapacitors are coming up. There are supercapacitors are huge, but it's also coming up. So there are lithium ion supercapacitors also coming up. So the lithium ion supercapacitors are high energy density, like the weight will be very less and the size is also very less. But the charge rates and the discharge rates are very high. Why people chose supercapacitors is, but I just give the overview what is supercapacitors. Okay, so mainly why people choose the supercapacitors is charge rate and discharge rate. Yeah, and the charge rate and discharge rate, no lithium ion can match that. Like it can go till 1000 C or 100 C like that. Depends on the supercapacitors what you use. Let's take lithium ion alone. Okay, so if you take lithium ion, there are number of chemistries. I will take three examples chemistries. Okay, LFP, lithium ferrous phosphate, and NMC, NCA. Okay, so LFP is the low energy density. Low energy density means it's nothing but it can store less energy only. For the size what it given, it can store less energy only. But this can withstand high life cycles. Life cycles means how much year it can come, how many charge cycles it can withstand. Okay, this NMC and NCA, right? So this has high energy density. This same size cell can withstand more energy. It can store more energy, so it can use more range, basically. So, but the charge cycle and discharge cycle and life cycle of this battery is very, very less. This LFP charge cycle, we can say 3000 cycles. This NCA NMC charge cycle will come around 1000. So that will be a trade-off. So for low performance, like not the high speeds, like 40 kmph vehicle, 50 kmph vehicle, 70 kmph vehicle, speed vehicles, you can choose LFP. They are choosing LFP only. And for 150 kmph vehicle, 200 kmph vehicle, in cars, they use different batteries. Titanium batteries also come up. But in bikes, high performance, 250 kmph, 300 kmph, those kind of vehicles needs only high performance, not the charge cycles. So they are not the life cycles. So they choose NMC, NC. So based on this only they choose. Like it depends on the manufacturer how they pack the batteries. Okay, we are using 800 volt system. It's a high voltage system what we are using. No one is doing other than a cars in India. I don't know whether cars also doing 800 volts now. They have started it now, I guess. So we are doing 800 volts. We can do 400 volts also. So and the DC voltage, it depends on the manufacturer how they pack the batteries. So it's not depends on the charging environment, but the charging infrastructure mostly it has a 400 volts DC voltage system, but nowadays they are doing 800 volts also. CB, NMC full form, nickel, magnesium, cobalt. That is the full form of NMC. How to select system or battery voltage as per duty cycle? Like as per duty cycle means what do you mean? Duty cycle depends on the range or depends on the speed, depends on the high discharge rate. So many things are there. So I think this topics we can discuss, and this is the total technical topic. If we discuss too much technical topic here, right, other people won't understand that. But I can answer this question. I mean, low voltage or high voltage system. Yeah, low voltage, high voltage system doesn't depends on the battery. See, if you arrange so many batteries in series, like if you arrange so many batteries, like let's say if you have 1,000 batteries, you are arranging 250 in series. That series means in that adding up the voltage. So 250 means it will go to somewhere around 700 volts, 800 volt system. If you arrange that 250 in parallel means you will get the less voltage. So voltage, it's the add up of the number of batteries, series add up of batteries. So it doesn't depend like the duty cycle, high voltage system. Why they choose high voltage system, low voltage system is depends on the wires. If you want to use the low size wires and the wiring harness and all, like some people understand wiring also. I'm just mentioning that term. So some people knows about the wiring on. So like if you want to use the less size wires, you will go for high voltage system. If you want to use if you doesn't care about the high size wires, you can go with low voltage system. That's all. That is the difference. And the efficiency will be high in high voltage system. Low voltage system, the efficiency will be little low. That's all. So I think it's going too technical use. So this is the battery technology, how it's improved. Up to design for low torque and construction machine, high torque. Like torque is totally depends on the current. It's not totally depends on the voltage. So I can explain that in further slides, Shamshu. So I can explain this, how to decide voltage. I can explain that in the upcoming sessions. So it will be easy for you if you look into those slides. That will be easy. Yeah. Next, battery technology is clear. Now we will go into the government incentives. What kind of government incentives we are getting? Like the main famous incentives you guys know is FAME. So I think you guys know about the FAME, right? Foster adoption of manufacturing of electric vehicles and hybrid vehicles. This was the incentive which released by the government. So to promote the EV thing in EV industries in India, because we are mostly totally dependent on China's and other manufacturers. So if we want to be a solo, and if we want to be a OEM, we have to manufacture in-house. We can't manufacture in-house without any money. So, and if you make one product, you have to sell that product. And if you're making EV product, if you're selling that EV product, so it will be the high price. So that's where the government will come in and play a role. By give some money, they will give some money to the manufacturer to reduce the selling price of the vehicle. So, for example, if Ather price is now 1,60,000, so it might price around 2 lakhs or 1,80,000. So the government comes in and they given that 20,000 to the Ather and ask them to sell it for 1,60,000. This is how the FAME works and the government incentives work. Government incentives I just said for FAME purpose, but there are many incentives like grants they are giving to, if you are starting your own company, the government will give 20 lakhs grant. So to develop your own prototype or your own product. This kind of help the government will do, and they give 50 lakh after that grant. If you are in revenue generation model, revenue generation means you are selling the vehicle and generating the revenue. So if you are in that phase, the government can give the 50 lakhs grant, not grant, 50 lakhs loan. So those kind of many incentives the government is giving to trying to push the EV industry up, like to promote the EV industry. So, for example, if you can see that the EV market in the how the EV market in the India. So this is the global EV market and how it's growing. Like this is what I mentioned about the how the EV will take over IC engine. You guys asked, right? So here, this is the reason. Like and the globally, it's increasing gradually. It's increasing. So and in India, you can see the two-wheeler EV market alone. So it's it's not increasing that much in 2050, 25, 26, but in 2028 there is a huge difference. Because why there is a huge difference after certain years is many manufacturers invested so much of the technology on the technology, so much of the amount of the technology. They won't just like the transit to the EV. So they want to sell the technology, and after that they will transit to EV. So like that only works in the industry industry sense. So they are moving to slowly moving to EV, and they will be releasing and they will be selling. At 2028, mostly all the vehicles will be EV. Two-wheelers for sure it will be EV. Mostly every vehicles will be EV. And in the high performance sector, we it's choose. It depends on the people. They want the ICR, but normal sector. Commuter means normal the slow vehicles, right? Like 100 kmph, 120 kmph, 60 kmph. Those kind of vehicles, like even the two-wheeler transport purpose they use, right? So everything will change in 2028. So if there is a sudden transition in the EV market, so there will be the huge job opportunities. Actually, you can also see here, how the electric vehicle market is growing from 2024, 2025, 2028. It is steeply growing. So if there is a huge increase in the market, there will be a huge demand in work. You can see in the EV industries, they're expected to create 10 million direct jobs and another 50 million to 55 million indirect jobs. So there will be a huge openings coming up in all the sector, because many people are doing their own vehicle, building their own company, and you can see many companies are acquiring the many companies. So the environment is growing. So the as per the job opportunities, it's going to be a huge in upcoming years. Now it's also huge. You can't say we can't get the job, because now the all the here the industry is growing, and mostly everyone is getting the job in EV side. And if you guys build the knowledge good, and tried out your knowledge, and you have to work out your knowledge, and you can get the job easily in upcoming years, in upcoming days. So this is the just a graph which I did for our research purpose, like how the EV market is growing. So I shared that with you guys. It might be helpful, and it will give you a good understanding, how the job opportunities will be in future. Here, which I showed, right? The market of electric vehicle is growing quickly, and next 10 years it's predicted to grow even more quick. Electric car sales in the US increased. It shows about the sales, how it's increasing the electric, how it's taking over the market. It's explained about the problem. I just showed that graph for your easy understanding. How it's growing, the rapid growth, how it's happening, environmental awareness and the government incentives, like I mentioned, like FAME and the grants to the government is grants is for the manufacturer, FAME is for the people who are buying, and for the manufacturer itself. So this works like that. The government incentives works like that. Advancement in battery technology, like how the nowadays people are asking for faster charging, right? They, of course, no, if you are used to the 1 minute fuel up and 2 minutes fuel up, not even 1 or 2 minutes fuel up. So of course the people will think, why should I wait for another 40 minutes or 15 minutes or 1 hour to charge the battery? So it's the common thinking but we also have to see the price point of view also. Here you are going to spend more, here you are going to spend less. That is also there. Trade-off is always there. So, but now in technology is improving, and it's totally going to the next level. Like even I saw many companies, the battery cell what we are getting from certain companies, right? They are doing the for batteries for a racing purpose, which can charge and discharge in 100 C. 100C means imagine like it can charge in 2 minutes, 3 minutes, 4 minutes also. The full charge, it's possible to, it's already available. They are doing the proto in those kind of batteries and with those kind of vehicles. The full charge can be done in 2 minutes, 3 minutes in future. So it's possible totally. Diverse EV types, including all electric and plug-in electric hybrids. Like nowadays, the plug-in hybrids also it's growing, and it's very good technology also. Plug-in hybrids. So yeah, expanding charging infrastructure. Ah, yes, the charging infrastructure expanding. Like how it's expanding. Like I can show you guys the. So you can see in my screen, right? Like the electric vehicle charging infrastructure, how it's expanding. So before there are not many charging. What is AB cost? Only electric cars are made for racing purpose. No, it's not like the electric cars are only made up for racing purpose. It can also made for racing purpose. I mean, they are doing a proto with the battery cells. So it can charge and discharge in 100C. So that means it can charge it within certain minutes and certain seconds. So in future, the future, it's possible to charge it in 2 minutes and 3 minutes. So that's what I am trying to tell about. Not only not for a racing purpose. So the future generation batteries is coming up, and it can be reducing the charging time. Yeah. Here, the how the charging infrastructure is improving. So you can see, right, like from 2024, it's improving, like it's increasing steeply. The 2020 30, it's going for some heavy billion. So the why I'm sharing this is it doesn't matter to us like whether it's improving or not, but why I'm sharing this is if company is investing, if people is investing on a physical asset means the physical product, the charging infrastructure, charging stations, gas stations. If they are investing heavily on this kind of platforms, they won't allow other technology in the future to come up as easily. Like I mentioned, right? Like why the Yamaha or Suzuki or they why they don't have a capability to come into the EV sector or not. They have all the capability. Why they didn't come into it? Because they already invested so much money on their own technology, which is engine. So they can't lose that, and they come up here directly. And many factors are there. Some other factors also there. You guys also know about that. But yeah, these are the major factors. So if in the future they are investing so much on the charging infrastructures and the electric vehicles, electric motors, batteries. So they won't just leave that and they will come to the other technology easily. So for sure, next 20 years it will be the electric only for sure. So because the people are investing on it and they won't allow to change to other technology easily. So that is the main reason we can see. And here you can see the FAME, which I mentioned about how the FAME subsidies and the FAME incentives, how it's improving the charging infrastructure. So in the FAME one, you can see like while the starting of this incentives, the government planning to start these incentives, right, for giving incentives for charging technologies, charging providers. So at the time, in FAME one, it was 427 charging station. Now, because of this, many grants given by the government, many incentives given by the government. So it increased to almost 3,000 in all over the world. In future, it will go to next 1 year after, it will go to 20,000, 30,000 easily. So because it's growing rapidly, because of many incentives coming from the government side and many investments coming from outside also. These are the major reasons why it's the why the our technology is moving towards the EV. Uh, Global competitions among automakers drives the innovations. Yeah. Uh, Here is the major thing I want to discuss. Like, you know about the companies like Hero, Ather, TVS, Yamaha. Like they are not only competing with each other. They are only electric car. It is 99.8%. Yes. It shows like 1.8%. It is 9.8%. It's from official website only. Yes, like global automakers, they are introducing new technologies. Everyone is introducing new technologies. Aether is introducing new technologies. They Aether proved it actually. Even the normal people, can come up with one idea with the quality product, and they can achieve the market. They are the real example who proved it. So they started in around 2011 or something. I don't know the exact year, and they proved it. They are the second highest selling electric mopeds in India. They are selling monthly 13,000 units easily. So yeah, so these kind of companies. Then Ather major investor is Hero. Hero is also doing their own mopeds. So this competition and the collaboration, and Yamaha is doing, the Yamaha now acquired the most of the stake of River, invested on River. So this competition and collaboration and the technology sharing, this making the environment good, and we are getting the high end products out of it. So everyone is this now technology is not like before. Now India mindset of building a vehicle is not like before. Everyone is running to give new product. Everyone is running to give a satisfied product. So we are getting out good products because these people are investing their time and collaborating their resources, sharing their technology, and giving out our new products out of it, the high quality products out of it. That makes the electric vehicle market grow, basically. Economic opportunities. I already shared about the economic opportunities and the job growth in EV related industries. I shared how much the growth will be. Here, the challenges include the sustainable battery production and grid readiness. Yeah, this is the major challenge, and I think one person already mentioned about this. The how the energy, if there are more EV vehicles coming up, where we will get the energies from. So for that only I answered, there are many companies coming up with the renewable energy sources to supply the energy. We have a huge energy source, and many startups and many companies are working on how to bring the efficient energy out of it, efficient power source out of it. So there are many solutions coming up, many energy coming up, and we also have one service-based company. So we are working on one renewable energy, like wind turbine. We are working on. So how to make the excess energy, if the battery is fully charged up, and still the wind turbine is rotating, and the energy will go out in heat. It won't charge the battery, right? So at the time, what we will do to store that energy. So that is our project we are doing as a service project. Yeah, like we itself doing it. So many people are doing this as a own sole company. So many people are working for this project. So in future, many solutions will come up. We'll go to next slide. Key policies in EV growth. Yeah, here in the key policies, they mentioned about the expansion of electric vehicles, how it's expanding, and the faster adoption and the manufacturing of hybrid energy vehicles, the FAME scheme. That is the main thing what here they're mentioning about. I will explain about clearly about FAME in further slides. In This is the key policies what I mentioned. I mentioned about the FAME policies, right? This is the FAME policy, faster adoption on the manufacturing of electric and hybrid vehicles. It's launched by the Indian government. They launched two times, FAME 1 and FAME 2. This is to promote the sustainable mobility in India. So how they started is they started with FAME 1 with a 3 year subsidy program. For 3 years, they will give a subsidy for what are all vehicle they are selling in the market. But it has certain requirements like the power, the kilowatt requirements, and the price requirements. The price should be above 1,50,000. Like that, certain requirements are there. for the FAME 1 and FAME 2. So FAME 1, after the upgraded model, the FAME 2 were released. So and now it's going to be get over in the March or April. It's going to get over. And the government were discussing like they are planning to extend the FAME 2 for another 3 months to get more reach and electric mobility. So how it helps the FAME, how it helps is financial incentives. Like it gives the financial incentives. It helps the manufacturer also. It helps the consumer also, the customers also. They give according to the kilowatt hour. They give the incentives. It is available for cars, two-wheelers, three-wheelers, charging infrastructures, trucks, buses, e-rickshaws, everything. It's available. The incentives are available. And the main thing is GST. So for other vehicles, the GST is for other products, the GST is 18%, right? For this same vehicle, for electric vehicle, the GST is only 5%. So this is to promote. This will reduce the cost of buying, initial cost of buying, and this is to promote the electric mobility in the in the platform. So and the charging infrastructure development, how the charging infrastructure is developing. Also, I explained. And domestic manufacturing. This helps. The Spain helps the startups to come up and make a made in India vehicle. We don't have to depend on always the China's and Europe for vehicles. We are doing now many startups came up and we are doing ourselves the motorcycles and cars and everything. In future, in after within 10 years, everything will be made in India. Mostly everything will be in India. And the research and development supports like grants, like if you are developing some prototypes, they will give a grant of 10 lakhs or 20 lakhs. It depends on the grant. It will be directly given under any scheme by the central government. I didn't understand the question, Sabi. Yes, the research and development supports they give under the FAME scheme. Like they release the certain grant for the certain projects, guys. If you do this projects related to this project, they will give this grant, and you can do the use that money to do that product, and you can move further with that product also, like creating a company and doing that product as well. Sole product also it's possible. In real life, how it's helping the customers and the manufacturers. So if for the middle class people or for middle class persons, by reducing the GST and giving certain incentives, the starting like 20,000 in the vehicle price per kilowatt hour, some price will reduce, right? If it is reducing, it will reduce the overall cost of the vehicle what the customer is buying, right? That will add up some value to the EV industry. So the person will buy it and it will add up the value to the EV industry. So this will expand. So the market will expand. This is how the frame works. So key players in the EV ecosystem. It is provided by central government, the incentives. And the incentives for startups, that FAME incentives are from the central government. Key players in the EV ecosystem. There are many OEMs like uh, like Tesla, of course, everyone know about Tesla. They are the pioneer for electric vehicle. Like they started the electric vehicle thing craze in whole world. Before that, also many manufacturers did the electric vehicle, but the Tesla got the name out of it. So for because they are stand by it with the car, and Nissan, Tata Motors, everyone is moving forward to the electric vehicle. So and other big OEMs like only the not only the Teslas and few people. There are in India itself, like you can see the private. Dynamics. They are doing their own electric SUV, which is the premium and luxury version SUV they are doing. And many four-wheeler companies are coming up in India itself. Like new startups are coming up. And this OEM, right, the high-end OEMs, they are supporting them in terms of technology also. So, and they are taking some part of, cured some part of their stake also, and they are helping it out. So the infrastructure and this funding infrastructure, this OEM infrastructure, it's growing healthily to improve the EV segment and made in India thing in India actually. Battery manufacturers, industries like the Panasonic kettle that Tesla used. Now Tesla is doing their own batteries. And here, India, we can say Godi Energy, they are doing the own battery, like high performance batteries they are doing. So, like in India, also the battery manufacturers are coming up. In future, many people will come up, and manufacturers like Molisol, uh, Samsung, they're high performance manufacturers. Like I mentioned, right? They are doing 100C charge rate batteries and all for the future purpose, for racing purpose. In future, these battery manufacturers are coming up with many technologies, not only the lithium ion technologies. Like you guys also heard about lithium ion solid state batteries and sodium ion batteries, phosphate ion batteries. So these manufacturers and this many startups are researching more oriented this and want to bring up something unique and to reduce the cost also and give the performance also, give the life cycle also. So these people are working on it. Motor manufacturers, like yeah, there are many motor manufacturers like in India itself. Like there are in Bangalore itself. If you take you can figure out 100 electric motor manufacturers easily. So that makes the environment healthy, like, right? Like you can go for any motors. Like if you want the 7 kilowatt of motor, 7 kilowatt motor, you can go and purchase directly. If you want the 10 kilowatt, you can go to some other manufacturer. You can get it easily. And these peoples are combining together like many OEM like. You guys know about the BYD China vehicle and the Japan, the Honda. These people are combining together and to make the powertrain of the vehicle. So it makes the in engine they won't do. While making an engine combining for race engine they will combine, for a production oriented engine they won't combine. So for the motors they are combining and they are doing it and they are releasing good performance vehicles. Controller developers, yeah, you know about the controllers, the chips, what the IC chips, what they're using in the VCU controls, and many inverters, how many, the switches, what they are using. These are the people who are the major monopolies for this kind of switches. Yeah, real example of key players. You all know about the Nissan. Nissan started the company, Nissan started the Nissan Leaf, which is the full electric car. That is the car which started the mass production, like Tesla now doing the mass production thing. But Nissan is the first car which started the mass production and gives the view to all the people and the customers. Okay, electric vehicle can run on road and it can exist on road without affecting, and it's advantage to the people also, customer also, it's advantage to the society also. Nissan Leaf, LEAF, it's a old model like Nissan Leaf. They are the first one who released the production oriented vehicle. Yeah, now we are moving to the next topic. It will be quite interesting. It will be not like government incentives and those things. Like it will be quite interesting. This topic, basic block diagrams of EVs and working and how it works. So this is basically the architecture of vehicle, how the blocks motor is connected to the battery, and what else will be if a motor is there, battery is there, in middle what should be there. So this kind of things we will see it here. So product is not delivered, then there is no liability. If the product is not delivered, mm, they will ask, they will make you to deliver. Uh, I can't say beyond that. That's the thing. There is no liability. So you don't file any collateral to do that. So there is no liability. But they make you do it. They do the product. So that's the thing. So yeah, basic diagram of EV. And in EV vehicle, what are all parts will be there? So that's the thing. What we are going to see it in this slide. So what do you guys think? What are all parts will be there in the EV? Like the major parts, not the. I'm not asking about the suspensions, the steering wheel, or those things, tires, or those things will be common in IC engines or EVs. I mean about the powertrain. Powertrain means the power which battery gives to the motor and runs the thing. So what are the parts will be there? What do you guys think? Just put it up in the chats. DC to AC converter. What is called DC to AC converter? This is the major parts which is available in the battery oriented vehicle. The first thing is part of the vehicle battery. The main is the battery. Then you will have a motor. In between the motor and the battery, if it is a AC motor, battery is a DC voltage, DC out, direct current. So motor, if you are using AC current, AC motors like PM DC motors, like you heard of PMSM motors. So those are now AC motors. So asynchronous motors. So it has a three phase. So the direct current is a single line, single phase. So in between that, you need a converter. So to convert that DC motor, DC voltage into the AC voltage. So for that, you will use one device, one component called converter. So you name it, you call it as an inverter. So it will convert the DC voltage into the AC voltage. That called as an inverter. So you can say it as a power electronics. This all comes under the power electronics. So it's you call it this as a power electronics. So it's a called a you can call it as a controller or inverter. Both are same only. So then yeah, battery. Now we saw that battery, and you saw that electric traction motor. That is the AC motor. And in between that, you will need one inverter to convert the DC voltage into the AC voltage. For that, you need one inverter or controller. Both are same. Okay. Yes. Then you will there will be one DC-DC converter. Why you are using DC-DC converter? Can anyone can tell why you are using a DC-DC converter? Which motors are mostly used in EVs and why? It depends on the application. Mostly, but mostly the for this cars and high performance more than 50 kmph bikes and all, they use AC motors only because you can control the speed because you are using the controller or inverter in between that you can control the frequency of it, you can control the speed of it easily. So yeah, that is the one thing. And the maintenance and this reliability of AC motor is electronics that work on low current. We step up and step down. Okay, charge flow to the battery is for low voltage. Yes, what is the battery auxiliary? Yeah, I will tell you. The DC-DC converter is nothing but you are using this, you can say this voltage, this battery voltage and this traction motor voltage, this controller voltage is, for, let's say 400 volts. Okay. So you can't use that 400 volts for headlights. Headlights will be 12 volts or 24 volts and sensors will be 12 volts or 24 volts and the other things like you see that battery auxiliary, right? So in bikes, in cars and all, you will see one battery, 12 volts battery or 24 volts battery. That is the auxiliary battery. So that used for supplying power to auxiliaries like lights, sensors, VCUs, and other actuators, door actuators, many sensors and actuators. It will supply the power, this auxiliary battery. To charge this battery and to supply the low voltage current or voltage to the low voltage application, you need DC-DC converter. It will convert this 400 volt system, right? It will convert that 400 volt system to 12 volts. It step down the voltage from 400 volts to 12 volts or 24 volts. Yeah, this is the purpose of DC-DC converter. It will can use for charge the auxiliary battery also. It can use to supply the current to actuators or sensors, and mostly it will be used to charge the auxiliary battery in cars. Traction battery pack. Let's assume 400 volts. It's a 400 volts. Motor is 400 volts. Controller is 400 volts. So you need to supply voltage and current power to other sensors and actuators. So how you will supply that from auxiliary battery? Then how do you charge this auxiliary battery? You need DC-DC converter to convert. Yes, DC-DC. Now I explained, right? It can be 800 volt as well. Yeah, we are using the 800 volt system, right? 800 volts battery pack. We are using a DC-DC converter to convert that 800 volts to 12 volts. Yes, with a DC-DC converter is nothing but you can step up or step down the voltages. So here, why we are using the DC-DC converter is to step down the voltage. We are using it's the 400 volt system. The battery is 400 volts, motor is 400 volts, controller is 400 volt system. From that 400 volt system, we need to step down to 12 volt system. For that purpose, we are using DC-DC converter. Clear, right? And here there is a thermal system cooling. Thermal system is there. Onboard charger. Onboard charger here inverter is not used to change the voltage. Regenerative units, it's there. Regenerative units will be inside the motor itself. It's a part of a motor. So I will explain the regeneration clearly for this. No, regenerative braking not used for onboard charging. No, onboard charger is to convert from AC main supply to feed the DC battery. That is the exact definition of it. Yeah, that is the purpose of onboard charger. Like you have the AC outputs. Our house and all, it's a AC output, and then there are charging stations outside. It's level 2 charging stations. When I'm coming to the charging that topic, I will explain what is level 1, level 2, and all. But there are level 2 charging stations which they use AC supply. So from the AC supply, how you going to charge the battery? You need one a component for it. You need one power electronics for it. So that is the onboard charger purpose. Onboard charger has the different power out ratings, like a 3.3 kilowatt onboard charger, 6 kilowatt onboard charger, 10 kilowatts onboard charger. It depends on the power what you need, you can use, and it will charge the battery according to it. 10 kilowatt onboard charger charge faster. 6 kilowatt charge little less than 10 kilowatt, like that. Depends on the power rating, it will charge. And transmission is nothing but gearbox. In vehicles, you have a gears, right? So that is that transmission. And charging port. To charge the battery, you will have a charge port. There are different types of charge ports. We will be seeing that in tomorrow session about the charging ports. Yeah, this is the whole thing, the main components in the EV. Onboard charger, for example, you are charging your battery, right? You are charging your phone, for example. Your phone inside it will have your power output is AC. Your adapter, your plug-in adapter, right? So that you are getting AC. That power output socket is AC, but your battery, the traction battery is DC, DC voltage. So you have to convert that AC voltage into DC voltage. Basically, onboard charger, it's a rectifier. Inside the rectifier, you can say. So you have to convert that AC voltage into a DC voltage to charge the battery. For that, we are using this device called onboard charger. You understand the inverter, right? The battery is DC voltage and the motor is AC voltage. Middle, you are using the controller or inverter to convert the DC voltage to the AC voltage to supply the battery, the voltage and current. Like that, to charge the battery, it's just a reverse way. To charge the battery from AC to DC, so you need onboard charger to convert the DC voltage into a DC voltage. That's all. Here we don't need an alternator. Like the alternator or starting motor we use for start the engines and charge the batteries. Here you have a big battery itself. You just need a DC-DC converter to uh, supply the current like to 12 volts. You just convert that voltage into 12 volts and charge the battery. That is the easiest way to charge the battery. Power electronics controller. Yeah, power electronics controller is nothing but inverter. Like you will have a switches inside. Like the about the AC current and DC current, right? So this DC current, the DC voltage, the battery is DC voltage, single phase, one line, straight line. Motor is three phase AC voltage. So you can't supply the DC voltage to the AC voltage directly. You need one system in between that which can convert the DC voltage into the AC voltage. Yeah, right. So for that you are using a system called inverter. So it will convert that 400 volts battery DC voltage to 400 volts motor AC voltage. So this is the purpose of controller, power electronic controller. Yeah. Thermal cooling system. Thermal cooling system is nothing but radiator. In your vehicle, you will see the radiator at the front, right? And you will see the fan radiator. Thermal cooling system is nothing but the cooling system of the motor and the batteries. It will circulate the liquid around it, and it will circulate in the radiator and cool it. That is the thermal system. Thermal means cooling system. There is a DC station charging in this charging port itself, right? I will explain tomorrow. There will be two sections. In the upper section, you have to charge for AC. In the lower section, you have to plug in for DC. So if there is a DC charging station, you directly charge the battery. It won't go through the onboard charger. If there is only AC charging stations, it will go through the onboard charger, and onboard charger will convert that voltage into DC voltage and will charge that. This power electronic control is providing three phase. Yes, and that is the purpose of power electronic control. It will convert that single phase into a three phase. I can say that DC voltage into the AC voltage. The cooling system is used to cool the batteries, motor, and the inverter. And so at some time, if it is a high onboard charger, high rating onboard charger, there will be a cooling channels provided in the onboard charger also. You will pass that liquid in onboard charger. It will cooling system is mainly for battery, motor, and the inverter or controller in this picture purpose. To take out the inverter, we can put the DC motor, but the DC motor has many disadvantages like reliability, durability, and the speed control. In these vehicles, the speed controls are really important. So for that, those efficiency purpose, for those kind of purpose, considering all the purpose and advantages and disadvantages, AC three-phase motor is the AC motors are the best used for automotive purpose. If you can see in all the most of the vehicles, they use AC motors. It available till we are using 6.6 kilowatt. There is 7.2 kilowatt also. There is 10 kilowatt also. Above that also it's there, but we didn't look into it. Please explain about traction motors. Traction motor is nothing but a motor, electric motor. There are DC motors, AC motors. In the AC motor itself, there is a asynchronous motors, synchronous motors. So traction motors is a huge topic. We will explain that in different session. But traction motor is nothing but an electric motor which used to push the drive the vehicle. Yeah, electric. This is PMSM only. AC motor means PMSM motors. IPMSM also there. Induction motors also there. So you can use induction motor. Tesla, the first version used the induction motors only. You can use induction motors only. 10 kilowatt up to what voltage ranges? 800 volts. The which we saw is 800 volts. So 800 volts is available in the market. It means why traction is used for. Traction means we used for means like it's a name like if you traction means pushing the vehicle, so it's just a name to tell traction horsepower. Mostly before they used induction motors, but nowadays they are using synchronous PMSM motors only PMSM motors because um, you need nowadays the vehicles need high powers and high speed vehicles. So induction motors won't give that high power. So if it will give the high power means it will increase the size of the motors itself. So permanent magnets is the main source of creating the powers. So the synchronous motors, that is the purpose they are using to withstand the compactness and the high powers. Here, this is what we discussed, basic working principle, battery, what is the purpose of battery? Stores the energy in the chemical reaction. Electric motor, which converts the electricity to the rotational energy, rotational current. Inverter transform the battery DC into the motor-friendly AC. So this is the thing what we discussed. Torque converter is different, totally different. A torque converter is used for transmission purposes. Inverter purpose of the inverter converting DC into the AC and transmission. Like in electric vehicle, the transmission is not will be not be that much because electric motor gives more torque at the starting of the speed itself. In IC engine, you can't get the torque, high torques in the starting of the speeds. It will come around at the 5,000 RPM or 6,000 RPM like that. But in motor, you can get that top peak torques and all in starting speed itself. So that is the main advantages of electric motor. So for that purpose, the transmission, you don't need the transmission that much. You can use the less ratio to control the transmissions. Regenerative braking is nothing but motor which it's nothing but like if you break, will the kinetic energy will create, right? It will go into heat. Instead of going into heat, you use that to charge the battery. I will explain clearly the regenerative braking. So for this slide purpose, we will explain like this. For the to better explanation for regenerative braking, I will make a slides, but I will explain in interactive session. Why the return of investment is the main thing. I think it will be shared to you guys. I will have to ask the host. Like you can ask the your coordinator like whether it will be shared or not. I think it will be shared. Here, the running cost of electric vehicle, the return of investment. That is the major thing. The main thing when we go to buy the electric vehicle, the main thing comes into our mind is the initial cost. Initial cost, how much you pay to buy a vehicle. So, but when you see like the initial cost and the running cost of the IC engine, so always the electric vehicle has a more advantage. So for example, this is just an example. So the cost of IC engine vehicle, let's take this is a Tata Nexon IC, this is a Tata Nexon EV. So the cost of IC vehicle is 15 lakhs, around 50,000, and here it's 19 lakhs 30,000. So the mileage what it gives is 16, and the fuel cost is 101 rupees. So economy for this price, how much kilometer per kilometer, how much you are paying. So 6 rupees per kilometer you are paying. So here the range it can go is 320 and the battery capacity is 30 kilowatt hour. So the unit price to charge 1 kilowatt hour is 6 rupees, 6.1 rupees as per the I just got it from the website. So the cost of full charge is 180, around let's say it's 200 rupees. So let's say it's 200 rupees, the cost of full charge. So the economy per kilowatt per kilometer is we are spending 60 paisa, or less than 1 rupees. So we are spending. So gain what you how much you are gaining from IC engine to the electric vehicle. So you're gaining around 5.7 rupees per kilometer. So daily, for example, daily you are driving around 80 kilometers. So how much you save per day? You can save around 460 rupees. And per month you can save around 13,000 rupees. Yearly you can save around it's everything is ideal condition. It's not the real time. It's just the ideal condition. So yearly you can save 1 lakh 65,000. So vehicle cost difference. So you can the cost difference of this both vehicle is 3,79,000. So in the 2.3 years, like you can save this amount by running cost. So this is the thing. In just 2.3 years, you can get this. You can save the amount. So, so this is how they calculate the ROI, return of investment, and many people are based on this. Many people are buying the vehicles, the electric vehicles. So because of the maintenance cost, first of all, the maintenance in IC engine vehicles, the maintenance cost is too high, and in EV vehicles, the maintenance will be less compared to the IC engine, and the running cost. Yeah, I will share the Excel. It's not a problem. I will share the Excel sheet. I think I can share it now itself with this. I will share it with you this. Yeah, this is the return of investment, how the people will calculate, how the manufacturer will calculate to attract the people, I can say. Yeah, that's the catch. Like the battery change life and cost, that's the catch here. Like the battery change, you won't do within, you don't do within 5 years or 6 years. So, considering those costs, it will add up and it will. That is the catch, the main catch between the electric vehicle and the IC engine vehicle. Finally, you have to change the battery to something else. But the thing is, you can nowadays the thing is coming up like called recycling. You can give it for recycling the battery, and you get out some amount from it, and you can change the battery out of it. And of course, you won't change the battery; you will change the vehicle once the vehicle is done. So that is the main aim of the automotive manufacturers. Like they in ICE engine, you will keep it for 20 years, 30 years. But in EV manufacturer mindset is to make you to move to other vehicle, to buy other vehicle. That is the main catch of this kind of vehicle. They itself, after 5 years, if your battery will deplete, it won't shut off. Like if the now it says the 100 percentage, it goes to 50 kilometers. In future, after 5 years, in that 100 percentage, it can go 220 kilometers or 210 kilometers. When it goes to 150 kilo, 100 percentage, 150 kilometers in seventh year or eighth year, like that, you will give the company itself buy back your vehicle, and they do whatever they want, recycling it, they do whatever they want. That is the main purpose, main background story of these things. So yeah, that is the main background of EV, how they are planning to do it. So they won't talk about the battery change life and cost number. That is the catch there. Yeah, the main things like the advantages of this EV is cheaper electricity and less than the fuel expenses, higher efficiency when compared to ICE engine. The EV vehicle efficiency is around 85, above 85 percentage. Sometimes it go to 80 or 75, but mostly it will be around 85 percentage. But fuel ICE engine vehicles will be around 40 percentage. Max is 40 percentage, we can say. And minimal maintenance, brake savings. Like I mentioned, right? Like in IC engines, if you have to brake or the motor braking, everything will go into heat. So there is no energy saving over there. Yeah, there will be no energy saving over there. So here, what they do is for motor braking. I will explain what is motor braking. So motor braking, they will recover the energy from the kind of that waste energy, and they will charge it to the battery. So that is the brake saving what they are mentioning about. And the emission incentives. There are many problems using IC engine in future. Like for example, we can say in Europe, while I was there, like there are emission-based taxes. You know about the emissions, right? Euro 1, Euro 2, Euro 3. Now they are going for Euro 6D, Euro 7 is coming up. So based on if you are using Euro 4 vehicle, so for example in Indian based, it's when you are using BS4 vehicle, uh, your tax will be different when you compare to the BS6 vehicle. So, so the emission tax is there. It's coming up and it's already there and it's coming up to all over there. So that is that. Uh, that will they will increase in future to higher extent to you to move all the IC oriented vehicles to the EV. The government will do that. So to may play a monopoly or something. And a battery longevity, home charging is possible. Like you can do the AC home charge, and you can put it up at night and the sleep. After 7 hours, it will be fully charged like that. You can do. And the price is also very less in that case. And the charging cost won't fluctuate like petrol cost. So electricity cost won't fluctuate like petrol or gasoline cost. That is the main thing. Or we saw that as an example. Yeah.
Just a quick info, guys. Intellipaat offers electric vehicle course training. Through this course, you will learn vehicle fundamentals, battery technology, battery sizing, mechanical subsystems, charging infrastructure, and much more from the top 1% of industry experts around the world. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, the link of which is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of EV.
Yes. Introduction of major components. This is the thing what we are going to see. The major components is nothing but we saw, right? Like what are all the major components in the vehicle. Now also we saw what are all the major components in the vehicle. The same thing we are going to see here in the detailed way. So first we will see about, yes, what are the major components in the electric vehicle? Battery is a major component, motor, inverter. Inverter is nothing but the controller, and the charger, charging port, DC-DC converter. Wiring harness is nothing but the wiring cables, how it's arranged. Battery management system, it's come up with the battery. Charging port, charger and charging port. Display, it's nothing but the infotainment systems. And the communication system. Communication system is nothing but how battery is communicating with the motor. Like let's say motor, I want like your pedal, like you are the user input. You will you are pressing the pedal like 50% throttle you are viewing. So you are telling that from the pedal, like you pressed 50%, that will come to the inverter. Okay, 50% throttle is pressed. So that the input will be given to the motor and the battery management system. So the battery management will discharge that much power and it will give to the motor. So this and all is happening in the communications, right? So what kind of communication they used for to communicate each other? So those things and all will come under the communication system. So we will go one by one. First, we are going to say about the battery pack, and then we are going to say about the battery pack. So battery pack is the heart of the vehicle. Everyone knows in the EV, the battery pack is the heart of the vehicle. It's nothing but providing the electricity, electric power to the motor to run. So I can show one example in the battery pack. So you can see the cells, right? These are the cells that will be arranged. You see that battery pack inside. How it looks is it looks like this, and there are the battery packs with the pouch cells. Pouch cells means the flat cells will be there. But here we will just explain or discuss with the cylindrical cell. This is called cylindrical cell, and pouch cell will be the flat thing. In the you saw that in your mobile phones and all, there will be the battery one cells will be there, right? Flat. That is called the pouch cells or prismatic cells, you can say. So, so this is the battery cell. So this is the high power cell, and this is the low power cell. How we are telling this is the high power cell and this is the low power cells is depends on the chemistry. Each batteries, everything is lithium ion here. So in the lithium ion itself, there are different types of chemistries. So depends on the application, you will choose the chemistry. So just guess which cell you will use, this first cell or second cell, NCA or LFP for a high performance. The higher performance of the thing is NCA, because it can discharge high power. The NCA can discharge high power. That is the chemistry what we discussed. In lithium ion, there are the lithium ion cells. In the lithium ion itself, there are many chemistries like NCA, LFP, NMC. You can see the abbreviations later, but there are many types of cells. So based on applications, like what type of car you are using, what type of bike you are going to build. So based on the application, they will choose that chemistry. For example, if you are going to make a high performance vehicle, high performance means high speed vehicles, we have to go with NCA because its discharge power is high, and its storage also high. Per kg, it can store around 230 watt, but LFP, it can store only 140 watt. So if you want to make one battery pack with 1 kWh, you will need just a few cells of molecule. Like let's say you will be using only 5 cells of molecule, but here you will be using around 8 or 9 cells. Just a assumption. More than here you will be using 8 or 9, so it will add up the weight. So like that only you have to choose the cells for the battery pack. We will discuss clearly once we are going for the battery section, but this is how they choose. So yesterday we discussed about this, right? So I just want to ask question like how you will choose the for the particular application. But yeah, you guys answered it correctly. NCA full form is nickel, cobalt, aluminum. They use those three materials in this cell, so they named it like that. LFP is lithium ferrous phosphate. What is gravimetric? Gravimetric energy. It's the energy, how much you can store in the single cell. Like per kg, this NCSL can store 230 watt. That much energy, like a range, it can store. But in LFP per kg, you can store only 140 watt. So, for example, in NCSL per kg, if you are using, you can go for 5 kilometers. In LFP cell, you can go for only 3 kilometers. Similar to the water, water is nothing but power capacity, right? So MAH is the capacity you will mention in terms of units, similar to MAH. How many cells are arranged in NCA? It depends on the application, like how much voltage you are using. For us, we are using 18 kilowatt hour battery. Okay, so if we use NCSL and it depends on the voltage, and we want to use 800 volt system, we will be using we will be having the 230, 240 in series, and there will be parallel also. Everything you will learn in battery class because it's too in depth, and yeah, water, yes. So this is the thing. And this battery cells, right, it will be arranged in a pack like this, depends on the voltage and the current requirement. So if you want to have the 400 volts, the series will be more, the parallel will be less. So those kind of things will be there, but the battery pack will be arranged like this. So in the battery pack, uh, what are the cooling will be there? I mentioned about two types of cooling: air cooling and liquid cooling. In liquid cooling itself, there are many types of cooling, but we will just see the two coolings. Okay. So in this picture, in the slide, you can see the two cooling. Air cooling and liquid cooling. So in this first picture is there, right? Like I'm highlighting, if you guys can see that. So this can be done in air cooling. It can cool in air itself. Water liquid cooling means there will be a cooling channels. So you can see the two tubes at the top. There will be an inlet and outlet tube. The water will be the liquid will be passing one side and coming out of other side. How it will pass the liquid? How it will pass in between the cells? That you can see in this yellow color. That battery you can see, right? So this is the channel. The gray channel is there, right? The liquid will be go inside through this channel, and it go to all the cells, outer areas, surface of the cell. It will cool, and it will cool the inner surface also, and it will reduce the temperature. This is how this is how the cooling works, batteries. You guys asked before, right? Like the liquid cooling, how it will be working in EV side. So this is how it works. Yeah, gravimetric is nothing but how much the single cell can store the energy. How much energy can a single cell can store, so that it can give us a range power. So here you can see the gravimetric as a 230, and here you can see is a 140. So if this 230 watt per kg, this cell can give a power to the vehicle to travel for 5 kilometers, let's say, and this cell is there, right? 140 watt. This can give a power or energy to travel only 3 kilometers. So that is the gravimetric. The energy can store to give a vehicle to run in a single cell. How much it will store? So yeah, by inlet one, the cooling will be what kind of liquid major? They majorly they use water plus glycol. So they mix of two they use. And if you want, there are many coolings like immersion cooling. They will immerse the cells in the liquid itself. So in that case, they have to use this water and glycol and all. It's a conductive. It conduct the electricity. So you can't immerse the batteries inside the water in the liquid. So in that purpose and all, they use dielectric fluids, like those kind of fluids or the dielectric fluids. So it's non-conductive. It won't conduct electricity. So those kind of liquids they use. Yes. Shall we move to the next slide? Motor controller. Motor controller. This is not the picture of the motor controller. So motor controller is nothing but like we are using between the batteries and the motor, right? To change the DC voltage to the AC voltage. It can control the motor speed and torque. That is the it's like a brain of the brain for electric motor. So how much you from the throttle, it will be directly connected to the controller, and the throttle input will be executing by the controller, which is in between the battery and the motor. So the controller will decide how much speed, how much torque the motor should run. Basically, that is the purpose of the motor controller, and it will convert the DC into AC. Motor controller is will be not used for a DC motor. Controller, there will be a separate controller for a DC motor also, but that is not a inverter. That is different. So this is the you guys can see the screen, right? So this is the motor. If you can see, this is the motor. The left side of the thing is the motor. So this is the inverter. We can say as a controller. So the three wires is connecting to the motor. This is the three-phase one connected to the motor. This is how the controller looks. So in the vehicle, it's like this. In the bottom, the right side picture you can see. So in the bottom, it's the motor, and at the top of it, you can see it's the controller. So the controller will be, the wires will be connected to the motor. This is how the controller looks and how it's connected. So three wires is connected to the motor, and the two wire, the positive negative wire will come from the battery and connected to this motor controller. So there will be five wires will be connected to the motor and controller, and the water, the liquid cooling, the tubes will be. So this is how the controller looks. I just want to show how the controller looks. So I share this picture. Let's move to the next. And this is the electric motor. Everyone knows about the electric motor. So it's the motor which converts the electrical energy into the mechanical energy. So mechanical motion it will convert. And this the motors are used for the propulsion purpose of the vehicles. Yeah, there is a liquid cooling in the inverter. So because the high performance inverters are there, right? So it will heat up so fast. The inverter is nothing but there will be switches inside. That switch will convert it will fastly react, and it converts the DC voltage into the AC voltage. So that is the purpose of the inverter. So it will heat up when you convert that. It will heat up. So for that you need a liquid cooling. Yeah, battery to inverter, inverter to motor. It's the flow. It's correct. So this is the electric motor. Everyone knows about the electric motor, so I don't want to dive deep into it. The internal connections of the electric motor and what are the electric motors or that and all we will see in this session, because it will be too complicated if I explain now. That it will take at least 1 hour to explain so on. And this is not the inverter picture. So inverter picture I already showed in the slide itself how it looks. So and you guys asked about the coolant, whether there is a cooling connection or not. Right? You can see these two tubes in this. I can show. You guys can see these two tubes, right? So this is the coolant tubes, coolant in and coolant out tubes. So and this is the three-phase ones. And there will be two wires which will be coming from the battery and connected to this inverter. So battery to inverter, inverter to the motor. That is the flow. I hope it's understand now. I guess. Yeah. Yes. About the liquid cooling, how the liquid cooling goes in and out also, I showed. Uh, it's clear, I guess. Go on next. DC-DC converter. I already explained what is DC-DC converters. So it will convert the high voltage battery, high voltage into a low voltage system for lights and electronics for those purposes. I hope it's clear for everyone, I guess, about the DC-DC converters. So I can show a slide about that also. Yeah, this is just a flow chart. I got it from the online. So how the DC-DC converters will be there located. So you can see the high voltage system and the charging station. You will charge the battery. So this is the AC charging. So you charge through onboard charger. Okay. So AC charging. So it connects to the high voltage battery and this charging. And from the battery, it will directly go to the motor. The inverter will be there and motor is there. So and it will also directly go to the DC-DC converter. So why the DC-DC converter they are using this? To give the power supply to the low voltage. LV loads means low voltage systems and low voltage battery. So for this purpose, they are using the DC-DC converter. I hope I showed in this slide also, it's clear, I guess. Wiring harness, I never came into that. So I will explain that for sure. I will explain that also. In the next slide, I will explain about wiring harness. So DC-DC converter, I hope everyone clear about that. Yeah. So DC-DC converter. Then here we are coming about the wiring harness. The wiring harness is the network of wires, like is the wires connected between the all the electronics for the communication purpose, for the power supply purpose, for the grounding purpose, for many purposes. It will connect in between the all the electronic ports. So I will show one picture how the electronic wiring will be in the real world cars. So I can show. Yeah, that is, you will have some DC-DC converters in the rectifier in the this thing in the inverter. So it will, you need a DC, the rectifier to charge the batteries also. So you will have a regenerative braking. Okay. That regenerative braking will supply the power to the inverter and the inverter will convert that AC to DC. For that, you will need a rectifier. For that purpose only, they mentioned the DC-DC over there. So it will convert that and it will supply to the battery, which for regenerative purpose. So only don't confuse with that. So just imagine that is a traction inverter. Uh, just imagine that as an inverter alone. I will explain clearly why they mentioned DC-DC. That is a different class that needs a big explanation. So it's not a big deal. Like imagine that as a traction inverter. That is why they mentioned that DC-DC over there. It has a certain meaning. I will explain about that. It is only for the regenerative purpose. So don't worry about that. I will explain. So I will share the wiring harness picture, how it looks like. So here, this is how the wiring harness will look like in the real time car. Like you can see the low voltages wires and the high voltages wires through the system. So everywhere, every company working really, really hard to reduce this wirings because it's complicate the whole system and it will add up the weight And if some malfunction opens also, it's very difficult to access and repair it. So now mostly they reduced all the most of the wires, they reduced it. So this is how it looks, the wiring. And this is the high voltage. The right side picture, you can see the big wires, right? That are those cables and all. It's a high voltage wires. You can see that high voltage wires. So this is how the wiring harness will look. The wiring harness, the purpose of wiring harness, it will use for communication purpose. You know about the CAN communications and all that, right? So for that also you need wire, like CAN high and CAN low wires will be that. So you need that, and there will be a low voltage wires. There will be a high voltage cables. You need for communication purpose, power supply purpose, and grounding purpose, and analog signals basically. So for those purpose, you need the wiring, and it will be connected like this only. Yeah, it will be in different code, but for just showcase for purpose, I just put it in this picture. Yeah, there are some regulations you have to follow. Like for high voltage wires, I know certain regulations for the wirings. So like if the wire, the high voltage wires, you have to make sure you have to give certain radius to bend the high voltage wire. Depends on the square of the cable. Like that, there are many regulations. That is totally different. Yeah, communication means the CAN communications, LIN communications, and Ethernet communications. There are many communications out there, right? For those also, you need wires to communicate. So yeah, that's it. So this is the wiring harness. So yeah, battery management system. This is the biggest topic in the whole EV industry. The overhyped version, like battery management system. Like if you guys are planning to start your career in the battery management system, you guys have to know more about the battery architecture, how it works, and how you guys have to know about the algorithms, logic algorithms, those things and all you have to study. That is a totally different topic, reading and studying about the algorithms, but logic you have to learn. So battery management system is nothing but it monitors and manages the battery. It will monitor everything like a thermal or cooling systems of the battery, how the cooling works in the battery. So that is called the thermal management system, we can say. And a state of charge, state of health of the battery, and balancing of the battery, active balancing, passive balancing. So there are many things inside the battery. It has to the battery management system has to do to safeguard the battery, to give the efficient output. So that is the main work of the battery management system, to safeguard the battery, to give the efficient output from the battery. So this is the main normal layman terms we can say. And I can share my screen and you can see the architecture, just the basic architecture. You can see how the battery management system is connected. So this is how the battery management system, just a basic, very basic architecture. This is the battery pack. So you will get the from the sensors, you will get the thermal how heat it is, that from the temperatures you will get the how heat it is. Those things you will get the information. Current you will get the information. Voltage you will get the information. From that you can from this measurement you will do the battery management will do this work. So like a cell balancing, and how much is the state of charge. State of charge means how much the percentage of charge. You will see in the battery, right? 100%, 90% battery, 80%. That is the state of charge. And state of health. What is the battery health? If you go and see in your phone, you will in iPhones, in many phones, you can see the health of the battery. Your battery health is 95%. It's not a state of charge, I am telling, the battery health. So in after a few years, it will go to the 80% health. So health of the battery, thermal management, how the cooling works, and it will guide, it will estimate, it will calculate and do the cooling for the battery. So those kind of works and all, it's done by battery management system. Is everyone clear with the battery management system, or if you guys need any more questions in? is any circuit diagram for high voltage wiring in EV? Yeah, I can share one system. After this slides, I will share my own company high voltage, how it's connected. So I will share that to make you understand. CAN bus control is nothing but it's a CAN communications. You have to communicate this everything with the vehicle, right? Like for the VCU in the infotainment system, you have to communicate. Okay, if the battery temperature is high, you will get that from the BMS. From the BMS, you have to communicate to the driver or rider what is the temperature. So for that, you will have that communication. So CAN communication is the used to communicate from this to that in the high speed. So I will explain about the CAN communication in the further slides. So you guys can understand. Cell balancing means there are two types of balancing, like active cell balancing and passive cell balancing. So when you charge the cell, not every cell will charge at the same level. Okay, there are like 5 cells arranged in next to next, and not the 5 cells will be charged in the same manner. Like not everything will be charged in 50%, 60% in the same level. So first cell will be charged to 70%, second cell will charge to 60%, third cell will charge to 80%. So to balance this to the equal level, they do one algorithm called cell balancing. It will take care of this. Thermocooling, yes, thermocooling, yes. You will get the temperature output from the battery pack, and it will measure, and they will do the BMS will take care of the algorithm part. Algorithm means the logic part, how to tackle this temperature, how to reduce this temperature, like that, and all. It will pass the liquid according to it. So like that, it will work. Charging and discharging while doing, it depends on applications. That is a different study. You can there is two balancing technique: passive and active. Passive, what they do is if there is a different percentage in the cells, and if one cell achieve the 100%, if the next cell doesn't achieve the 100%, still the 100% will get charged, right? That the charge will reduce released as a heat to the environment. So uh, that is passive cell balancing. Active means it will analyze the each cell, like how much percentage it's charged. So it will transfer that one cell is charged to the 100%, let's say. So no, from this 100%, it won't charge anymore. It will give to the next cell. So that is costliest version. So no manufacturer, not that much manufacturer will opt for active cell balancing because it's costly. So mostly they will do passive cell balancing, just release to the heat. Please repeat the diagram. Yeah, the diagram is nothing like you will see the battery pack, and in this battery pack, the BMS will be connected. This battery pack, what will do is it has many sensors in it, like temperature sensors, current sensors, voltage sensors. Many sensors will be there. It will give that information to the BMS, and based on the information, the BMS will work out all the data. Like there are many data like cell balancing, it will work out. State of charge, it will work out. State of health, it will work out. Thermal management, it will work out. Based on that, the output will given to the like HMIs or VCUs, or if the output, it will change the battery like according to it. If the temperature is high, the thermal management will work out, and it will give the liquid to the battery pack. So this much flow rate it has to maintain to cool it. Like that, it will give information will be given, and the pump will flow the liquid to the battery pack, and it will reduce the temperature. That is the purpose of the BMS. So that is the one part of purpose of the BMS. Like that, it will work it out. So this is BMS. We are going for a charging BMS on charging port of EV. So charging ports. You guys saw many charging ports in India, right? So what kind of, why they are using the charging port basically? The charging is used to charge the battery. there are two types of charging: AC charging and DC charging, and there are number of levels of charging. So AC charging is nothing but from the household, from the uh, you can say in the many stations in India, like AC charging stations, they will do the AC chargings. DC charging is nothing but you will directly charge the battery. AC charging, you need onboard charger or some type of converter in between that to charge the battery. So there are two types of charging station, we can say AC charging and DC charging. So and we will look into this charging thing even deeper in after the two more slides. There will be a separate topic for charging itself. So we will look into that in that topic. We will explain clearly in that. Display and communication systems. So display is nothing but the infotainment system you will see in the vehicles, right? So next to the handlebar, next to the steering, you can see the screen, those kind, and the RPM vehicle kilometer showing screen. Those and all, it's the infotainment systems. All yes, it depends. All vehicles are suitable for both charging. Battery can be only charged by DC. Okay. So if they have onboard charger in the vehicle or some kind of converter in the vehicle, so you can do the AC charging. If they don't have any converter and you are not using any external converters or anything, you can only do the DC charge. No, both are not done through the same port. I will show that in the upcoming slide, what ports they are using also. Clearly, I will show that. Here displays the infotainment system interface between the driver and the vehicle. So, and like in the before slide, I mentioned about the battery management system, right? The CAN, you saw that CAN communications. Why you guys also asked why they are using the CAN thing over there. So it's nothing like the BMS will communicate to the, it has to show in the infotainment systems, right? Like what is happening in the battery. So for that, the communication they use is CAN. So that will communicate to the infotainment system or VCUs, vehicle control unit. Like that, it will communicate and it will show to the rider. You can see here, it provides the information such as speed, battery level, range. So those things and all will be seen in the displays or infotainment. How it is communicating is through CAN or LIN or some kind of communications they are communicating among those players. What type of communications related to battery will be there? There are many communications. In very low level vehicles, you can see the range, battery level, state of charge percentage. You can see how much range the vehicle can go. You can see, and in an advanced vehicle, you can see everything. What is the battery temperature? And which cell is affecting in the module. There will be a number of modules in the vehicle itself, in the battery vehicle. So which area the battery is affecting, even that also you can see in the high-end vehicles. So many things it will communicate to the vehicle control unit and it will communicate to the infotainment systems. So here, introduction of communication systems. So like I mentioned, communication system is nothing but the components has to communicate with each other. The electronic components has to communicate with each other to control and to tell information to the rider. So what are the types of communication they are using? I will share my screen. So these are the communication a system commonly used in the vehicles. Okay, nowadays vehicle, these are the communications used in the vehicles. Depends on the application, they choose the communications. Okay, so the you guys have heard the name CAN. I hope everyone here the name called CAN, Controller Area Network, called the communications. So this CAN communications is the majorly used in the all over the world. Like CAN communications, LIN also is used. Nowadays they are using Ethernet communication. Ethernet is nothing but the you are using the Ethernet cables, right? Those kind of communications, but the cable will be little different. So, and FlexRay, this is the one type of communication system. So these are the communications protocols under the communication system. So you can see in the centralized zone and architecture in the right side picture, you can see, right? This is the advanced architecture the vehicle is using. Yeah, I will explain what is the use of Ethernet in the vehicle. FlexRay also I will explain. Not the too detailed version I will explain. I will explain why they are using FlexRay, those kind of things. So you can see here the centralized and the zone architecture. Yeah, right. So this is the architecture used in the nowadays cars and the future cars or nowadays cars they are using. What is architecture means? How they place the electronic units and how it is communicating to the your VCU, your computer. In each vehicle, there will be a computer. Okay, that you can call it as a control electronic control unit, ECU or VCU, you call it, right? So that is called the computer. We name it as a computer. Let's say it's a computer. So each vehicle has a certain computers. So how it is communicating with all the sensors and all the actuators in the vehicle. So let's say here you can, in this picture, you can see the central brain, zonal gateway. There are four zonal gateways. Let's say that phone zonal gateway is the also the computer. Four computers on the each location. So this zonal gateway, right? So each zonal gateway or each VCU, that is, we can say each computer will take care of that particular location. What are all systems? What are all electronic components? What are all the sensors? What are all things or the electronic systems or that this particular zonal gateway in that particular area will take care. Okay. So how it will take the zonal gateway? So how it is communicating, like a zonal gateway, it is communicating with red dots, right? There is line going to the red dots. So how it is communicating? For that communication, they are using CAN or LIN. Mostly they use CAN. LIN is the low speed version. CAN, when compared to LIN, CAN is a high speed version. So they use LIN or CAN for the communication. It will communicate this red dots and the yellow dots. It will communicate to the zonal gateway. That is one computer. It will communicate to the zonal gateway. So the zonal gateway, that is one computer, has to communicate to the central brain. Okay, right. So how it will communicate? So you can communicate to the through CAN communication, some kind of communication called CAN communication, or you if you need to communicate in the faster way, like in high speed, I want to communicate, very high speed, I want to communicate. So on that purpose, you will use Ethernet cables. So Ethernet cable is the high speed cables, right? So you will use that cables to communicate. So it's just a communications like you have to do for which purpose. Like if you are using medium speed or somewhat high speed you need means you can use a CAN. If you just want to do the low speed communication means like infotainment, some like a mirror adjustment, like those kind of things, you can do the link communications. That is a little bit low speed. And if you want to communicate in very faster manner, like very high speed, you will use the Ethernet communications. If you want to use the FlexRay, FlexRay is the costliest version. So they will use this FlexRay for some purpose only. Okay. So uh, at what purpose and all the FlexRay they will use? The FlexRay, this is one type of communication they will use. What purpose they will use is for ADAS, like you know about the blind spot detection. You guys know about the blind spot detection, autonomous vehicle, automatic driving, those things and all, you know, right? For those kind of applications, they use FlexRay. Those kind of communication protocols they will use. This is the basic idea of communication and what purpose they use what communication and where are all they are using the communication. Just an overview. I just want to, you guys have to know about just the overview of the communication, how it's communicating, because I am totally working on this part of the vehicle. So I just want to you guys to understand what is communication. So I explained this communications and all you guys won't learn in this this is the higher little higher studies, so we'll learn in after a few other sessions. No, nothing is wireless, everything is wired only. Wireless is not speed. You won't get that much speed in wireless communications, everything is wired only. In cars and all, you have to communicate very fast manner, and you have to send crores of messages every time. So for that, wireless you can't do. So wireless communications and all you can do, like you have a tire pressure monitoring sensor, right? And tires. So you can do you can do that wireless communication. So like that you have to prioritize, and you have to choose which communication, which part has to be done. So center brains or the electronic control unit. Even the zonal gateways are also the electronic control units only. So it's a control units. Yes, everything will be connected to the GPS, and everything will be connected to the cloud. The gateways, or you can see, right, that will store and that will send to the cloud, or you can store and send to one particular. In flights and all, you will see the black box. So all the information stored in the black box, right? Like that also you can store. Flex-ray communication is high-speed communication. It's a high speed than CAN communication. So that is why mostly in automotive cars and all, they are not using the flex-ray communication is because of the cost. The cost of the flex-ray is high, so only they are not using that. So like automotive world, they use this kind of communication for some purposes alone, for ADAS applications. You know about ADAS, right? Automotive driving, blind spot detections, autonomous driving. um, like there are many autonomous driving and automated driving applications are there, right? So for that purpose communication they use FlexRay. So it's little higher speed than CAN. I guess communications, you guys had some idea what is communication, how the vehicles are communicating with each other. I guess you guys have some idea, I guess. So I will move to the next slide. I don't know about the interior, why it's costly, what materials and all they're using. So those kind of things you can research on your just search, you can research. But this is the basic thing. In further sessions, we will discuss more into. I don't think so. Communication we will be discussing as soon as possible. It will be coming in later sessions. Communication is a bigger topic, very big topic. So that we'll discuss later. Let's move to the next slide. We will see the topic of charger, charging points, how the charger port looks like, how it works. So we will see the topic in this session, in this few slides. And after that, we'll see, I will showcase just the MATLAB model. Because the end of this slides, right? A few slides related to MATLAB will be there. Why you are using the MATLAB and those things and all. I will showcase I made a model for you guys. So I will just showcase that, how it works and all. Okay, we are going to see about the chargers and the charging type. So uh, there are two types of chargers, AC charger and DC chargers. AC chargers, we have to use one control unit or power electronics unit in between the battery and the charger to convert that AC into DC. DC charger, we can directly plug into the port and it will directly charge the battery. This is the concept between the AC charging and DC charging. So everyone is clear about that, I guess. So here, next slide. So there are the types of levels of AC charger, AC and DC chargers. Like let's say the level one chargers. The level one chargers are normal household chargers. Like in the household, there are 20 amps chargers. You can see the 20 amps chargers in the house. The red one switch will be there with the red highlight. So those kind of sockets you use for the chargings. Yeah, I will repeat. There are two types of chargers, the AC chargers and the DC chargers. Okay, AC charging is the normal. In household, you can see the charging ports. Those things are the AC chargings. DC charging, you can see in the outer charging stations, like big box will be there. So that is the DC charging, which will be directly connected to the battery. The port will be directly connected to the battery. So there are three levels of charging. Level 1 charging, level 2 charging, level 3 charging. Level 1 charging, and you can charge it from the port. And in between there will be a charger. In the laptops, for example, we can take the laptops. You will connect the adapter to the port, and in between one box will be there. That is the converters or those things charger, and it will connect to the vehicle. So this is the slow charging. Level 1 charger is the slow charging. It will take at least 8 hours to 10 hours to charge the battery. If your vehicle is around 10 kilowatt hour battery capacity, so it will take at least 7 to 8 hours to charge the whole battery. So if you want to do the charging from house, you can do this level. You can do the level 1 charging. Level 2 charging. What is level 2 charging? Level 2 charging is the AC charging. You have to do little bit faster charging from the AC charging itself. So in you can see the in the Aether showrooms and in mall in some high-end restaurants, in high-end malls, in the parking lots, you can see one charging ports, AC. It's called a level 2 charging AC, level 2 AC charging. You can see in this picture itself, there will be two small boxes, like green small box and gray small box. This and all AC chargings. So it will take at least 3 hours to 4 hours or 3 hours to fully charge the vehicle. So it, you can save the little bit time over it. Next, level 3 charger. The level 3 charger is the fast charging. That is the big charger. A separate charging station will be there for that, and the box will be very big. And you don't need any converters in between the charging port and the battery. So there will be a charging port, and it will be directly connected to the battery, and you can charge. You can charge the vehicle, like let's say the 10 kilowatt hour vehicle. Depends on the DC fast charging station. Like there are 20 kilowatt fast charging station, 50 kilowatt fast charging station. So if it is a 20 kilowatt station, you can charge the vehicles, the DC by DC charging. You can charge the vehicle in 30 minutes or 40 minutes. It's full charge. The 10 kilowatt hour battery. So I can show you I can show you my slide, so it's easy to understand. So okay, here you can see, right? What is the difference between AC charging and DC charging? So AC charging, you can see that small charger. It will connected to the car. In between the charging port and the battery, you see that onboard charger. So you need, if you are going to do the AC charging, you need onboard charger in between the battery and the charging port to charge the battery. If it is a DC charging, you don't need the onboard charger because it's a DC. The battery is also DC voltage. You can directly connect to the car and it will charge the battery. DC charging is fast charging. AC charging is slow charging. So if you see the right picture, the same picture itself. So the first you can see the port from the house, or level 1 charging we can say from the house. From this you can connect, it will connect to the onboard charger, and from the onboard charger the battery will be charged. That is AC charger. So every vehicle has an onboard charger, limited power and slow charging is the AC charger. DC charging. DC charging will have one separate charging station. So it will be directly connected to the battery through the port in the vehicle. So it's a large power rating and fast charging. So it's high speed charging. So it's called DC charging. So for example, this is the 3 levels I mentioned. First is level 1. From the house, you will have one charging charger adapter here in between that, and you will charge the vehicle. Second is level 2 charging. You will have a whole unit, AC charging unit. First you can see is the 120 volts. It will supply the 120 volts charging. Second is 240 volts supply, and third is a DC charging. It will supply 400 volts, 200 volts, 300 volts, but it supply the high current. So to do the fast charging, this is the three types of charging. Here, same. Does all vehicles support both and have dedicated ports? Yes. That is my next explanation. I will explain this. There will be a separate ports in the vehicle. We have to connect there, and it will charge. So, for example, the level first I will finish this level 1 and level 2, level 3. So how it works and types of EV charging. So level 1 charging, they will charge it in house itself. So for example, it's a slow charging. Per hour, if it is charged, it goes 2 to 5 miles only. So if you are in the home, if you came at night and you can put the charging, and morning you can take that out and you can ride it. Level 2 charging, per hour, it will charge up to 10 to 30 minutes. So it's first level 1 is 120 volts supply. Level 2 is 230 volts or 240 volts. Level 3 is the DC fast charging. This is a very fast charging. So per hour, you can give the miles of 150 to 350 miles. So it depends on the power rating, what the station. It might be the DC power station is 20 kilowatt, 30 kilowatt, 40 kilowatt. There are 150 kilowatt, 300 kilowatt also. The stations are there. Depends on the power, it will charge. So that much speed it will be there. So this is the basic of charging stations. Here you can see the real-time charging station. This is the AC charging, level 2 AC charging stations. This is also a level 2 AC charging stations. So this is the DC charging stations. See how big it is. So this is the DC for fast charging stations. So this is how it looks. So level 1 chargers, which are standard household output, like the 120, 110, 120 volts, providing slow charging. So convenient for overnight chargings and those things. Level 2 is the 240 volts output. You can see it and you can fix it in the house also. You can fix it in you can see this kind of stations mostly in public stations, malls, and everywhere. So in companies and the parking lots, you can see that is the level 2 charger. So level 3 is the fast charging station. You will have a separate charging stations for fast chargings. So it is a little big stations. So you will do fast charging. So these are the three levels of charging stations. So yeah. Now we are going to see what is the connector types. What are the different types of connectors? So you now you see the stations how we are going to charge the vehicle, but now we are going to see the how what are the connectors in the vehicle, like how the connectors looking in the vehicle. We have to see. So AC and DC are not charged through the single port. That will be a two separate sections we can charge. I will explain in this upcoming slides how it will be charged. So there in before like way before and all, like there will be a separate they followed like a separate connectors for separate areas. Like Tesla has their own connectors, and in Japan and North America they follow J1772, and we follow like India, they follow CCS2, CCS1, those kind of charging models, connectors they follow. So nowadays, everyone is commonizing the charging stations. Like in North America and the US and all, everyone is going following the Tesla's charging stations, and here everyone is following CCS2 charging stations. So that CCS2 Tesla charging, those things are now its port. How the port looks like. So that's what we are going to see here. So types of connector. This is type 1 J1772. Type 2 Menicus. Menicus is from Europe. They follow this type of connector. CHAdeMO. This is type of connector. CCS2 combined charging system. This is one type of connector. So I will show you guys how the connector looks in this upcoming slide. I have one separate document for it. Yeah, battery life and charging speed has a great connection. there will be the batteries, while you're purchasing battery and battery pack itself, they will mention the charge rate, how much rate this vehicle has to charge. If it is charging in the higher rate, the battery life will go off. You can't charge in the higher rate. If it is charging in the very higher rate, the battery life will go off. So if you maintain the very low rate charging, the time will charging time will extend, but the battery life will be there. So it has a great proportional connection. So you can say. So here in this slide, so I hope this slide is visible about the connectors. It's visible, I guess. So these are the connectors. Yeah, these are the types of connectors used in the course. So these documents, we made it for our company purpose. So I just thought I can share it with you guys how the connectors will look. This is the connectors used in the vehicles. Depends on the locations. For example, J1772 Type 1, J1772 Type 1. This kind of charging port types are used in the charging port types means um, in the vehicle there will be a port, charging port, right? So you will insert that adapter to it. So that port. So that type, it's mostly they are used in Japan and North America. They use this J1772, and makers they used this type in Europe, and CCS2. It's commonly used everywhere, like Europe, America, and Europe, India. They are using this type of connectors. And Tesla, they have separate types of connectors. So this is the port where the charging. In the vehicle, the port will be there, right? That is the this is the types of pins, how it looks like. In India, mostly what they will use is CCS2. You can see in the top the top area, right? This is they used for AC charging. In the bottom area, 2 pin is there, right? This they use for DC charging. So this is the two things, like the AC charging and DC charging. You guys asked, right, whether they will charge it in the single port or not. So this is the one single adapter. You will see it on the port. You will see it in the car. I will search for one adapter picture also. So here you can see the CCS2. This is commonly used in India, in most of the vehicles. So in the top layer, you can see, right, one big pin. I hope you guys can see the highlight and port in the CCS2. So that port is used for AC charging, and the below the 2 pin is there, right? And this port is used for DC charging. This is how they separate the AC and DC charging ports. So these are the types of connectors, and where it is from separately, from different parts of the world, they followed one regulation and one type of ports. Now in future, the regulations are coming up, and everyone is going to follow the single port versions. The CCS1 and CCS2, they just changed and improved the pin, how it looks, and there is not much the difference will be there. So it's just a version upgradation. So you can see the pin adapter size, right? They use that, they changed the top pin. So this is the thing. So in the real world, you can see I, I took one adapter picture. This is how the CCS2 looks like in the car. You see the charging port, right? So this is the same single port you will get for charging the AC charging and DC charging. The top port you will connect for AC charging, and the bottom 2 pin port is there, right? That you connect for DC charging. This DC charging port, if you connect, this connection will directly go to the battery, and it will charge. If you connect to the top port, right, that is AC charging, that connection will go to the onboard charger, and the onboard charger will go to the battery and charge the battery. This is how it works. Yeah, it's an all cost in India. Mostly nowadays they are using the CCS2 only, no other connectors they are using. They want to standardize, in phones and all, they are standardizing the Type C chargers, right? like that they want to, the government or the central all over the world, they want to standardize the charging, so they plan like that. They are using here. You also I mentioned about the DC and AC charging, right? This is how it is used. So bottom it's a DC and the top is the AC charging. Like that they will connect with the adapters. I hope it's clear, the charging thing. Let's go to the slides. Okay, so that's the charging thing. North America and Japan, they used JN 1772. They are also moving forward to CCS2. And Europe, they used Menicus. Now they are also moving forward to CCS2. It similarly looked to the CCS2, so they are also moving towards the CCS2. Chatmo, this is the level 3 DC fast charging they implemented in Japan and Europe. Only the bottom DC charging they implemented. CCS2, this is commonly used everywhere, like I showed in the picture under the slides, where they used AC and DC charging. Yeah, so this is the charging and the charging connectors. The port you will get, right, and that you will insert the port, right. If you're going to AC charging station, you will get the top port where you plug. If you go to the DC charging station, you will get the bottom port where you plug. So you don't have to select separately. It depends on which station you go and where you plug, and they will automatically recognize. So yes, this is about the charging station and charging. You will have a separate session for charging infrastructures. So you will get to know more things in the charging infrastructure, how the charging. I think it's the fourth session from, like I may will be discussing about the charging. So we'll discuss deeply on that. For now, basics is this thing, like how the charger port looks like, and the top what they are connecting, bottom what they are connecting. So this is the what commonly nowadays they are using in all over the world. So this is the basic thing I just want to explain you to you guys. So I just explained. Next, we are going towards the MATLAB software introduction. I hope here like here, how many people knows MATLAB? Battery swapping is totally different. Battery swapping is you totally take out the battery and you will swap the battery. So that won't come under the charging, this charging. So you will take the battery, you will have a battery in the vehicle, right? You will take the battery and then you will shift the battery to the another battery. So yeah, in car also we get the level 1 type. You can insert the level 2 also. You will have an onboard charger, so you can do level 2. Level 3 is the DC charger. Okay. I didn't understand. Only hear the name. Didn't understand. You guys saw the presentation, right? Oh, for the MATLAB. Okay. Yes. MATLAB is nothing but a simulation software. It's a mathematical simulation software used to do the mathematical simulations, like how we are calculating the powertrain, how we are sizing the powertrain, how we are calculating for this much speed, where you need this much power to go and this much range to go. So this kind of calculations, and you can do the controls in the MATLAB. So this kind of type of things you will do in the MATLAB. And many people are telling about the Simulink. MATLAB is the platform. Simulink is the tool. Like you have many tools in the MATLAB. Like Simulink is the one part of tool to do the mathematical simulations. You have many tools like that, like embedded tools like that, STM32. You have AutoSOR. You have state flow. There are many n number of things in the MATLAB. So Simulink also is one of the tools to do the mathematical calculation. It's called nothing. It's called a MATLAB Simulink alone. It's a separate. In the MATLAB, Simulink also is one of the two. Okay, so I will explain further. So MATLAB software, it's plays a major role to do the mathematical calculation, to how it works. So it's mostly used for the simulation purpose and used for the control purpose also. So and how to do the calculations and all, you can This is mainly used to reduce the physical cost. Like you can do all the simulations and calculation in the MATLAB itself, and you can decide whether to go further with that or not. Instead of purchasing and connecting and seeing the output and lose the money over that, you can do the simulation in the MATLAB, and you can see whether the output is right. And if it is right, you can go further with that. If it's not right, you can change few things in the MATLAB, and you can do the simulation. It's not only the design. So simulation, it's the calculations also. So it's not only the design. Simulation, it's not only the analysis simulations. You can see tell the calculation also simulations. So mainly in the EV sector, where they are using the MATLAB software, is to do the battery performance modeling, like how the battery is performing. You can do that model in the MATLAB and see how it is performing. If you are, for example, if you are building the BMS, battery management system by yourself, and you want to see how it works, and you can't buy one battery pack and test it physically. It will it has many dangerous things, like it can burst and many things will happen. Before that, what you can do is you design the BMS and you can connect with the MATLAB. You can model in the MATLAB one battery pack, and you can do the simulations in the MATLAB itself or Simulink. You can do that, and you can see the output, whether it's going to burst or the temperature is getting high or not. Everything you can see in this MATLAB itself, and you can see the output. Based on that, you can take a call whether to go with the physical testing or not. For that, for example, this is the example for battery performance and powertrain optimization. For example, powertrain is nothing but the motor, battery, power electronics, inverter, everything you can tell it as a powertrain. The part which is used to run the vehicle is you can tell it as a part. So powertrain optimization. How you can do the powertrain optimization in the MATLAB? For example, you are deciding you are going to build one car. Okay. So for example, you're going to build a car which is going to run 150 kmph. Okay, so for that you have, and you want to run that vehicle for a certain 200 kilometers range. So for that you do the calculation. Okay, you can do the manual calculation for every drive cycle you can do, or you can put that everything in the MATLAB, and you can model and you can see the output result, whether it's reaching 150 kilowatt and whether it's going 150 kilometer per hour, and whether it's going for 200 kilometers. And for that, how much power motor you need, for that, how much capacity battery you need. You can do those kind of calculation in the MATLAB. So that is the main purpose of a powertrain optimizations. And the energy management strategies. Now I said, right, like a battery management system, you can build a battery, like logics of the battery management system, and you can test it out with the real-time battery, and you can see the output. There's you can put the various strategies, like if the temperature is high, do like this. The thermal management, do like this. If you do that in the real time, it might happen anything, like it can burst also. But if you do it in a MATLAB, it will give the indication the temperature is rising. Don't do that. Like, so those kind of calculations you can do in MATLAB. Charging infrastructure planning. There are many things you can do in MATLAB. Like MATLAB is the wide software. You can do the simulations. You can do the controls. You can see. You can do the automatic driving system. How it. You can visually see how it drives. When you model, and you can see in the one tab how it runs, whether it's going correct or not. Everything you can see in the MATLAB. So this is the software we use for doing the simulation before going for real time or real time purpose. We do the simulation and we test it out. We'll see and we'll go there. And in the vehicles, there will be a vehicle control unit. So for that vehicle control unit, for example, in the steering wheel, there will be one. There are steering combination switch. Like there are many switches in the steering wheel. If you press this button, it has to communicate with the easily. Okay, so that communication you will do with the CAN, LIN, we saw right now, right, before few slides. You do that communication with some communication thing like CAN, LIN, or Ethernet, like that. So, but if you press that button, it communicating to that computer or VCU, do this, stop the wiping of the windshield. So like that. That logic where you will do in the MATLAB, and you will flash it in the computer VCU. So those kind of things also do we can do it in the MATLAB. So this is the thing we can do in the MATLAB. So I will share my screen. So for you guys, how the MATLAB will look. So to understand what I'm telling, like powertrain optimization, I just build one small model for powertrain. So you guys can see in how it works, and why the MATLAB is used for, and why you guys have to learn MATLAB if you are going further in this field, in the EV field. You guys have to know about the MATLAB. So yeah, I will share my screen. Yeah. Okay. Yeah. This is MATLAB. This platform is MATLAB. So here I just created a small programming embedded. This program is embedded C. What I'm done is C program, embedded C. So this is MATLAB, and a few people told about the Simulink, right? So this is the tool in the MATLAB called Simulink. So this I build it so to show how the powertrain works. Okay, so I will explain this blocks one by one. Just a short explanation how I did this. So to see how the powertrain works, what is the power you need for certain kmph, certain uh, to reach certain speed, and how much battery will deplete, uh, battery range will, how much battery capacity will deplete if it runs for a certain time. So those things and all you will get it from this. For example, so this is the first class of MATLAB, right? So it's not a class of MATLAB. Just I'm showcasing the how MATLAB looks, and how what are all you can do in the MATLAB. So you can just see how it looks, and how interesting it will be. So now I will explain one by one. Now what is the drive cycle and what is everything I will explain. So this is the drive cycle. Drive cycle is nothing but how your vehicle runs, and it's a time is a speed graph. So I will show the data. Yeah. So it's the, yes, it's a speed versus time is a speed graph. So for I have a graph for 100 seconds. So and this is the racing data. So this we did for our vehicle. So the max speed what we considered is 270 kilometer per hour. Here it's 170. So it's in mph. So 270 kilometer per hour what we consider. So for this power, you can see here 270, right? So for this speed to achieve, how much power we required from the motor, those kind of calculation you can do it in the MATLAB. So this is a drive cycle. For this seconds, it has for this second this much speed is going. For that time, how much power you will need from the motor to achieve that. So basically, that is the drive cycle we created. Or, for example, this is a small drive cycle which I created. So I'm riding from 0 to 1000 seconds. I'm going from 0 to speed of 60 kilometer per hour. Then I'm going in the constant speed till 1000 seconds in the 60 kmph itself. Then till to the 2000 seconds, I'm slowly, constantly increasing my speed to 110 kilometer per hour. Then I am going in the constant speed till 4000 seconds. You guys understand that, right? What I'm prepared the drive cycle. That is the my driving cycle. I'm riding like this, 0 to 60 kmph. I'm going, and after that I'm riding in the constant speed for till 1000 seconds. Then I am increasing my speed, and I'm going in 110 kilometer per hour till 2000 seconds. Then I'm going in the constant speed till 4000 seconds. This is the drive cycle which I created, which how I am riding. Okay, right? So this is the thing which going inside, and this is the calculations, like a vehicle calculation. You will learn this in session 3 clearly, how to calculate, and all I will teach you clearly. So these are the calculations to calculate for that speed, how much power, how much torque you will require from the motor. So this is the thing. So this is the transmission. Like in between that, there will be in motorcycle, there will be a motor sprocket and the rear sprocket. You guys know about the sprockets, right? Motor sprocket and the rear sprocket. So there is a two sprocket. What will be the ratio between two? That is the gear ratio. For example, I will do something. Yeah, you guys can see this, right? This is the sprocket and this is the chain. Here it will connect to the motor, that is called a motor sprocket. This is the rear sprocket. The size and teeth is there, right? That size is the gear ratio. So what will be the ratio between the two? You can do it in 2022, 2021 itself, the Simlink. Yeah, that also we will cover it in this MATLAB. Also, you will learn it in this session. So, not in the session, in this module. Yeah. So this is the transmission, and you can see the motor. What is the motor, and how the what power you need from the motor. So you will get the power output, and it will deplete from the battery. How much power you require from the battery. So that is the small model we created. For example, like I want to drive like 100 kmph, 120 kmph like that, and I calculate the how much power I need from the motor. So through the transmission, I will get the motor power how much from after the transmission and the motor block. I will get the motor power how much I need to achieve the speed. So that power will deplete from the battery. How much energy you have to deplete to drive this much seconds at this power. So this is the basic block which I created. So I will run this block to for your guys understanding. So you guys can see here, this is the SOC depleting. From 100%, it's reducing to 98%, 97%. It's running for 4,000 seconds, so it's reducing slowly. This is how the battery will deplete for riding. So in a motor curve, so you can see here, I will open this, the required power from the motor. How much power you reckon from the battery. So that you can see it in this. These are all called scope. You can see, right? So you need this much power till certain seconds, and it will increase. After some time, it will increase. So it's increasing, right? So it's slowly increasing because drive cycle is our drive cycle is like this. In the speed is increasing, so our motor power is also increasing at the time. So if the motor power is increasing, so if the motor power is increasing, so your battery, you can see the battery depletion capacity. How much capacity you are reducing also you can see. So our capacity is reducing. So this much capacity already 3 kilowatt hour is gone to achieve this speed. So based on the time. So we can, this much power is it's asking to reach. Then you will have a constant speed. I already showed the constant speed, right? So here the constant speed. This much power you need to achieve the 60. Then constant speed. Then you need this much power to achieve the 110. Then it's going to the constant speed till 4,000 seconds because we have this till 4,000 seconds, right? So it will go in constant speed, and the battery is depleting. So now 7 kilowatt hour is gone. So like that. This is how, yeah. Now this much percentage. Now 40% of the battery is depleted to achieve this. So this is how you do the calculation in the MATLAB, and you can see how much the battery is reducing, how much power it's needed, and you can see how much range it's traveling. So also Wait, I will open the range also. Range, I think I'm not connected on this like this. Yeah, this is how it works, and you can see how you can calculate the vehicle, how much distance it's going, how much battery is depleting, how much power it is required. So range, see in the range, how much range. So you can they for 4,000 seconds in that those speeds they traveled around 600 kilometers. So this is how you calculate. You can see here they traveled around 100 kilometers. This is how you calculate in the simulation software, and you can see before going to the real-time simulation, you will calculate and see it in a MATLAB. So this is just an example. I just want to show you guys how the MATLAB works and how you will get calculate and get the data. So this is very basic what MATLAB can do. So you can do a lot in the MATLAB. Yeah, for that you have to create a block, charging block. This much after it stopped, you have to charge it for certain seconds, and it will. You have to charge it for 1C rate. In 1C rate, this much amps you have to charge it, and how much it can charge. That also can be done. Anything can be done in the MATLAB. Whatever you want to see the simulation, you can model it in the mathematical way, and you can do it. So I guess some idea you guys got about the MATLAB, I guess, how it works and what purpose they are using it. So those kind of ideas you guys got from the MATLAB. And there are many other purposes the MATLAB can be used, like for the VCU purpose. I can show my VCU models also, but it's not, and it's a confidential. I can't show that. So that is the problem. Otherwise, I can show the how. I told about the control units, right? So inside the control units, so what are all the things will be there? Inside the control unit, what are all the communications will be there? You can see it in the VCUs, which the model we have. You can do that also in the MATLAB. For the course structure, what I get MATLAB till the May, I think till the session 4, I'm going to teach you guys. So module 4, I'm going to teach you this. And that very minimal MATLAB is there. And after that, they are going to teach you the in-depth of MATLAB. I guess you guys can ask about the MATLAB, how much MATLAB knowledge you will get from this course structures. You guys can ask your coordinator. So they want me to showcase how the MATLAB, how it works and all. So I just showcased, and you guys also will they will teach you this the MATLAB from the basic. I hope it's clear for everyone how the MATLAB works, and yeah, it's possible. So the same PPT will be available. Yeah, it's available, and the pictures will be like which I did, right, like question and answer sessions. I did separate slides which I showed them. I will share that also. That I did by myself. So this available in Storytel. Yes, does it needed to learn C language also, and it's not too complicated. The if Simulink doesn't need C that much. So to make it easier way only they made it in the Simlink. Otherwise you can do with the C language also by programming. But yeah, you should know the C when you start the MATLAB, like embedded C at least. Basics at least you should know. And I also. Yeah, they will provide you this. I think they will give, I guess, for student version. I think they will give. I don't know about that thing. So I didn't get any information about that. You guys can ask your coordinators about that. So whether you will guys get the student version of a MATLAB. See, I want to tell you this thing. Nothing is complicated, or nothing is we can't do. Okay, we have to put an effort to learn. You guys spend money to learn this modules and everything. So you guys have to put an effort to learn. So we can learn it in slow phase. How much slow we want to learn, we can learn it. But at the end of the day, we have to learn. MATLAB is one of the tool we have to learn. Programming also is one of the part we have to learn. Yeah, so this is the thing, like we can learn. So it takes time, but we have to learn. So we have to put an effort. That's all.
Just a quick info, guys. Intellipaat offers electric vehicle course training. Through this course, you will learn vehicle fundamentals, battery technology, battery sizing, mechanical subsystems, charging infrastructure, and much more from the top 1% of industry experts around the world. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, the link of which is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of EV.
Normal conventional vehicles. Conventional vehicle means now electric vehicles came in. Before that, what was that? It's a IC engine vehicles. IC engine vehicles like petrol engines or diesel engines like internal combustion engine vehicles. So now how it looks like, the architecture, how it looks like. There will be an engine and there will be a clutch and there will be a gearbox. You know about the transmission part, right? Gear. So in the engine and in between the engine and the gearbox, there will be a clutch to disengage and engage the engine with the transmission. And there will be a propeller shaft. This is the rear wheel drive, front engine rear wheel drive. So there will be a propeller shaft which are connected from the transmission to the rear wheel. So you can't directly connect that propeller shaft to the rear wheel. So you have to run the rear wheel, right? So you need certain gears to run the rear wheels. That set of system is called differential gears. So this is the normal vehicle architecture, how it looks. So I can share my screen, 1 minute. You can see the screen, right? So here, this is the real vehicle architecture, how it looks, rear wheel drive architecture. So there will be a front engine. So here you can see the engine, and in between the engine and the, you can see the one long shaft. So you can see here, so there will be a engine, and in between that, one clutch will be there. So you can see this drum kind of structure, right? This is the transmission set. So in between the engine and the transmission set, there will be a clutch. So and there will be a transmission gearbox will be there. So this is the internal architecture of the vehicle, and it will be connected to the end of the transmission. It will be connected to the differential unit. So differential unit, it's look like this. The third picture, the small picture you can see. So it look like this, and there will be a set of gears inside the differential gears. It will be connected to the rear wheel, and it will run the rear wheels. So this is how the normal vehicle architecture will be. Okay. So there will be a number of conventional vehicle layout. We can take a 4 vehicle layouts. So front engine, rear wheel drive, front engine, front wheel drive, front engine, all wheel drive, and a rear engine, rear wheel drive. What is the difference? Means how the engine is located in the vehicle. So the front engine rear wheel drive means, now we saw, right, there will be a front engine, but there will be a number of components in between, and the rear wheel will be driven. So driving. So this is the structure: front engine, rear wheel drive, and next front engine, front wheel drive. So you won't find this propeller shaft, differential gears, and all. Everything will be at the front itself. I will show everything in the videos, and but I'm just giving an intro of what it is. So everything will be at the front in the engine side itself, front itself. Everything will be there. The engine, clutch, gearbox, everything will be there in the front. Front engine all-wheel drive. So there will be many components in the front engine all-wheel drive. I will explain that. Rear engine rear-wheel drive. This engine compartment, clutch, gearbox is there, right? It totally will be in this differential area. So everything will be in this backside, the rear wheel. So this is the layout, and why they are using those kind of layouts in the vehicle. Front engine, rear wheel drive. So clear for you guys? So this is the front engine vehicle. So the engine will be at the front and everything will be at the front. The clutch, drivetrain, everything will be at the front. Next, consider mid. This is the mid-engine vehicle. The before build before the rear wheel, the engine will be set. They fix the engine before the rear wheel. This is the rear engine. So both in the rear wheel itself, they will fix the engine like a front wheel drive you saw, right? The front engine will be fixed in the front wheel. Like that, the rear will be fixed here. So this is the front engine. So what they are telling us, like how this front engine, rear engine, or mid engine, how it affects the space, steering dynamics, torque, and oversteer, understeer, everything will be explained in the upcoming. So I will explain. I will explain each and everything. So this is the most common structure, front engine, rear wheel drive. This used from long back and mostly for most of the cars they use this. Now like for past decades and mostly all the cars are coming with the front engine, front wheel drive. So there is some reasons for that also. I will explain in this video clearly. So the thing is, the first advantage what we have is you can easily do the maintenance work. If something happens in the engine, you can just pop up the car, pop up the bonnet, and you can see the what is happening in the engines. So everything you can see it easily. The maintenance will be easy. Service will be easy. That is the first advantage of the engine. So this is the thing, weight distributions. So the engine is at the front, so the weight is adding at the front, and the transmission and the clutch and propeller shaft differential. The transmission, clutch, and propeller shaft at the middle. So this makes the whole vehicle the equal weight distribution, ideal weight distribution. So not equal, at least the ideal weight distribution will be there. So this makes the traction good. Traction means the power transferring to the wheels, right? So it needs some traction. If there is some weight, there only the traction will be there. So that it makes the traction good. That's what they are explaining. Service can be done for any cost, but I'm telling it will be very easy in a front engine cost. Yes, I will share this whole the PPT itself, so you guys can view the videos. The main advantage of the keeping the front engine rear wheel drive cars are mostly used in for commute purposes. Commute means normal daily use or weekend use, those kind of purposes. Not for the high performance and a few other stuffs like or off road, those kind of categories that they won't use the front engine rear wheel drive mostly. So the front engine rear wheel drive mostly used for the commute purposes because it gives more advantages like service aspects also it has more advantage and the slippery because of the equal weight distribution. So ideal weight distribution, it won't slip faster. So that's the thing. And the cabin space. So you will get more cabin space because the engine at the front, totally at the front, and the transmissions are the equally distributed at the middle, and the rear differential will be there. So this makes the whole and the cabin space more. So yeah, this is the one of the advantages. So this is the thing. They can easily access the front engine vehicles and do the service. So this is the drivetrain component. There will be a front engine. There will be a drivetrain between the engine and the transmission. There will be a clutch and there will be a propeller shaft. And at the rear, there will be a differential unit that will be connected to the rear wheels. So this is the layout. Next advantages is cooling systems. So the engine will be at the totally at the front. Okay. So the cooling, the air will be first go through at the front. So the cooling will be more at the front. So that is the one of the advantages. So you can see in the video the air will be processed. So the air at the front. So the engine will be cooled faster. When it is the rear, you have to design the vehicle. You have to give out the vents, the sides to air to pass through the engines. So that is the one of the advantages what we have in the front wheel drive cars. Why we are saying the front wheel drive? Front engine rear wheel drive car, not the front wheel rear wheel drive. It's a front engine rear wheel drive car. So you can see the airflow, how it is going. So if the engine is at the front, so the air will easily go through the engine. So it will cool the engine even more faster. So that is the one of the advantages what we have in the front engine vehicles. So you can see there will be an engine at the front, and before that is the radiator. So the air will pass through the radiator, and it will easily cool the engine. So this is the radiator. So how it cools. If it is at the front, it will be there. So this is the one of the disadvantage what we have. In the front, yeah, if it is a, front engine rear wheel drive car, so there will be a oversteer. If it is a front engine front wheel drive car, there will be understeer. I will explain what is understeer, oversteer, everything. So what is the thing is when if for example in this vehicle what we are talking about is the front engine rear wheel drive car, so the rear wheel gets the more traction for it. So if you give out more traction at the traction means how much power you are giving at the certain wheel, the rear wheel or front wheel, how much power you are giving at the wheel. So if the wheel power is exceeds, so it will at the turnings, so it will do the oversteer or understeer. Oversteer means the rear wheel get drifted away, and understeer means the front you can't control the front wheel steering. It will go because the front wheel is getting more power. So here in this scenario, what the engine layout, what we are talking about, what will happen is oversteer. So yeah. So for a quick summary for the front engine rear wheel drive car, so you will have a ideal weight distribution. Yeah, you will have an ideal weight distribution. So there will be an engine and a clutch and the transmission, and there will be a shaft and differential. So it will be ideally distributed. So you will have an ideal weight distribution for better handling and stability. So that will be that. For traction, so rear wheel drive cars, the front engine rear wheel drive cars, for better handling under traction, especially during the acceleration on dry surfaces. So you will get the better traction in the acceleration, because why it is happening is while acceleration, the total weight of the vehicle will transfer to the rear wheel. So the weight distribution will be go to the where the traction is there. So it gives the more stability in accelerations, easier to service and do the maintenance, and very simple engineering. So what are the disadvantages? Less grip and slippery conditions. So in the slippery conditions, the at the front the front engine is there, but the whole weight is transferring to the rear, right? So you will lose the grips at the front tires. So you need for the grip you need more weight at the front. So you will lose that in this kind of vehicle. So yeah, more prone to oversteer. We saw that video, right? The rear wheel is going away in the turning, so like drifting. So that might happen. And so many components will be there when we compare to the front engine front wheel drive car. So only, everything will be at the front, right? Front engine front wheel drive. So here more components are there. For example, extra the propeller shaft differentials are there, right? So here the propeller shaft and all extra components for a front engine rear wheel drive cars. So that will be neglected in future costs. So and larger cabin space. These are the advantages and disadvantages in the front engine rear wheel drive cars. Then, okay, I think everyone heard about this front engine rear wheel drive cars, right? Yeah. Then we can move for next vehicle layout. Next vehicle layout is front engine front wheel drive cars. So we are going to see what are the advantages and disadvantages in the front engine rear wheel drive cars. So in this thing, the whole the engine, gearbox, clutch, everything will be at the front wheel. So what are all the advantages in the front engine rear wheel drive cars? It's a cost-effective manufacturing. You don't need extra propeller shaft, and the accessibility of maintenance and the service will be very, very easy in the front engine rear wheel front wheel drive cars. So the first advantages is cheaper to manufacture, and compared to all the all-wheel drive cars, rear-wheel drive cars, it's very cheaper to manufacture. And improved traction in slippery roads. I mentioned right in slippery roads, the front wheel need to have a more weight. So in this thing, the front has a more weight. So it will have a good traction. Traction means that the power transfer to the vehicle, so to the wheels. So that traction will be good in the front engine front wheel drive cars. The one more advantages what we have is the cabin space. The whole engine, gearbox, everything at the front. So you have a huge space of cabin, and it has a good fuel economy because of the way they use mostly these kind of structures layouts for commute vehicles like cars like you can say Honda Brio or many cars out there. Like they use the front engine, front wheel drive cars. So they use mostly for the commute. And what are the disadvantages of that? The main disadvantages, first disadvantages, what we are going to see is the video is visible. The front engine, front wheel drive, cause the rear wheel won't get any power. So there is no shaft will be connected to the rear wheel. The front wheel will be driven. For example, yeah, you can see this right. The front wheel drive cars tend to have understeer. So understeer means the power is going to the front wheel, and the steering also you are handling by the front wheel. So if the more power is going on the front wheel, you can't control the steering in the high power situations and all in the turnings. So what it will do is it won't turn. It will do the understeer. The vehicle will go directly. So you can see here, it will go like this. So this is the main disadvantages what we have. That is called torque steer. So why they automotive manufacturers won't use the front engine for a high performance vehicle? The main reason is like a torque steer. Like if it is a high performance vehicle, the high torque will be transferred to the front engine, front wheel. So what will happen is you can see. So if they accelerate the vehicle, the steering itself automatically turn. So if it is a front engine, front wheel drive car. So and the driver won't have capability to control the vehicle. So yeah, this is the one of the disadvantages what they have. And one more disadvantages what the front engine front wheel drive cars has is like wear tire. Like tire wear will happen in the front tires when compared to the rear tires, because even the steering is handled by the front tires, and even the power is handling by the front tires. So the tire wear will happen even more faster when compared to the rear tire. So that is the main one of the main disadvantages. So and the weight balance is one of the disadvantages what we have. The most of the weight will be at the front wheel. So it will be the front heavy. So that is the one major disadvantages what we have in the front wheel and front engine front wheel drive cars. So this is how it front wheel drive, front engine front wheel drive. The engine, transmission, differential, everything at the front. So this is how it looks. Next layout what we are going to see is rear engine rear wheel drive cars. In parallel, they use the rear engine rear wheel drive cars. This is mainly meant for racing purpose. So like mostly the supercars, the sports cars use rear engine rear wheel drive cars, because while driving the high performance the driving and all, the whole weight will transfer to the rear. So the whole wheel, the load will be at the rear wheel. So if you give traction power to the rear wheel, so you will get more acceleration, more power output from it. The vehicle will go faster. If you put, if the more weight is transferred to the rear, and you put your engine at the front, there will be a no traction. You won't get the weight at the front, so you won't get the traction at the front. So you won't get the power output at the front. The vehicle won't go faster if there is a front engine. So I'm talking about the totally high performance vehicle like a super sports, like a Lamborghini, Ferrari, those kind of vehicles. So why they are having the rear engine vehicles is this is the main reason they have a rear engine. So rear engine, rear wheel drive cost. So the rear engine, the mostly the weight, it's a balanced weight what we have, and mostly the weight distributed to the rear end. So it will have the better handling because the steering wheel doesn't have any load, like any torque load to handle. You are going to handle the steering wheel alone. There will be a no load will be acting at the steering wheel like power. So that makes the even more easier handling. So for high performance vehicle, that is the main reason you need the no torque steer at the front wheel. So improved traction, that is the second main advantages what we have. Reduced torque steer. Why reduced torque steer is there is no front engine or front power is happening in the steering wheel. So reduced torque steer. Easier to control the steering wheel. Improved braking because the whole weight is transferring to the rear. So the vehicle will be balanced. So if you hit the brake, the braking performance will be high. So you can hit the braking performance. You can stop the vehicle even more faster if it is the front engine vehicle, high performance vehicle. Improved. The main disadvantages what we have is service and maintenance is very hard in the rear engine vehicles. Like to open and do the service, you have to remove the most of the parts and the rear end. So that is the main disadvantages what we have. Less grip and slippery conditions because the front wheel doesn't have a most of the load, so it has a less grip at the front, less load at the front, so there will be a less grip at the slippery conditions. So then when you're sitting inside the vehicle itself, you will hear the more noise, so because the engine at your back, so that is the main reason the noise will be high. And it tend to oversteer. Oversteer, I showed you, right? The rear will be drifting away. So if the more power is acting at the rear, so it will drift away. The traction will be more, it will be drifting. And this makes the exhaust design complicated. There will be an exhaust pipe from the engine, so it makes the engine exhaust pipes and the components complicated because there will be more components to reduce the emissions. There will be a smoke coming out of engines, right? You have to use many components to reduce the emissions. So placing those components will be difficult if it is a rear engine vehicle. So, and one more thing is engine cooling. So that will be the vehicle will be moving forward, right? The front is the first facing the gas. So the engine is at the rear. So how will you pass the air to the rear? So you have to create vents at the sides of the vehicle to give the air to the engine to release the heat from the engine. So these are the main problems what we have in the rear engine rear wheel drive. So only this kind of layout they use mostly in the super sports car, those kind of things. I can show you the video, so it would be easier to understand even better. So this will be commonly seen in the performance sports vehicle. So this is the thing. They use mostly this kind of cars for drifting because the oversteer will be more. The rear will, the steer will be more. The drifting away. So you can see the oversteer in this. So here there will be no need of the propeller shaft, anything. So the engine will be placed at the rear. So the drivetrain, the components will be very less from the transferring to the front to rear or rear to the front. Those components will be very less. That makes the cost little bit less, not too much less, little bit less. So this is the rear engine, rear wheel drive advantages and the disadvantages. Okay, next what we are going to see is all-wheel drive. For that, yeah, advantages and the disadvantages of the front engine all-wheel drive. Like all-wheel drive means all the four wheels will be driving. So that is the main thing. So for that, what are all advantages we have? Why they brought up this concept first of all? What are all the disadvantages we have in this? So those things we are going to see in this next few minutes, and we are going to see that. I have a video for this also. We can clearly see in that video also. Okay. Differential, yeah, I can explain you. The differential is there is a propeller shaft which coming from the engine. You have to transfer it to the two wheels. Okay, for that you will use one gear systems inside the differential to transfer that power to the wheels. So that is the work of a differential. So in this coming slides itself, I will show you the pictures how the differential engine looks. Understeer, oversteer. Understeer is nothing but if your engine has the rear wheel traction, the rear wheel has a power. Um, you know about the driftings, right? The rear wheel drifting they do, right? That is basically in corners. If you do, that is a oversteer. So the rear will be drifting away. In the video itself, it's clearly shown. Show the video once more. See, in the oversteer, the rear wheel has a power. So it is drifting in the corner. So in the below video, you can see the oversteer. In the understeer, the front wheel has a power. Okay. So the steering also handled by the front wheel and the power is also handled by the front wheel. If more power comes to the steering wheel, you can't control the steering wheel in the corners. So it will take you to the steering won't turn. It just go like this. So it will go like this. This is the understeer. I hope now you understand. How the weight is balanced in no the front engine front wheel drive the traction there is no connection to the rear wheel, so it won't the power won't transfer to the rear wheel. Propeller shaft is nothing but you have the transmission. From the transmission, you have to transfer the power to the rear wheel. So there is an engine. Here, this front wheel is a dead axle. Okay. So the engine is there. You have to transfer that power to the rear wheel. The rear wheel is driving. So you have to use one shaft to do that. So that is the propeller shaft. You will transfer that power through the propeller shaft to the differential and you will drive the rear wheel. So that is the main use of the propeller shaft. Next question. Weight is not balanced in the rear engine rear wheel drive. The you can say the rear end from the mid to the rear has a 65 percentage and to the front it has the 35 percentage. So like the why they said the steering control managed because the weight is acting no power is acting at the front side, so you can easily turn the steering. There will be no torque steer. If there is a power at the front wheel only, you will get the torque steer. Torque steer is nothing but the engine power will give engine torque will attack will be on the steering wheel that will make a turn automatically without you are turning the steering wheel. So those things won't happen in the rear engine rear wheel drive. So, but weight distribution is not ideal. Like a weight distribution will be like a 35, 65. The rear has a 65 percentage. That makes the whole weight is going towards the back, right? So in the accelerations and those things will be high in the rear engine, rear wheel drive car. That's the added advantages. So which joint used between propeller shaft and the differential mechanism? What kind of there is a in all-wheel drive they use the universal joints. There are different they have 5 types of joints. So I can show in the slide itself. Wait. This is the propeller shaft. So this is the propeller shaft inside how it looks. What about for yeah, I'm yet to discuss about that 4x4 and all-wheel drive. What is the difference and what is the added advantages? Everything we are going to discuss about that. So electric engine can also placed as IC engine front of electric engine. You have many advantages that we are going to discuss tomorrow, because in the motors are small. You can place one motor at the front and you can place motor at the rear. You can control easily. There is no need of say a propeller shaft, shaft, big transmission. There is no need of clutch. Nothing is needed. So this is the conventional vehicles we are discussing. All four wheels are have same traction power. In what powertrain? All four wheels we are asking about. In which vehicle layout? So flywheel will be in the engine, which is attaching to the clutch and the engines. Both are totally different. Understeer, less contributing steering. Yes, the steering plus less contributing steering, because the engine torque is acting on them. 4x4 we are going to see now. So we are going to discuss now. So I think I will go ahead with the 4x4. There are many possibilities in EV in 4x4. So we will discuss tomorrow. You can put 4 motors and the 4 wheels also. That is called in-wheel drive. They will say like that. Also you can do. Yes, Chandra. You can put up your thing in text. So okay, let's go ahead with the. Here the 4 wheel will be driving. So there are 2 types in the 4-wheel drive and the all-wheel drive. I will explain what is the difference between the 4-wheel drive and the all-wheel drive. So is my screen visible? So in 4-wheel drive, you heard about the term called 4-wheel drive, right? So in the 4-wheel drive, you can control manually whether it has to run in 2-wheel drive or 4-wheel drive. Like that, you can control. You can see in that right below corner, right? You can manually in this setting, like you can see in the right below corner, you can manually control the 2-wheel drive whether it has to run in the 4-wheel drive. So in the normal riding conditions, like whether you're riding in the highways or somewhere, you don't need 4-wheel drive. So it's just the waste. It will consume the fuel lot when compared to 2-wheel drive. 2-wheel drive means the rear wheel drive, front wheel drive, like that. So it will consume more fuel when compared to the 2-wheel drives. So in the while riding in the highways or like that, you have to go for a 2-wheel drive. That is a more fuel efficient. And they mentioned in this picture itself, right, in the video itself, the front wheel are the off-roading conditions. So when you're going for off-roading conditions, you have to go for 4-wheel drive. Why they are going for a 4-wheel drive? So if the vehicle, if the 2-wheel drive, they are going for off-roading conditions. So you will get the traction at any particular end only, in the front wheel, either front wheel or either rear wheel. So that won't suitable for off-roading condition. You need to have each vehicle traction. So that for that purpose, they introduced that 4-wheel drive. So here you can see the 50% torque is going, engine torque is going to the front end and 50% is going to the rear end. And in this off-road condition, each wheel has a sensors. Okay, so the sensor will tell to the vehicle ECU or VCU how much, like this side more slippery is happened, this side less traction is there. So I need more power in this wheel. So this will give more power in this wheel. So like that only the 4-wheel drive work. So this is the all-wheel drive. There will be no manual transmission. You saw in this Jeep, right, in the right left corner. So there will be no manual gears to change the two-wheel drive or four-wheel drive. This will be always running in the four wheels, like the system. It has one computers like a VCU or ECU that will decide whether it has to run in two-wheel drive or four-wheel drive. That makes the vehicle to drive in that particular wheels. So if it is going in the off-road condition, all the four wheels will be driving, and if it is going in the straight roads, two wheels will be driving. Every decision will be taken by the computer. This kind of systems used in mostly these kind of systems use they prepare this kind of system for snowy areas like Europes or those kind of areas that in the winter's times there will be more slips. You can see in the video itself there will be more slips. Two-wheel drive doesn't do anything in this kind of areas, like it will just run in the front wheel or rear wheel and it won't go further. This kind of technology, what it will do is it will sense how much slip is there at the front wheel, how much slip is there at the rear wheel, how much power you needed at the front wheel right side, how much power you are needed at the front wheel left side. It will give the exact power to the particular wheel and it will run smoothly. That will save the fuel efficiency. Okay, now we saw before like four-wheel drive will have more will less fuel efficient, right? So why I'm saying now it's more fuel efficient is in if it's a two-wheel drive, the let's say it's a front wheel drive. Okay, the front wheel will be just rotating in this snow. It won't move further itself because of weight distributions and everything. So it won't move further itself. Sorry, rear wheel. If let's consider rear wheel. So because of everything, it won't move further. So, because there is a no torque split from the front wheel and the rear wheel to tackle the slips and all. So, in this condition, you will lose more fuel just running the wheel. You will lose more fuel. So in the situations, if you bring in the all-wheel drives or four-wheel drive, that will sense how much torque exactly you need, how much power exactly you need in the particular wheel, and it will give that particular amount of power to overcome that slip. That is the main reason they started this. That everything will be taken care of computer like ECUs. That one will be given more torque and the other will be given, that everything is taken care by ECUs, and there will be a differentials. Okay, there will be a front differential gear and there will be a rear differential gear that will take care. There are many types of differential gears, so that will take care of it. I hope it's clear. You can see in this video itself, power is going to the all wheels. So they are getting the rain at that red color marked tire, right? They going through the rain. So it's giving more power to this side of the wheel to overcome that. So you can see this. They're giving more power to this side of the wheel to overcome more variable focus. Grip capacity. You can see in this itself what I explained now, right? You can see in this video. Because it's raining and it's slippery, it's all-wheel drive is going faster than the forward wheel and the rear wheel. Why means it's equally distributing power to the each wheel and overcome that slip. So this is what will happen if it is a front wheel or particularly the rear wheel drive. So this will what happen in the slippery conditions. So all-wheel drives that won't happen. It will equally distribute the power to each wheels and it will control the vehicle without any wobbling and everything. So this is the two-wheel drive cause. So the rear wheel is slipping out. So the advantages, this kind of advantages, you can do the off-roading. If you do this in two-wheel drive, right, or rear and two-wheel drive, it won't go. It will be stuck. So because of all-wheel drive, each wheel has the need will get the power what they want. So it overcome the off-road conditions and So you can see in this slippery condition how it manages. So you can see in that, right? The front wheel is not moving, the rear wheel is pushing to move. Sometimes the front wheel will be pulling the rear wheel. So this power transfer will take care by the computers and how it will manage. I think it's clear, I guess. I will show one more video also for all-wheel drive and the four-wheel drive. So the all power will be delivered to the. You saw that, right? This is the transfer case. Okay, the engine, the transmission will be connected to this transfer case. This will transfer the power to the rear wheel and the front wheel. You can see this shaft is going right to the rear, and the shaft is going from this end to the front. This will take that this transfer will case will deliver how much power it will need at the front wheel and the rear wheel it will deliver accordingly. There is no much difference in four-wheel drive and the rear all-wheel drive. Here, manual in four-wheel drive, you have to do that manually, the change, gear change, and uh, in all-wheel drive, it's little expensive. So everything will take care by the computer, the ECU. So that is the difference. Not much difference. So you guys would have seen that 4x4 in some vehicles. Yeah, what that means is the four is the number of wheels, and the second four is number of powered wheels. How much wheel is getting power? So in the front wheel drive or rear wheel drive, it will be like 4x2. There will be a four wheels, and the two wheel is getting power. So like that. Yeah, you can see here six wheels in the truck. Okay, so here four wheels is powered wheels. So that's what they are saying in this. Here in this thing, we can see the working, how it works. So there will be a three major components. First, you saw that differential. So this differential will be at the front wheel, the rear wheel. Both the wheels at the mid, you can see the differential. And the transfer case, the middle of the front wheel and the rear wheel, the shaft will be there, right? At the middle, you will see the transfer case and the locking nuts. So you can see the differential where it located, front wheel and the rear wheel. So this is how it looks and the differential. I don't know what happened. This is the device which splits the power from the to the front wheel and the rear wheel. This is the device which splits the power. This is how the inside, how it looks in the transfer case. The transfer case, why they are using is they will split the power to the front wheel and the rear wheel. So it will get the ECU will get the information from all the four wheels. Each wheel has a wheel speed sensors. The ECU will get all the information of the four wheels, and it will calculate which wheel needs how much power. So it will tell to the transfer case. The transfer case has many gears. So the power will be transmitted to that, and so it will transfer to the front wheel. So there will be many parts components in the front wheel, like locking hub. If there is more pressure is happening in one side of the wheel, like in turning the left side. They are turning in the left side, right? While they're turning in the left side, so this left wheel will be rotating very less when compared to the right side. So this will sense, and it will give less power to the left side, and it will give more power to the right side wheel to make a turn smoothly. So this is how it works. It's managed by the computer. How much power is we need to give everything? It's managed by the computer. So yeah, this is how I will share the videos in the PPT with the PPT, so you guys can clearly take a look. What is it, and you can see the videos and learn about this. If you guys have any doubts related to the four-wheel drive and the front-wheel drive, just put it up now, and we will discuss. The differential, what it will do is, you can see here, right? In this video itself, you can see my screen. There is a long shaft is going to the from the front to the rear. So it's the straight shaft. It will be rotating in the 360-degree this direction. Okay, how you will split that power to both the tires? So you need gears for it, right? So that will do. The differential is that gears that will split the power to the both the wheels. So for example, thought of showing this picture at the last, but I can show it now. So this is how the differential look. Okay, so there is a shaft coming. This is the differential system. So this shaft will rotate this side. There will be a gear engaging in both the side, and it will transfer the power to both the wheel. That is the main purpose of differential. So while we are going to see this differential topic also in this. So I will show the video of a differential, how it works. So it would be easier to understand. So these are the conventional layouts, how the vehicle works and how the traction works and how the rear wheel drive works. If there is a front engine car, okay. So you guys have to ask why there is a engine at the front and it's connected to the rear. So why they done it? There should be some reason they have done it. Right now, you guys must know some reasons why they done it. So that's what this session is for. This particular of the session is. So yes, now what we are going to see is powertrain. So the powertrain is what we are going to see is engine. Okay, okay then. We will go to the video and we will see what is the engine and how it works and everything. So I hope my presentation is visible. The powertrain, powertrain means which powers the vehicle. Okay, first I will explain this thing. What is drivetrain and powertrain? Drivetrain means the clutch, transmission, and which transfers the power from engine to the wheel, right? That is the drivetrain. Like transmission, clutch, propeller shafts, those things are not drivetrain. What is a powertrain? Powertrain means the what which creates the power. In a conventional vehicle, engine creates a power. In electric vehicle, motor creates a power, and that is the powertrain. Like here, engine, the transmission, clutch, everything is the powertrain. Okay. In electric vehicle, motor, inverter, like a battery, uh, so those things are on powertrain. So this is called powertrain. Drivetrain means only the transmissions, clutch, and those things are all drivetrain, which transfers the power to the wheel. We use right those medium is called drivetrain. Powertrain means which creates a power, like engine. Powertrain means including the transmissions, everything that will come under the powertrain. Engine, transmissions, clutch. I think it's clear, I guess, what is the powertrain and what is the drivetrain. So we'll go into the. So this is the engine, how it looks, the internal structure of the engine, how it looks. So there are like different parts, which is there. And the main parts you can see here. You can see that a coolant, that one wall is there, right? Those internal structure is called cylinders. Uh, you heard about the engine cylinders. This is the cylinder where the piston goes up and down. So this is called cylinders, and this is the piston. So in the top you can see the two rollers, right? That is the camshaft, which is used for to open and close the valves, intake valves and the exhaust valve. This camshaft will rotate and open and close the valves. So in the below, in the piston, it's connected to the one shaft, right? That is called crankshaft. The connecting rod will connect to the crankshaft. So in below that you can see the oil pan. So this is how the engine in one single cylinder engine, single cylinder engine will be there, right? In normal vehicles or not, two wheelers or not. So this is how the ports, the internal ports will look like. So now we are going to see how it works, like how engine works. So I can show you the video, so it would be more easier to understand. So this will be some faster video. I will show one more video also, but this is how the engine works. You can see it in this shorts. So what is happening is from the left side, the intake air and fuel is coming inside, and it's going to the engine, going inside the engine. And this is the piston is moving upward, right? So that is the compression. Okay. So during this compression, the air and fuel is compressed. At the time, what will happen is the spark will be coming. Did you saw that, right? The middle one plug will be there, right? The yellow color plug. That is called spark plug. So that will spark. That creates the ignition. Like the fire will create that pushes the piston down. So this is the intake stroke. Fuel and air is coming inside slow motion. This is a slow motion video. So at the same time, so now it will next stage is compression. Now this is going upwards and it's compressing the water and the fuel. So in the it will be compressed in the high pressure. Then the spark plug will give the electricity. So then power ignition will combustion will happen. That pushes the piston downwards. That piston pushes the piston totally downwards, and it will rotate, and it will come up, right? At the time, this side wall, the right side wall, it's called exhaust wall. It will open. See, the exhaust valve will be open, so this piston will push out all the combusted gas will be there, right? It will be pushed outside, so it will be totally pushed outside, and through the tailpipe it go to the environment. You see the smoke outside the vehicle, right? This is how the smoke will. I hope you can understand somewhat from this video how the engine works. So I will show one more video. Yeah, the crankcase will be there, right? For that only. What is the tailpipe? Tailpipe, you saw it in the vehicle, right? The outside exhaust pipe. That is the tailpipe. In the cars and all, there will be a exhaust pipe, right? That is the tailpipe. I will mention as an exhaust pipe. So in this video, we will clearly see how the engine will work. So this is the four-stroke. There are two varieties, like two-stroke engines and four-stroke engines. We don't have to. The stroke means how much times in one single power combustion happening, how much time it's going up and down. It's like there are two varieties, two-stroke and four-stroke. I don't think so. We have to go deeper in this. If you want deeper how it works, I can go inside. So the four-stroke means it's going down, intake and compression is happening, going up, compression is happening, then power is happening, it's going down, one stroke, and exhaust going up. And the exhaust smoke will be come outside. That is the four strokes. Intake, compression, power, exhaust. That is the four stroke. In two stroke, intake and one in one stroke itself, the power compression power and the exhaust will happen. So that is the two strokes. This is the one stroke intake. The air is coming inside and it's going upward. At the time, the yellow you can see, right, inside the cylinder. So that is the compression. What is happening? So here the spark plug is ignited and combustion is happening. Then it's going down. That is a one stroke, and it's going up to get out all the exhaust outside. So that is one stroke. So four stroke. So stroke one intake. So the air is coming inside. Air fuel mixture is coming inside through the intake port. Next stroke is compression. The piston will move outside. it will be compressing to a higher pressure. So at the time, if the spark plug is ignited through electricity, it will ignite. So at the time, the combustion will happen. So now the combustion. See, if you can see that, white that power, right? So at the time, the combustion will happen. The fire will happen. Then it pushes the piston downwards. So it's pushing the, yeah, this is the continuer and this is the crankshaft which rotates. Then here inside the cylinder, all the smokes will be there, right? That has to go out in the exhaust way. So here, while it's going up, the fourth stroke, the exhaust valve is open, right? So in this way, all the smoke will go out. So this is how the car engine will work. So it will go up and down, and it will produce the RPM and torque. So this is how the engine works. Four-stroke is I said, right, intake, compression in single cylinder itself. Intake, compression, power, exhaust will happen. That is the four-stroke. Okay. Now, next, what are all the types of engines are there in the available? You know about the petrol engine, CNG engine, and the diesel engine, LNG engine. So you know about these kind of engines. So in petrol engine, CNG engine, LNG engine, they use spark plug. You saw that one electricity provided, right? That is the spark plug. Diesel engine is little bit different. So you won't get, the spark plug won't be there in the diesel engine. So how diesel engine works is it compress, it auto ignite. So and it will push the piston downwards. I will show in one picture. Before that, I got two questions. If you can see, you can see this diesel engine, right? So this is the diesel engine, how it works, four-stroke diesel engine. Intake valve is getting more air inside, and compression is happening. It's compressing, and through this fuel injector, in the third picture, power picture, you can see in this fuel injector, the fuel will be injected inside. And the time the power will be, due to this compressed air, right? So the power will be produced. The combustion will happen. It will auto ignite due to the over pressure. The fuel coming inside, it will auto ignite and pushes that piston down. Then in exhaust, the piston will go outside, exhaust valve will open, and all the smoke will go out. This is how diesel engine works. So this is the different types of engine. Petrol engine, you will get the petrol. CNG gas will be there, and the LNG means liquefied gas will be there. So this is how the different types of engine and how it works. Okay, now we are going to see the engine subsystems. What are all engine subsystems are there and how it works. So we will go one by one. In that, I will show it in the video. What is the air intake system, fuel system, what it is. Everything I will show in the video. So we will slowly understand how engine works. Okay, the first subsystem what we are going to see is air intake system. For engines, the air intake is really important. So how that system is working and what are all components will be there in the air intake system we are going to see. So here they mentioned air filter will be there, intake manifold. Intake manifold means that intake wall will be there, right? That will be connected to one rack. So that is called as an intake manifold. Throttle body, how much throttle you are giving, how much acceleration you are giving. Based on that, the air will go inside, and sensors. So air intake. So this is how it works. The air intake. So the air is coming inside through the air filter. There will be a filter which the dust will be there, right? In the air, it will filter that. The air is coming inside through the air filter. After that air filter, the air is going into the cylinder. this each tubes is going inside, right? That is called intake manifold. In this way, you will find the sensors. Near to the intake valve, you will find sensors called intake manifold sensor that will say how much air is going inside. Air will be receiving from outside, like from the environment. If there is a turbo, you will get from the turbo. That is also coming from the environment. So that is how the air intake will work. Does each car require four cylinders? No, it depends. Like there are car with 3 cylinders, there are car with 4 cylinders, there are car with 12 cylinders, 16 cylinders. So it depends on power what you need. If you are using 900 cc or 1000 cc, like 1 liter engine, so you need just 3 liters. 3 cylinders. So like that, they will plan. So if you are driving 2.6, based on that you will use the cylinders. How much cylinder? Depends on the power. Why they are not showing carburetor or fuel mixing? Uh, like you want to see the carburetor or fuel how it mix. So this is how the air will come inside and it will go inside the intake valve. So these are the sensors, and this the way the air will suck inside through the air intake manifold. The air is coming inside, and through the air filter, it's going to the intake manifold. Intake manifold is the nothing but the whole way going before that intake valve. And through when intake valve is open, the air will go inside the cylinder, and the ignition will happen. So this is how it works. So this is how the air intake system works. Next, we are going to see about the fuel system, how the fuel system will work. Here you can see the fuel. The fuel will get from the fuel pump, which is will be in the fuel tank, and it carries through this pipe, and it will the, so there will be before the fuel before it goes to the engine, to the fuel injector. The fuel will be filtered using the fuel filter. So this is the fuel injectors. So there will be a common rail injectors or something. The common rack will be there. So fuel injectors will be attached to it, and it will be injected in the intake valve for petrol engines. So like this only it will inject the fuel systems. So this is how it's sprayed in the intake valve, and near to the intake valve, combustion will happen. This is the fuel system, how it works. Next, we are going to see the ignition system. Okay. Ignition system, what all will be there is the spark plug, ignition coil. You heard of the spark plug, right? Which I mentioned. So the spark plug will be there, an ignition coil, ignition control module. That is nothing but this computer, the ECU. So that will control the ignition, how much spark has to be given, like that, and which cylinder. If there is a 4 cylinder, number third cylinder ignition has to be spark has to be given, like that. It will decide. So we're going to see the ignition. So here you can see the spark plug. The spark plug will be deliver the electric. So that will create the combustion. So this is how the spark will happen. And when the fuel is compressed, right? Fuel and air is compressed, right? There will be a more pressure at the time. At the time if the spark happens, the combustion will happen. This is the coil path which gives the electric current to this spark plug. This is the engine control module which I mentioned. How much, which spark has to be activated, how much current has to be given, like that, and all. This will give the information. This will decide air to fuel ratio, how much it will be, and everything. This engine control module will decide and tell to the sensor or particular system, and they will do. And next, lubrication. Lubrication, you will see that lubrication. Someone asked about the lubrication, right? So I can show the how the lubrication works in engine, particularly. So this is how the look. There will be an engine. Right, the channels will be going right. Did you saw that yellow lines? Those are all its channels where the oil is passing to lubricate the camshaft, lubricate the cylinder sides. The that yellow lines and yellow areas and all, it's the oil which is lubricating. So you can see this bottom area, big yellow, right? That is the oil pan where oil is will be there in the crankcase, below the crankcase. So from that, the channel is going to all the lines. How it see how it goes the oil. Which is pushing this is the oil pump, and the oil filter will be there, which filters the oil. So this is the oil, and this is the oil pump to pressure to send the oil to the all the channels. This is the oil filter which keeps the oil clean. Okay. This is the oil pump and the lubrication, how it works. Next, cooling system. This is not fuel system. This is cooling system, how it works in engines. We are going to see. This is the cooling system. So the cooling system consists of radiator, coolant pump, cooling channels, and you will have a radiator fan. Um, so these are all used to cool the engine. So how it works, we will see in this. This is the radiator, which the front area of the radiator, and the coolant tube is going, and the coolant channels will go around the cylinders and the cylinder head, the top area is there, right? It will go around that. This will keep the temperature in the optimal range to improve the efficiency. So there will be a radiator fan. After passing through the cylinders, the hot coolant will go through the radiator to the each channels. You see the grill, right? This fan, what it will do is the fan will suck the air from outside and cool the coolant. So this is how the cooling system works. Here, this is the water pump, which pushes the cooling inside, pull and push the coolant inside. This valve will sense temperature and open and close. So this is how the coolant system works. Next, what we are going to see is exhaust system. Exhaust system is nothing but after the cylinder, the power, it's combusted, right? Power has happened, right? It's combusted. That hot gas will be there inside the cylinder. It pushes through the exhaust valve, right? I said it will go through the tailpipe. That means exhaust pipe. So what are all, they won't allow that directly to the atmosphere. It's called emissions. They won't, it's contagious to health. So it's hot for the health. So they won't allow that directly to the environment. They have certain components to control the emissions. So like catalytic converters in petrol engine, they use the catalytic converter. In diesel engine, there are many components are there. Diesel oxidation, many components are there. So they will use those kind of components to reduce the emissions, and they send to the environment. So you also heard about that Bharat 1, Bharat 2, BS4, BS5, BS6. These are the emission standards these car companies has to follow. So they have certain norms. So to control the engine emissions, they have to use this kind of components, converters, to match that values that are regulation norms. So this is the thing what we are going to see in this video. So this is the exhaust pipe. The exhaust gas is coming, right? It will form like this. This is called exhaust manifold. Near the four tubes is there, right? That is called exhaust manifold. So it will go through the exhaust pipe. So it collects from the gases from the engine, and it will go through the one pipe to this particular area. This one area is there, right? That is the catalytic converter, which it has some chemicals, some components inside, and it will reduce the emissions. It will convert the emissions, it will reduce the emissions, and leave it to the atmosphere. And one more part will be there, right? This is the muffler. So this will reduce the sound, exhaust sound. There are regulations for sound also, right? So this muffler will reduce the sound, and it will give it to the exhaust. So this is how the exhaust system works. And electrical system, yeah, each manufacturer has their own temperature limits. The coolant intake coolant degree should be this much. The outtake degree should be this much. The 40 degree should be the intake coolant. Before going to the engine, it should be 15 degrees Celsius. Outside, it will be this much, and the radiator has to cool this much. It has a temperature sensor, so it will sense the temperature, and it will make the coolant accordingly by increasing the flow rate of the coolant, or increasing that radiator fan is there, right, to cool even more faster, increasing the speed of the radiator fan that they will do. So electrical system. What are all electrical system in the vehicle? Battery, auxiliary battery, everyone knows, and alternator. I will explain about alternator. Wiring, like wiring harness, we already know. What the bundle of wires which connected to the sensors and everywhere is called the wiring harness. And various sensors. What are all sensors will be there? Ambient sensor, temperature sensors, oxygen sensors, many sensors will be there. So those sensors, actuators, door actuators are there. If you want to open the door, there will be one system will be there. Those kind of actuators, those kind of systems will be in the car. So what is an alternator? Alternator is nothing but, I will show in this video itself. So it will be easy. This this is the that big motor type one is there, right? That is an alternator. When the engine is running, one belt is will be connected to the this particular alternator. So what it will do is, when engine is running, it will generate electricity. So it can be act as a generator. So it will generate electricity. That electricity will transfer to the battery. It will charge the battery. In EV, we do the charging with the DC-DC converter, right? Because we already have a battery inside, huge battery. So with DC-DC converter, we can charge the auxiliary battery. But in IC engine vehicles, we have to charge the battery using this alternator. So this will charge the battery. And this one small device is there, right? Like gray color. That is the starter motor. So that will while you're doing the self start and ignition start, this will rotate that crankshaft and it will start the engine. So this is the two main electrical devices in the cars. Remaining everything is the spark plug also is connected to the electrical, and various sensors will be there, actuators will be there. So spark plug and everything. So these are the electrical systems in the vehicle. Emission control system. Now I explained about the emission control system, right? In the exhaust pipe, what are the emission control systems will be there? Catalytic converter, you saw. The sensors, oxygen sensors will be there in the exhaust pipe. And the exhaust gas recirculation valve. I will show that in one picture. Turbo, yes, turbo is a different topic. Turbo, I can show you. Wait. So this is the wiring harness. battery will be there, alternator will be there, and a charge starter motor. So the how the wire is connected. So this is just a small layout, just the basic, very basic layout. So it's connected. And I will share this video also. The video, the Eric, the copy. He explains how the devices will work and everything they will explain in this video. So now what we are going to see is yeah, turbo you guys asked, right? So turbo is nothing but you can see the turbocharger here. So what it will do is there is a combustion happening and you are getting the exhaust gas. Okay, instead of giving out exhaust gas directly to the environment, the exhaust gas is a more pressured gas. So using that pressure, that flow rate, so you can rotate something. Okay, so you are using the turbocharger. You are using this side to rotate and suck the fresh air even more faster. If you are giving the intake air, normally the intake air will be in certain MPa, okay, certain bar. Normally the intake air will be in the certain bar. Like let's say the intake air will be in 1 bar, 1.2 bar. It's atmospheric bar. So if the intake air pressure is high, when intake pressure is high, it will create more power in the engine. So how you will do is using the turbo. So using exhaust gas, you will rotate this faster, this side faster. That will rotate the fresh air side faster. That will suck more air inside and give the pressurized air to the engine. So that will create the power. That is how the turbocharger will work. How supercharging will work? They are connecting exhaust gas to the turbine, right? So what they will do is from this crankshaft, and you saw that crankshaft, right, in the vehicle. So they are connecting alternator to it with using one belt. So with the crankshaft itself, they will connect one belt to this turbocharger. So using that, they will rotate and they will suck the fresh air inside in a high pressurized air. So that will create more power. This is how the turbocharger and supercharging will work. So exhaust gas recirculation. So the exhaust gas recirculation is nothing but the exhaust gas is going out. So instead of going out directly, they will circulate. They will one pipe will go to the turbocharger to bring in fresh air in more pressurized way, and another one valve exhaust gas EGR valve is there. Right, the valve what it will do is at certain time the exhaust will be the combustion won't be happening fully, so some fuel will be left in the exhaust itself. So it will reroute the fuel to the intake. So they reroute this gas into the intake to combust again. So that will create a power. So this is how the exhaust gas recirculation. No, turbocharger won't fuel economy will not be more. It will make an engine efficient, but it depends on the speed what you drive. If you drive the turbocharger in the low speeds, you won't get that fuel economy. So you have to drive in the particular way, so you will get the economy. But the performance will be high if you use the turbocharger because where you are getting 1 bar pressure inside, at the time you are getting using turbocharger, you are getting 2 bar or 3 bar pressure inside. Of course, your performance, the power will be more, the performance will be more. The turbocharger main purpose of using is for performance, and the fuel will be combusted fully. So in the high volts, not in the low powers, in the high volts. So yes. ECU. ECU is nothing but that I showed, right? One module which controls the ignition timing, when the spark has to come. All the electronic components will be there. It's controlled by one computer. That computer is called ECU. So, for example, here the VCU is connected to the switch input, key signal, charger, accelerator pedal, how much throttle they are pressing, it will send to the information to the VCU. Then VCU will send information to the throttle, how this much is opening, so this much air is coming in, so this much fuel you have to inject. Like that, it will this VCU will do all the this VCU will have all the algorithms inside, and it will give out the certain controls to the system. So other auxiliary systems like power steering, air conditioning system, charging system, they are mentioned in this.
Just a quick info, guys. Intellipaat offers electric vehicle course training. Through this course, you will learn vehicle fundamentals, battery technology, battery sizing, mechanical subsystems, charging infrastructure, and much more from the top 1% of industry experts around the world. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, the link of which is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of EV.
And this is the main topic what we have to cover. It's about the hybrid vehicles. So I think in the fresh mind, if we start with this topic, it would be more understanding, I guess. So I thought of starting with this slides. We are going to see about hybrid vehicle. So what are all vehicles, energy sources of energy for to run the vehicle? So first of all, we are going to see. So here we are seeing the conventional vehicle. Conventional vehicle is nothing but the IC engine vehicles, the spark ignition vehicle, petrol engine, diesel engine, CNG, so LNG. So those kind of fuel-based vehicles and engine-based vehicle is the conventional vehicle. So here the sources of energy is fuel, and fuel consumption will be there, and there will be a lot of emissions in the engine-based vehicles. So next, what we are going to see is hybrid. In this hybrid vehicles, there are many types of hybrid vehicles, full hybrid, plug-in hybrid. So, and many types are there. So we are going to see one by one in this today topic. But the first one is hybrid vehicle. Hybrid vehicle is nothing but full hybrid, what they mentioned about. So there will be an engine also, there will be a battery also. So, but the engine will supply electricity to the battery to charge. There will be no plug-in through the outside connectors. There won't be any plug-in in this vehicle. So, for example, I can show in a picture. Yeah, I hope it's visible. So, this is the hybrid vehicle. So, there is no charging port, but there is a battery, and there is the engine, there is a motor, but there is a no charging. So how the battery will get charged? There will be a engine, and there will be a generator. There will be a motor to run the vehicle, but there will be a generator also to supply the electricity to the battery. So the engine will run, and the generator will run, and the generator will supply to the electricity to the battery. And this battery will charge up, and the battery will supply to the motor to run the vehicle. This is how the hybrid vehicle works. Yeah, that's how I'm explaining like how it charged. So this is how in full hybrid the vehicle is charged. Okay, so here this is how it charged. So only they mentioning the sources of energy is fuel only. Okay, so there will be a fuel consumption, and there will be a battery also. So here why emission is less means the engine will run at optimum point. So you will if the engine is running at the lower speeds and lower speed, so you will get more emissions. In the higher speed, you will get the more emission. Here that won't happen. Like mostly it run in the optimal speed, and it will give energy to the battery, and battery will supply to the motor. In the lower city and all, the motor will run. In highways and all, the engine will run like that. So it makes the emission less. That's what they're mentioning about. And a plug-in hybrid. Plug-in hybrid is nothing but you will have a fuel also. You will have a charging port also. The battery will charge using the plug charging port, and the engine will run with the fuel. So both will run the vehicle. It will run through the motor also. It will run through the engine also. So this is how the plug-in hybrid work. Plug-in hybrid is nothing but the battery will charge through the adapter plugins. How to switch from the fuel to battery in hybrid, that and all, it will the computer will take it, the ECU will take it when it has to switch, like low speeds and all, the battery has to and the motor has to run high speeds and all, this engine has to run like that and all, the ECU will take it. Yes, but in plug-in hybrid also there are some ways, like I will explain what are all hybrids itself. What are all is that there are many types of hybrid, which needs generator also. Yes, in ACU itself, all the integration will be done. Like you know about the cars, right? With like in idle, while in the traffic, while in the traffic signal in idle, the engine will switch off automatically. When you press the clutch or the press the accelerator, it will turn on automatically. The turn on is hybrid. That is a mild hybrid. So that are you are not turning on, right? The ECU is taking care of. So ECU is the electronic control unit, or VCU, you can say, vehicle control unit. That is a computer in the vehicle. Then you can see here all electric. There will be no engine. The vehicle will be totally running with the battery and the motor. So there will be no emissions from this vehicle. Next, what we are going to see is the fuel cell. I think I explained clearly about the fuel cell in the starting of the session itself. So I will explain again, like in the short overview. You will have a hydrogen tank also. You will have a battery plug-in charging also. So with that, it will run. That will be a fuel cell stack which converts the hydrogen into electricity, and it will charge the battery, and through the battery the electric motor is connected, and the electric motor will run. So like that, this the electric fuel stack will be there, right? Which gives the electricity. It will also directly connected to the motor, so sometimes it will run through directly, or sometimes it will charge the battery. So why here emission is there? This is not particularly emission, this is H2. So while converting this hydrogen into electricity, you will get out heat and H2, that is water. So you will get the emissions out like a H2 and heat. So yes, this is how it works. I have one video also for fuel cell. How it works, it will clearly explain. So I will show here. There will be a hydrogen tank. The three round is there, right? That is a hydrogen tank, which they will store the hydrogen. And this one's rectangle box is there, right? That is the fuel stock. It's like a battery only. Inside the battery, there will be a cathode, and in middle the electrolyte will be there, right? It looks like that only. So see, so they will supply the oxygen to one side, and another side they will supply the hydrogen. So the positive particles and the hydrogen atoms, right? So it will pass through this membrane. The negative is the electrons. So the electrons will pass through the one shield, one line. So that will create the electricity. So this it passes through this side, right? So this is the emission it will produce, the H2O. So this is how the electricity will produce in the fuel cell, and it will supply to the battery. So this is how it works, the fuel cell. I just want to explain how it works. It would be more understanding for this. I will put this all the link in. I will share the slides. You guys can take the links from the slides. Yeah, there are many vehicles. Like you know about the Toyota Mirai. Honda also have the fuel cell vehicles, but not in India is very minimal. But there are vehicles, fuel cell vehicles. There are many trucks. This is that. I didn't say the plug-in hybrid doesn't have emission. It has the emissions. So where it says it has no emissions. Plug-in hybrid has emissions. So because it has an engine inside, so there will be emissions. So it has emissions, but when compared to hybrid, it will be minimal because the engine capacity is very less. The battery capacity will be more. So mostly the battery, the motor, the battery supply to the motor will run, and the engine will run at the highways and the straight roads like that, long drives like that. At the time, the engine will run at the optimum point at the higher efficiencies. So the emissions will come out less. So this is how the different sources of energies. We are going to see in the further slides each and every hybrids and how it works and everything and all we are going to see. So yeah, now we are going to say about hybrid vehicles. What is hybrid vehicles? Using two energy sources in one single vehicle itself is called hybrid vehicles. So, for example, what are all the hybrid types of hybrid vehicles is there? So, diesel hybrid is there, diesel and with electric motors, and the gasoline like petrol with the electric motors, nuclear energy with the electric motors, fuel cell we saw that is a fuel cell with the electric motor. So these are all it's the hybrid vehicles. So how in the hybrid vehicle itself there are many types of hybrid vehicles. So there are the mild hybrid or mild, or you can say is a micro hybrid, medium hybrid, full hybrid, so and a plug-in hybrid. So there are many types of hybrid vehicles. So this what they mentioned, degree of hybridization is nothing but how much percentage hybrid it's using in this vehicle, how much percentage of motor power using in the vehicle. So for example, they given HEV, hybrid electric vehicles, with motor rated as 50 kilowatt and engine rated as 150 kilowatt. So we'll have a hybrid. So the hybridization ratio is 25%. So at 25%, it will come under the medium hybrid category. Below 10%, it's a mild hybrid or micro hybrid category. In 10 to 30% is a medium hybrid category. Above 30%, it will be a full hybrid or hybrid vehicle categories. So this is how they split the hybrid vehicles. So in the hybrid vehicle itself, there are many types, right? According to the degree of hybridization, according to the how much percentage of electrical energy is used in the vehicle. That is according to the degree of hybridization. We saw that how much percentage, right? So in that there are different types: mild hybrid, medium hybrid, full hybrid. There are three types in that. So why they call it as a mild hybrid, medium hybrid, full hybrid is how much percentage of electrical energy is used in the vehicle. So mild hybrid is less than 10%. Medium hybrid will be 10 to 30%, and full hybrid will be above 30%. That is how they split the vehicle as a hybridization. Next, according to the architecture and the motor. So in hybrid itself, there are many types of hybrid. Okay, so there are called parallel hybrid, series hybrid. I will explain one by one. Parallel, what is parallel hybrid? What is series hybrid? We are going to see the layouts in the upcoming slides, so you will get a clear idea of what I'm saying. So parallel hybrid, series hybrid, complex hybrid, series parallel hybrid. So these are the architecture. So it's nothing but how they place the motor and what a motor will directly connected to the wheel, or engine will directly connected to wheel, or both will connected to the wheel, or the motor will act as a generator and supply to the battery. How which category what layer will be, everything will be seen in this architecture. And according to the position of motors, so where you are going to place the motors. Okay. P0, P1, P2, P3, P4. These are all the topologies, layout topology. So where you are going to place the motor depends. Like P0, for example, you will place a motor near to the engine and connect with the belt. Like you saw that alternator, right? Like that, one motor will be there. Motor will be there, not the alternator. Motor will be there. So it will be connected to the crankshaft to the with through the belt. So that is a P0. So if you place the motor after the engine flywheel, like connected to the engine flywheel, the crankshaft flywheel, directly. So that will come under one P1 category. So like that, there are different categories where you place the motor according to the number of motors. Okay, how many motors you are going to use in one vehicle? There is a electric. You can use the two motors, or you can use the four motors in each wheel, one motor. Like that, you can use, or with a single motor, you can run the vehicle. Like that, those categories we are going to see, the layouts we are going to see in the upcoming slides. So first, what we are going to do is we are going to start with degree of hybridization, like a mild hybrid, medium hybrid, full hybrid. What it is, we are going to see. So first one is mild hybrid. I will share my thing. So mild hybrid is nothing but you will have one small battery, 48 volts battery. You can see, right? You will have one small battery, 48 volts battery, and you will have one small motor, 48-volt motor. Maybe the capacity will be 10 kilowatt. If the vehicle engine capacity is 150 kilowatt or 160 kilowatt, I just have a 10 kilowatt motor, small motor. Why they are using small motor is this will be used for this will be used for acceleration, to help the acceleration purpose. In the acceleration, the motor will push the crankshaft even better, and it will give more push to the vehicle. And it can be used in idle stop start. In a traffic and all, you will stand. You will no, nowadays vehicle and all, it will stand and the engine will turn off. And when you press the accelerator or a clutch, it will automatically turn on. So those things and all taken care by this mild hybrid. And those thing and all categories will be come under the mild hybrid. This mild hybrid vehicles can't be run the vehicle on its own. The motor can't run the vehicle on its own because it's very small motor. So it won't push the vehicle on its own. So it will just support the engine to at the acceleration time and the idle stop start time. So this saves the fuel. Like in the vehicle, if it is in the traffic, the vehicle will be in idle, right? Mostly. So while in idle, it will consume the fuel. So to stop that, they bring up this method. So it saves the fuel. And in the acceleration, so the in engine and all, the starting torque will be very less. At certain point only, you will get the torque, max torque. So at the starting stage, the torque will be very less, right? At the time, this motor will help to achieve that torque. So improve the acceleration. So this is the purpose of mild hybrid. So that's what idle stop and one more thing, regenerative braking. So when you take your when you're running, vehicle is running. So when you take the foot from your pedal, there will be a motor braking, right? There will be some slow braking will happen with the motor without pressing a braking pedal. Some brake pressure will be there the vehicle. So those motor braking will be recovered by this motor, this 48 motor, and supplied to the battery, and it will store in the battery. So this is how the regenerative braking works in this mild hybrid. And yes, 48 volts. It saves. So this helps to save 5 to 10% of fuel totally comparative. So, for example, what car in Maruti Ciaz is there, Honda City is there. In many vehicles, the mild hybrid is there. If there is a 48-volt system, which you saw in the vehicle, that is a mild hybrid vehicles. But this won't have a capacity to run the vehicle. It just supports the vehicle. Emission level will be normal. Like in the idle conditions, the emissions won't you won't get that emissions alone outside. And at the acceleration condition, you will press the pedal so lot, right? At the time, you will get more fuel emissions. So it will restrict those emissions. So when compared to the normal IC engine vehicle, normal petrol engine vehicle, normal diesel engine, it will be little bit very slow. So very less. That's all. So not that much difference as in terms of emissions. It won't drastically reduce, but little bit for sure it will be very less because it won't run in the idle conditions. That time the emissions will come right in cities and all the city traffic conditions and all. So those things it will take out, and at the acceleration it will help. It's mainly used to improve the fuel economy. That's all. Okay. Next, what we are going to see is and one more picture I plan I want to show. So you guys can see this picture, right? Yes. So this is how the 48-volt system looks like. That mild hybrid will look like. There will be a 48-volt system that is a battery, and there will be a 48-volt lithium-ion battery will be there, and AC to DC converter. So this is if you are going to use AC motors, so you have to convert that DC voltage into AC, right? So they are using AC to DC converter. So the electricity is supplying through this converter and will just directly going to the motor. So you can see the green motor symbol, right? So that is the motor. And yeah, so this red color box is the DC-DC converter. It's a 48 volts battery. So you have to reduce that 48 volts to 12 volts. So it will supply that to the DC-DC converter, and DC-DC converter is supplied to the 12 volts battery, and it will supply to the all the electronic components. This is how the architecture looks. And you can also see this green motor, the how it's connected to the and in this also you can see the 48 volt system starter generator, how it's connected to the engine. So this is the Audi powertrain. So this is the mild hybrid. Shall I go to the medium hybrid? Mild hybrid, you can use the DC motor also, you can use the AC motor also, because it's a very low voltage, low power system, right? If you are going to, if the car is having any 5 kilowatt motor or say a 6 kilowatt motor, like that, you can below that you can use a DC motor. Above that, the only AC motor is suggestible. So because it's more reliable, durability will be more. So and speed adjustment will be more. So many advantages are there in the AC motor. So mostly in the high power motors and all, like above 5 kilowatts, they use AC motors only. So only in they mentioned 10 kilowatt in this mild hybrid, so they are using AC motor. And for that AC motor, you have to use the converter to convert that DC voltage into AC voltage. So it depends, AC or DC given to them. It depends on what motor you are using. If you are using the AC motor, you have to use AC voltage and DC. No, if DC motor is there, we don't need AC DC converter. So you can directly connect battery to the motor. There will be a controller in between to how much current it should pass, like that, and all it will control. Okay, let's go for medium hybrid. Now, medium hybrid is nothing but you're using 48 volts. Medium hybrid is nothing but you're using the 48 volts system in the mild hybrid, which doesn't support two vehicle to run. And it's a small battery and the small motor which used for acceleration purpose. Medium hybrid is nothing but you are using little bit higher version, very little bit higher version. Like you are using any high voltage, like 120 kilowatt, 120 voltage battery and a 120 voltage motor, like that. If you're using 10 kilowatt in the mild hybrid, you will use in medium hybrid 20 kilowatt or 25 kilowatt motor. So those things will be used in the medium hybrid. The same usage like a mild hybrid, idle stop. They will use this medium hybrid. Regenerative braking will happen in all the hybrid cars, like that regenerative braking, but not capable to push the vehicle that much. It doesn't have that much power to push the vehicle. And yeah, it will increase the cost of the vehicle because you are having a little bit higher voltage of higher capacity battery and higher voltage motor, so it will increase the extra cost of the vehicle, and it will save the fuel because it will help a lot in acceleration purposes and low speed purposes. It will support the vehicle. So, for example, in Honda Civic, I got only one example, the Honda Civic, and some vehicles, high performance vehicle also, they use the medium hybrid. It's 158 volt means nothing. The voltage of the motor is 158 to supply. You have to supply 158 voltage to the motor. 144 voltage, not 144 voltage. Next, we are going for full hybrid and the storm. Regenerative braking is nothing but you are doing the braking, right? You ride bike, right? With you ride bike, right? So if you release the clutch while riding, you just release the clutch. There will be a motor braking. There will be a motor braking. So that motor braking, if you have the motor in the bike itself, it will observe that motor braking. So and it will convert that into electricity and supply to the battery. That's all. So I have one video for regenerative braking because you guys asked many times about the regenerative braking. I have one video also. I will show it. Okay. What is idle stop? Idle stop means just without gears. If you start the vehicle, it will just be in one condition, right? Running condition, not the vehicle moving condition. Just the vehicle will in the running condition. So that is idle. Like without gears, just one idle position will be there, right? Just being in the same position, the vehicle will be running, right? That is the idle. Idle stop means in the traffic, if you ride some nowadays vehicles and all, if you ride right in the traffic, it will automatically stop the engine. You won't get the engine sound and all. When you press the accelerator, the engine will automatically start and you can run the vehicle. You don't have to start with the key. While pressing the accelerator itself, so you will start the engine. So those things are all taken care by this small motors. And when to start, when to stop will taken care by ECUs. Strong hybrid and full hybrid. Strong hybrid and full hybrid is nothing but you can run the vehicle. There will be a big battery, there will be a big motor, there will be engine. You can run the vehicle with the engine also. You can run vehicle with the battery and motor also. That's all. So it of course it will be helpful in idle stop because in cities and all only the motor will be running because motor in the low speeds engine has a very low fuel economy. You know, right? You used to hear in cities it is giving less fuel efficiency like that. So in the engines and all. So in the cities, in the hybrid vehicles, they use the electric motor to run, and highways they will use engine to run. Or there are some architecture you can run both at the same time, and you can run the vehicle. So this is how the hybrid vehicles work. So it helpful in idle stop and regenerative braking. It will help capable to push the vehicle with the motor itself, and the cost will be more because you are using the big batteries. Engine also, motor also. There will be a generator to which the engine can run and supply that electricity to the battery. So many components will be there. So, but the main advantage is it saves a lot of fuel, 30 to 50% of fuel when compared to ICE engine. You can save on this. So, the main example of full hybrid vehicles are you heard about Toyota Prius, Grand Vitaras, and all. It has the full hybrid. Yeah, you can. Lithium-ion batteries, nothing depends on what kind of car. It depends on, like, if you are using what kind of performance you are going to use. If you are using high performance, going to use in the high performance vehicles, you have to use the lithium-ion in different chemistries. So lithium-ion is a common term. Like nowadays, many things are coming. How cost effective? How cost is affected means you are using many parts here. Like there is when compared to IC engines, there is only the engine will run the vehicle. Okay, there is no motor, there is no battery, there is no generator, and there is no connecting parts, the transmission to connect the everything. So those and all extra cost. So those and all will be there in the hybrid vehicles, but it will save the fuel. The one-time payment will be more in hybrid vehicles. The starting initial payment will be more, but operational cost will come less. NMC for high performance they will use, and NC is the main thing for high performance. Nowadays, Ather, TVS, that Vola and TVS iQubes and are using the NMC, but you can't say Ather is high performance, right? So, but NMC chemistry is high performance, but not when compared to NCA chemistry. So yeah, this is the full hybrid vehicle. Full hybrid vehicle is a short summary. It's nothing but you can run the vehicle with the electric power itself for short distances in cities and all. In long distances, you can use the engines or both you can use. So yeah, you have a greater flexibility of using at what situation what should use. That will save a lot of fuel efficiencies. Um, and it will gives out less emissions, and the acceleration it will help lot smoother acceleration it will give. But the only disadvantages is more expensive, and the weight is also will more because more components are there, so weight will be also more. Yeah, of course they will reduce the engine size for full hybrids. They will, for example, if 150 kilowatt vehicle, if they use four-cylinder in a vehicle, in the hybrid engines they will use three cylinders, and the motor will fill the remaining power. Like that only they will use, but it doesn't reduce the cost that much when compared to hybrid vehicles because you are using more components in hybrid vehicles. So this is how the hybrid vehicles differences we saw. Any doubts in hybrid vehicles you guys can ask, you can ask. So I can move to the next. In the hybrid vehicles itself. So here we saw the degrees of hybridization, like mild, medium, and full hybrids. What are all it's there? Next topics, what we are going to see is architecture of the hybrid vehicles. So whether it's a parallel hybrid, series hybrid, what kind of hybrid it is, we are going to see in this upcoming slides. First, what we are going to see is series hybrids. Series hybrid is nothing but this is also a hybrid. You can see that engine is there, generator is there, motor is there, battery is there, inverter is there. So everything is there. This is called full hybrid vehicles. In the full hybrid itself, you have a series hybrid, parallel hybrid, series parallel hybrid, like that. Three differences are there. So we are going to see one by one. What is that? Okay. Difference between mild and medium is only the power level, not the voltage level, the power. You will use less capacity battery. If you are using a 5 kilowatt motor, a 10 kilowatt motor and 5 kilowatt hour battery in mild hybrid, you will use 10 kilowatt motor and 10 kilowatt hour battery in a medium. Yes, we are going to say about the series hybrid. Series hybrid is nothing but the engine won't be connected directly to the drive wheels. Only the motor is connected directly to the drive wheels. So the motor will run the vehicle. The engine can't run the vehicle. The engine only supply the electricity to the battery. How it will supply means the engine will run the generator. So here the motor acts as a generator. So the engine will directly connect it to the generator. This generator will supply the electricity to the battery. So there is an inverter. Inside the inverter, there will be a rectifier. So that will supply the electricity to the battery and it will store the energy. And that energy will be given to the motor and it will drive the wheels. Sometimes what will happen is this is one scenario. Another scenario is the engine will be running the generator, right? And it supplies the electricity. This electricity can be directly given to the motor and it will run the vehicle. So this is the series hybrid. Series hybrid is nothing but the engine won't be directly connected to the drivers. So this is the series hybrid. So what they mention is utilizes an ICE as a generator to produce electricity, which powers the electric motor that drives the vehicle. Can operate in electric only mode. Yes, well, because motor is only the running thing, right? So it operates only in through motors. ICE serves as a range extender as a range extender, I mean, it gives the extra ranges. So like that they mentioned. When a battery is low, it will give the electricity to the motor to run the vehicle like that. So at low speeds and all, only the motor will run from the energy, take the energy from the battery, and only the motor will be running. Engine won't be running. The engine just it will run and it will supply the energy to the battery. The main advantage is why they invented the series hybrid is the engine. Right? Engine won't be having the optimal point at every time. Like in all the speeds, the engine won't be running in the optimal point. There is a certain RPM, like let's say the 4000 RPM, 4500 RPM, and the engine will be running at the optimal point. Optimal point means higher efficiency point. So the engine will always be running at the same speed, same point, and the fuel economy will be very good. So that in this, so it will supply the electricity to the battery. The engine will be running at in the one point and supply the electricity to the battery. That is how it works. Engine can operate at the optimum point to achieve the best fuel economy. So this is the series hybrid. Here motor is AC. You saw that inverter, right? Whenever the inverter is there, you have to assume the motor is AC. Yeah, the engine, it depends. The engine don't, like if the battery is full, the engine won't be running. So engine will be shut down. So there will be no emissions at the time. Like that. It depends. Whenever the battery is, there is a gap in the battery, it will give, or whenever you want to run in the high speeds and all, it will, the battery will also supply the current. The motor generator will also, the engine will also supply the current and it will run the motor. Like that, it will work. Yes, since the generator is AC, why inverter is like it has to supply to the battery, right? So it has to, the inverter will convert, not only convert the DC to the AC. Inside that inverter, there will be a rectifier also. It will convert the DC to AC to the DC. Yeah, speed of the engine not depends on the driver. The speed of the engine totally depends on the optimal point here, because the engine is not directly connected to the wheels. The motor is only connected to the wheels. It will be only in the constant mode. The purpose of generator is like it will supply the electricity to the engine can't directly supply the electricity to the battery. You need some generator to supply the electricity. So the engine is connected to the generator, it directly supply to the battery, or it will directly supply to the motor. Okay. This is series hybrid, what we saw now. How the case in series scenario, when the vehicle is in traffic, battery low, engine is not the optimal speed. Yeah, at the time the engine will be running at the low speeds. It's not like engine can only run at the optimal speeds. When there is a scenario, the engine has to run the low speeds, or it will run at the optimal speed. It will charge the inverter. It will supply the electricity to the motor. Sorry. I'm wrong in this. The engine will always run at the optimal speed, because in the traffic scenario you mentioned, right? Battery is low, engine is not at the optimal speed. Engine will be in the optimal speed. It will supply the current to the through the inverter, and the motor will be running the drivers. Maybe the engine can be running at the higher than the optimal speed to supply more electricity. At sometimes it might happen. What is the role of the gear if it is controlled with the motor? The gear, you need the speed reductions. Depends on the torque and the speed what you want. You will use the gears in between the drivers and the motors. If the engine is shut down once, if the ECU will take, there will be a starter motor in the with the engine. So whenever the engine needs to be started, the starter motor will start the engine. Yeah. Okay. Let's move to the parallel hybrid. This is not the picture for parallel hybrid. There will be one connection. The engine. The main thing is parallel hybrid is here. You can see the parallel hybrid. The engine are also directly connected to the drive wheels, and the motor will also connected to the drive. There will be a mechanical coupling. Mechanical coupling is nothing but one kind of transmission. The coupling transmission will be there. So whenever you want to run in the vehicle want to run in the engine, it will run through the engine. Whenever it want to run through the motor, then it will run through the motor. For example, ICE will run in high speed applications like highways and everything, and motor will be running in the cities areas. So this is how the parallel hybrid works. So in series hybrid, the engine won't be directly connected to the drivers. In the parallel hybrid, the engine will be connected to the drivers and motor will also connected to the drivers. This is the difference. So here it combines the IC engine and electric motor to drive the vehicle simultaneously. So the electric motor assists the engine during the acceleration. Yeah. So They can operate in the electric only mode for short distance, like in cities, in traffic conditions, it will run only in the electric mode also. Regenerative braking will be workable in this because you have a motor that is connected to the drivers. So regenerative braking is also possible with this. It all offers the improved, yeah, it will offer the improved fuel economy because then cities and all, it will be running in the using the motors. There you will save a lot of fuel, and then there are many conditions you can save the fuels. This is how the parallel hybrid work. The battery may change in different types. I didn't understand the question. So no charging in this case. Charge if it is a plug-in hybrid, you have to that they will give a charging. If it is a full hybrid, like, there will be no charging port. The charging will be done through the engine and the generators. Which it depends on car manufacturer. There are vehicle with parallel hybrid. There are vehicle with series hybrid. It depends on what scenario you are using that vehicle. Okay, so series hybrid can't be used in high long distance it can be used, but mostly they won't be used in a long distance application, high speed applications and all. So because the motor is running the vehicle, right? So it mostly used in the cities and daily commute conditions. If it is a plug-in hybrid vehicles, it's possible to the manual output. There will be a port that you can do the charging. So if it is a full hybrid, there will be no port. You can charge only through the engines and generator. I hope what is series hybrid and plug-in and the parallel hybrid is clear. Next, we will move to the series parallel hybrid. So combining the series and the parallel in one vehicle is the series parallel hybrid vehicles. So you will have the engine. So it will be the engine will also directly connected to the drive wheels, and the motor will also directly connected to the drive wheels. In the parallel hybrid, we saw that engine won't be supplying electricity to the battery. In series parallel hybrid vehicles, there will be a generator. So engine will also capable to supply electricity to the batteries to store energy in the battery, and you can use that energy to supply to the motor. So yeah, combining the series hybrid vehicles and parallel hybrid vehicles is the series parallel hybrid vehicles. This vehicle you can see Toyota Prius, the latest vehicles and all, they use the series parallel hybrid. So the main thing is it will combine the series hybrid also, parallel hybrid also. They allow the vehicle to operate entirely in the gas in the engine type also. It can be independently run through the motor also. So both ways it can be run. So the engine can be used to charge the battery because there is a generator, right? The engine is capable to charge the battery through this generator also. So everything can be done. This is the most efficient powertrain. So you can play around with many scenarios in this powertrain. Like at the slow speeds, you can use the motor. In the high speeds, you can use the engine. While using the motor, the engine can be run because there is a power split device, right? While running through the motor, the engine can be directly run and through the generator, and it can supply the to the battery. Or if you need more and more power, you can couple both engine and motor together and supply to the rear wheels. Yeah, many scenarios is possible in this powertrain, but the disadvantages of this powertrain is like weight will be very high, and the cost will be very high because you have so many parts here. Battery you have, inverter you have, generator you have, motor you have. There is a power split device, and there is a reduction gear. That transmission will be there. There are many parts. The weight will increase and the price will increase. But this is the most efficient powertrain. Engine will be operating in the optimum efficiency at the most of the times, not all the times, most of the times. So this is the series parallel hybrid. In Toyota Prius, you can see the series parallel hybrid vehicles. how your power is supplied in both series and parallel. I didn't understand. Like how power is supplied in both series and parallel means. Yeah, how power the way engine through this power split device, the engine also directly connected to the this reduction gear and it can supply to the rear wheels. This motor will be directly connected to the reduction gear and it can be directly supplied to the rear wheels. So when mode in the city conditions, when the battery, let's say the battery is in 30% charge, so and it's running in the city conditions, traffic conditions. So you have to run with the motor for high fuel economy. Okay. So at the time, what engine will do is it will be running, and the power split device it will be connected to the generator, and the generator will supply the electricity through this inverter to the battery. The inside the inverter there will be a rectifier, so it will supply to the battery. So this is how it works. And at some times, what will happen is when the vehicle is, let's say the battery is 5%, and you can't run with the motor. So at the time, what it will do is it will directly connect it to the rear wheels, the reduction gear. The engine will directly connect it to the rear gear, and it will run the vehicle. But here, what happens is low fuel economy. But there is no other way. You have to run the vehicle for certain kilometers. So you have to run the vehicle for. At the same time, the engine what can do is the engine can run at the optimum performance, optimal point. At the same time, it can also charge the battery through this power split device. There are many scenarios you can play around with the series parallel hybrid vehicles. Is motor and engine or use drive top? I didn't understand the question. So yes, this is how the series and parallel hybrid vehicle works. I hope you guys understand the topology, how the architecture looks like. So next, what we are going to say is, next what we are going to say is, in this vehicles, how the motor placements will be, how they place the motors in the vehicles. So you can't place the motors everywhere. Okay. So there will be some particular architecture where they follow and place the motors. So we saw that here, right? So according to the positions of motor with reference to the IC engine and transmission. In hybrid vehicles, they place the motor according to this topologies. P0, P1, P2, P3, and P5 also that. For here it's not there, but P5 also that. I will show what is P5 motor placement also. This is the motor placements. There is a EM, right? That is the motor placement. Okay. In P0, the motor is placed near to the engine and it will connect it to through the belt. It's nothing but mild hybrid vehicles. You know, right? The 48 volts vehicle I mentioned. So this is how it will be. So that is the P0 topology, portion of motor topology. In P1, what will happen is there will be IC engine, and the IC engine, the crankshaft, the flywheel will be there, right? That will be directly connected to the electric motor. So, okay, that it will be directly connected to the electric motor, and there will be a clutch. The TRN is the transmissions. So there will be a clutch after that. So the ICE will be directly connected to the electric motor. So that is how the P1 portion of electric motors will be there. And I'll share my screen. Before going to the sorry to directly shifting the topic. So I just want to show this, the series parallel hybrid, the series parallel, how it looks like. So this is the difference, how it looks. The series, the engine will be connected to the generator, and generator will be connected to the inverter and the battery. So the inverter will be connected to the motor and to the rear wheels. Parallel engine, transmission will be there. Engine also can run the vehicle, and the motor also can run the vehicle, but there will be no generator to supply to the battery from the engine. So there is no parallel hybrid work and series parallel hybrid. So both the things, the engine, it has a power split device and the generator will be there. Inverter is the, and it will supply the energy to the battery. And from the battery through the inverter, you can get the power to the motor and you can run the vehicle. So through the engine also directly you can run, through the motor also you can run, through the engine also you can supply the energy to the battery. So this is the whole topology of vehicle. Okay. Yes. Yeah, this is the another picture, one more picture I just mentioned. The same scenarios only, but another picture. So yeah, here back to the position of motors. Hybrid vehicles or not all the vehicles are rear wheel drive. It depends on how you place the engines. There you can place the engine at the rear and the motor at the front also. That also totally possible. Yes, the battery will be charged through the external source, like a plug-in hybrid, you can say. Okay, the position of motors. Again, we will come to this topic, the position of motors. So the P0 portion of motor is the engine will be directly connected to the motor will be directly connected to the engine through the belt. So that is called P0 portion. P1 portion is nothing but engine. The motor will be directly attached to the connected to the flywheel on the crankshaft of the engine. So that is one portion of the vehicle of the motor. P1 portion of the motor. If someone asks tell about the P0 portion topology like that, if they say, you have to say the motor will be directly connected to the engine through the belt. Someone asks for P1, the motor will be directly connected to the flywheel or crankshaft of the engine, like that. Yeah. And P2, P2 is nothing but there will be an engine in between the motor and the engine. There will be a clutch. It can engage and disengage the motor. So with the engine. So that is the P2 portion. So here the green portion is the P2 portion. P3. P3 is nothing but after the transmission, you will place the motor. So for example, you can see here this picture. So you know about the P0 directly the belt you will connect. P1 is nothing but next to the engine, the flywheel it will connect. P2 after the clutch, there will be a motor. So it's the and P3 is nothing but while connecting after the transmission, this box is there, right? Different round gears. That is called transmission. So after the transmission, the one shaft will connected to the front wheels. So that shaft, in between the shaft, you will have place the motor. So that is the. So after the transmission, you will place the motor before this axle, before the differential, you will place the motor. That is the P3 portion. So P4 portion is nothing but this is the rear wheel. Let's assume this is the rear wheel. So P4 portion is nothing but you can like a P3 portion, you attach the in the shaft, right? The front wheel before the differential and after the transmission. Like that, in the P4 portion, you will not in the engine area. If the engine is in the front area, you will attach the motor in the rear wheel in the differential shaft. Like before the differential shaft, you will attach this motor in the rear wheel, not in the engine side, the rear wheel. If the engine is in the rear wheel, you will attach the motor in the front wheel. That is the P4 portion. The differential area, the material area, you will attach the motor. So that is the P4 portion of the motor placement. What is the P5 portion of the motor placement? P5 portion is nothing but you will place the motor directly in the wheels. So you heard of four-wheel drive motors, right? So that is the thing. You will place the motors directly in wheel. That is called in-wheel motor also you can see. So the motor will be placed inside the wheels, like a hub motors. So that is the thing. So this is how the placement of motors in the vehicle will be. I will repeat from the first itself. What is P0 portion of motor is nothing but there will be a motor and it will position next to this engine. So the belt will be connected to the motor and the engine. That is the P0. P1 is nothing but in the crankshaft of the engine or flywheel of the engine. The motor will be directly connected to the engine. Yeah, you can say P0 and P1 for mild hybrid. That is the thing. So yeah, in P2, you have there is an engine and there will be a clutch. So and then there will be a motor. So this is how the P2 position is. In between the motor and the engine, there will be a clutch, or there will be no connection also, you can say. There will be a clutch, so it can engage and disengage. So in this P2 position, when the clutch is engaged, this P2 motor is there, right? It will act as a generator. When clutch is disengaged, this P2 motor will directly connect to the wheel. It runs with the motor alone. So this is the purpose of this push. Okay, next P3 portion. P3 portion is after this P2 portion. Before we saw that, right? P2 portion. After that, there is a transmission. Okay, in P3 portion, the motor will place after the transmission while connecting to the differential case. In that area, the motor will be there. In the differential area, the motor will be there. So that will supply the power to the motor, the wheels. P4 is nothing but apart from the engine side. If the engine is at the front side, the motor will be at the rear side, rear area. So rear, that center area, the motor will be attached. So motor will be running in the rear wheel. P5 is nothing but you will place the motor inside the wheel. So it's called as a in-wheel motor. So this is how it works. Yeah, P3 is front wheel drive. In this, according to this scenario, according to this picture, the P3 is front wheel drive. P4 is rear wheel drive. P4, you can say if the engine is present at the front and motor is at the rear, it's the four wheel drive. You can run from the front wheels, although you can run with the rear side. P0 is nothing but the engine will next to that the motor will be there. The motor and the engine will be connected with the belt. In the mild hybrids, you saw, right? The motor and the engine will be connected with the belt, and it used to stop the engine, and for acceleration purpose, it will help the engine. For the purposes, the P0 will be used. So P3 and P4 is same. No, yeah, the working is same, but the area where is the difference is front and rear. Yeah, correct. I think a position of motor is clear. Let's move to the architecture of the vehicle. So in this topic, we are going to see the architecture of the vehicle. What are all components will be there, and everything we are going to see in this slide. Okay. So this is the normal electric architecture will be there. So there will be we will come from the charging port. So there is a charging port. The cable is going to the onboard charger. So this is the AC port. In the onboard charger, it has to pause. The onboard charger will convert that AC current into the DC AC voltage into the DC voltage, and it will supply to the battery to charge. This side is used for charging. And here you saw that, right? DC charging station. So this is the DC charging, fast charging. It will supply directly to the motor, directly to the battery. It will do the charging directly. And from the battery, there is a inverter or controller, you can say, DC to AC controller. So it will convert the DC voltage into the AC voltage, and it will supply to the AC motor. And this AC motor is connected to the single stage transmission, single speed transmission, you can say. So and will connect it to the transmission and is running the vehicle. So this is the architecture how it looks. So if it is a double motor, two motors are there. One is fitted at the front and one is fitted at the rear. You need two controller. One will connect it to the one motor and another will connect to the second motor. So you will need the two controller. So that will connect it to the one ECU. That's how it will look. And here, why there is a two differences, controller and the power converter. So the difference is this power converter is nothing but it will convert the DC voltage into the AC voltage. Okay. The speed, how much throttle is given for the throttle, how much power has to be given, current has to be given from the power converter. Those things and all this controller will decide. So that's what they mentioned here. So in-wheel motor. So in-wheel motor, I mentioned one motor placement, right? For the in-wheel motor. If it is the motor in the four wheels, what is the motor placement topology? It's a P5. So yeah, it's right. P5. So if the motor is connected directly in the wheel, so then there will be a four motors and there will be a four controllers for each motors. We need one controller. I mean the converter to convert DC voltage into the AC voltage. This is the motor layout in the vehicle, how it looks. I hope it's clear. Next, from the slides, we will see about the advantages of single motor, advantages of using double motor, advantages of using four motors in each wheel. We are going to see the advantages and the disadvantages as well. Okay. This slide, what we saw the layout, right? Single motor layout, double motor layout, in-wheel motor layout. So in the slides, upcoming slides, we are going to see advantages and the disadvantages of single motor layout, double motor layout, and the in-wheel motor layout. Gearbox is the transmission, both are same. Gear train, gearbox, transmissions, everything is single. It's a single motor layout of EV. So single motor is only one motor will be using to run the vehicle. Either it will be in the front end, either it will be in the rear end. Don't consider the hybrid vehicles and all. Just we are going to focus on. Let's consider this as the electric vehicle itself. We are going to see whether the single motor layout, two motor layout, in-wheel motor layout. So here we are going to use only one motor to run the vehicle. Okay. So what are all advantages will be in this layout? So it's very simple. Like you will have the motor in front end or the rear end. So the service and maintenance accessibility is very easy when compared to other vehicles. Space optimization, like you will have a huge cabin space and the weight will be less when compared to two motors. You will have an extra one motor, right? So you will, the extra weight will be added up. So here weight will be less. Regenerative braking. If there is a motor you are using in the vehicle, so of course you will get the regeneration out of it. So these are all the advantages in the single motor layout. Disadvantages. So the performance, like the single motor, won't give that much performance when compared to two motors. You will have two motors in each one wheel, and the rear wheel you will have one motor. So the performance will be very limited in the single motor layout. And the handling, like here, in the limited control over the torque vectoring. Torque vectoring is nothing but each wheel how you control the torque. So in the slips area, in the all-wheel drives, you will control the each wheel torque, right? Each wheel rotations you will control it. So you can't control that in the single motor. The motor will be fixed at the front wheel side or the rear wheel side, either. So if it is fixed at the front wheel side, you can't control the torque of the rear wheel side because the motor is not there and you don't have any access to control it. So that's what the limited control over the torque vector. And its redundancy and the reliability. Limited all-wheel drive. So there is only one motor. It will be in the front end or either rear end. So all-wheel drive is not possible. Yeah, torque control will be very less when compared to all-wheel drives because each wheel you can control the torques. So future compatibility challenges. For example, if you are using only one motor, the max performance, like the max kilowatt, you can't increase way too that. Like there will be some limited. According to the motor size, the power will be some limited. So using the single motor, you can't achieve the max higher powers. So yes, now here what we are going to see is the two motors layout. So the motor will be either put it up on the front side or either at the rear side. For example, yes, you can see. So the motor will be either put it at the front side or either at the rear side. In the L3, you can see front or rear. You can place the motor. So, what are the advantage and the disadvantages in this kind of motors? So, you have a good performance. because you have a two motors. Two motors helps to push the vehicle, so you have a good performance and improved handling. You have a motors in the each front side and the rear side, so the torque control will be more is very good. So you can handle the vehicle very good. So by controlling the each wheel side, all-wheel drive capability is possible like this because the motor will be at the front also, rear also. All wheels can be driven. Efficiency will be very high. And disadvantages. The cost will increase because you are using one more motor, so of course the cost will increase. And complexity in terms of servicing, you have to access the front side of the vehicle also. You have to access the rear side of the vehicle also. The service accessibility will be more, will be hard. In the normal driving conditions, if you are riding in slow, like in the traffic, so you don't have to ride it in the both motors. Either one motor has to be, you can run with the one motor. If you are riding with the both the motors, the efficiency will be low. PTO, I have to look into it. I think it's a power transmission unit. It's like that only. It's just the power transmission unit. So don't look into this two motor layout. This is not the two motor layout. The picture is somewhat different. So look, you can look into this motor layout. So L3 you can look into it. The engine will be fixed like this only. The electric motor will be there. There will be one transmission and the differential. If you connect it to the differential, and it will run the front wheel, and the rear side also it will be like electric motor. One transmission, small transmission will be there, and it directly connected to the differential, and the rear wheel will be driving. So this is how the layout will be. Next, what we are going to see is distributed motor layout of EV. Distributed motor layout of EV is nothing but all-wheel drive or in-wheel drive. So the each motor will be placed in wheels. So for example, this is the distributed motor. So in wheel motor, the in the wheel itself, you will the dark blue shade, right? That is the motor. So in the wheel itself, the motor will be there. So and four inverters will be there for each motors one inverter, and control unit will control it. So this is how the motors will be located. So what are all the advantages? Performance will be very good and improved efficiency and regenerative braking. You can get good regenerative braking because each motor is attached to the each wheel. So you will get regenerative braking group and good torque vectoring will be there. Each tire wheel you can control. The left side, left front wheel you can easily control. In the slips, if it is going in the slips, the wheel speed sensor it will detect the front tire spinning, and you can cut out the electricity passing to the front side, front left, front right, or something. You can cut out, and the spinning won't be happening. So drifting also you can control. Over steering you can control. Understeer you can control. Everything it's possible to control in the distributed motor layout because each wheel is attached to the each motor. So it's easily controllable. But here, the thing is, the complexity will increase. The motor will be attached to the each wheel, right? So the complexity will increase, cost will increase. There will be using four motors, four inverters, and the lines from the battery has to connect it to the four inverters. There will be a lot of wirings, and the control has to be done. So many, the cost will be increased. So this kind of motors will be, this kind of layouts will be used in, Mercedes AMG vehicles, high-end AMG vehicles, Mercedes. So they use this in build models. Not yet to come outside, I think. So it will come. This is the layouts and the advantages and the disadvantages. So any doubts in this? What is that? And the two electric motor, why they are using is you can control the four wheels, the front side, one motor, rear side, one motor. You can control the four wheels easily, and you can put up two big motors to improve the performance also. And regenerative braking, if you use only one motor, regenerative braking is possible from the front side of the motor alone, not the rear side. Here, from the both side also, the regenerative braking is possible. So many advantages are there. But the problem is when the cost will increase, complexity for servicing and everything will increase. Next, what we are going to say is electric power drive systems. Uh, what are all subsystems will be using in the electric powertrain? We are going to see that in this. So, how the electric powertrain drivetrain will be and powertrain will be, how the electrical system will be. So, whole vehicles, what are all systems will be there. Those things we are going to see in this upcoming slides. So there will be one drive controller. Controller is the brain that which controls the what power it has to give and what acceleration it has to give and those things. And the power converter is nothing but the DC to AC converter. So here in the bottom red box you can see the energy source. Energy source is nothing but the battery. Energy refueling unit is nothing but the charging unit, so we will charge the battery. And the energy management unit, it's a battery management system which manages the battery, how much it has to discharge and how much is the state of charge, state of health, and the thermal management. Everything will taken care of for the battery by the battery energy management unit or battery management. So this power converter will get the DC voltage from this energy source and convert that into AC and given to the electric motor, and the electric motor will given to the transmission and it run the vehicle. This is the whole subsystem. And auxiliary subsystem you are seeing, right? That is nothing but what are all auxiliary power supply, like DC-DC converter is one kind of auxiliary power supply, and the auxiliary battery will be there. And other subsystems like power steering. Now we are using the electronic ESAP, right? Electronic steering. So that we are using the thermal management systems, power takeoff systems, door control systems. There are many control systems or the auxiliary subsystems are there. Like for example, like when I come to the auxiliary subsystems, I will explain what are all that. We will go one by one. So we saw that BMS, energy management system. What is energy management system? Which controls the battery, which takes care of the battery. The BMS takes care of the cells, ensure the safety and security of the battery, measure voltage, current, temperature of the battery, and gives out what has to be done if the temperature is high. If the current is very less, you have to give the more current. Like that, all of this battery management will only taken care of. The control algorithms will be there, will taken care of. And the state of charge, how much charge is there? It will the battery management system will calculate, and how much the health, how long this battery can withstand the life of the battery is the state of health. Estimate the state of energy and state of power and how much capacity battery is there, how much power the battery is giving. Everything will be come under the battery management system. So next, energy source subsystem. Energy source subsystem. Okay. Now we know about the battery management system. What is the battery management system? Is an electronic control system that monitors the manages the performance, safety, and overall health of the battery. It's commonly used in electric vehicles, hybrid vehicles, and the energy storage systems. Like there are many energy storage systems on that, so it will be used in that. Energy source subsystem. Energy source subsystem is nothing but how you charge the battery. You are charging the battery, right? The AC. Now, how many types of charging is there? I have one question here. How many types of charging is there? And what are the types? Can you list them? Yes, three levels. But what are the three levels? So, yes, level one household, level two AC charging, level three DC charging is there, right? So, this is that energy source. So, it refers to the vehicle, how the vehicle is charging. So energy sources typically the electricity which is used to charge the vehicle battery. How this energy is coming? You are getting this electricity, right? How it's coming? Where it's coming from? Where the source is from? So this energy they are getting it from renewable sources, renewable energy. You heard of renewable energies, right? What is renewable energy? Can you guys tell? Yes, solar, wind, biomass, hydro, wind energy. There are these are the renewable energies. So these are the renewable energies: wind energy, thermal, geothermal energy, hydro energy, biomass energy, solar energy. Through this, the electricity will be produced and it will be stored and it will supply to the all over the world and all over the supplies. You can get that supply and charge the vehicles through the charger ports and charging mediums. So these are the renewable energies. So this is the energy refueling unit. That is nothing but charging unit. There are we just now discussed. There are three types of charging, right? Level 1 charging, level 2 charging, DC charging. These are the charging units which used to charge the battery in the vehicle. Usually for charging stations, we usually get the energy from the wind energy, renewable energies, on the wind energy, solar energies. It will supply to the electric mediums and you will get the energy. And now we are going to see about the auxiliary subsystem. Auxiliary subsystem is nothing but what are all, apart from the powertrain means engine, motor, inverter, those things are there, right, which drives the vehicle. Apart from that, what are all the systems are there in the vehicle? Like steering systems is there, door control system is there, and blind spot detections. If it is autonomous vehicle, there will be a blind spot detection, front camera, rear camera, and there is a door control module will be there, and a seat control module will be there. Nowadays, everything is electronics, right? And the steering switches, combination switches will be there. Media system is there. So these are all the subsystems, auxiliary subsystems, which can get supply from the auxiliary batteries or DC-DC converters and the VCUs. So that's what they mentioned here. Auxiliary subsystem in the electric vehicle refers to various components and systems that support the operation and functionality of the vehicle beyond the main power. So this subsystem provides climate control, lighting, infotainment, cluster is there, right? Infotainment, safety features, everything. So some examples: heating, HVAC, heating, ventilation, air conditioning system, power steering system, lighting system, infotainment system, brake system, ADAS system, horn is there, and different comfort devices will be there, like seat adjustments, seat heating, seat cooling, everything is there, battery cooling system, and thermal management system. Those are all the subsystems. Okay. And next, what we are going to see is electric propulsion subsystem. So in powertrain, the powertrain electric motor is the propulsion, what they are mentioning. What else is there in that except the electric motor? What are all subsystem is there? We already seen this architecture. This architecture itself we seen long back. What is the architecture and everything we saw. So what are all subsystems are there? Apart in the powertrain, what are all systems are there? Can you guys put up in the chat? So apart from the motor, what are all systems are there? Just put up in the chat because we already discussed this multiple times. So you guys might know what are all the components or electronic components or systems are there apart from the motor. Yes. Apart from the motor, what are all the subsystems are there? Is the controller or inverter you can see, and DC-DC converters, batteries, transmission. So these are all the subsystems apart from the motor you are using to drive the vehicle. That's what we are going to see here. This is the electronic controller, nothing but the inverter. I shown this in which is mounted in the vehicle also. What is the purpose of this? Is yeah. Can you guys tell what is the purpose of this electronic controller? Convert DC to AC, not AC to DC. Yes, it controls. It converts DC to AC, and it controls the speed, acceleration of the vehicles, and it controls the regenerative braking also. These things and all it will take care by the electronic controller. And the regenerative braking also it's taken care by this particular control. Next, power converter. Power converter is nothing but DC-DC converter or DC-AC converter, you can say. So DC-DC converter is why we are using DC-DC converter. Means like we have to supply the 12 volts subsystems, right? Like there are sensors, actuators, many systems are there. So we have to supply that. We have to supply it to the small auxiliary battery. We have to charge the battery. So we have to supply the 12 volts supply to the battery. So we are using DC-DC converter to from the traction battery, high voltage battery, it will convert that to 12 volts and supply to the auxiliary battery or sensors, and it will run it. That is the purpose of DC-DC converter. So there are two types in the DC-DC converter. It's like a step up, step down. Step up means it will increase the voltage. If there is a 12 volts, it will increase the voltage to the 100 volts and it will supply. If it is a step down, if that is 100 volts from the battery, and it will decrease to 12 volts and it will supply to the systems. That is how it works. Power converter, AC DC inverter. See, DC AC inverter. DC AC inverter is nothing but an inverter like which is in between the battery and the, so it converts the DC into the AC and the supply to the electric motor. And you guys can ask, what is the difference between AC DC AC inverter and the electronic controller? Both working are same, but in the electronic controller, you can control the speeds, accelerations. There is a one control brain will be there, like a computer will be there. It can handle the speeds, like in-depth control can be done in the controller part. But AC-DC DC-AC inverter, little bit some restrictions will be there. For example, you can't do that regenerative braking in DC-AC inverter. Only the inverter part, because there will be no rectifier in this inverter module, so you can't do the regenerative braking in this. But in the electronic controller, you can do the regenerative braking because you have a rectifier in the this module. So it can convert from the motor, you will get the AC. It can convert and give back to the battery as a DC. Next, electric motor. There are many types of electric motors out there. There are DC motor, AC motor. So DC motor is nothing but which runs with the DC voltage. AC motor, you need AC voltage, three-phase voltage you need. And when coming to the electric motor, difference of electric motors, you're going to study totally about the electric motors, and you guys can learn totally in depth in that. So, but here basics are there are different types of electric motor. Commutator is nothing but in DC motor. I need pictures to show that. So I think it's better to learn it in the module 4. I will create the pictures and I can show the different types of motors, whatever it is. What is the induction motor? In induction motor is basically you won't use magnets, rare magnets in the rotor part. You guys have to understand what is rotor for that. So in the rotor part, you won't use the magnets. So in PM brushless, you will use rare magnets in the rotor part. So that is how it works. So you guys can learn everything in this both module 4. Module 4 is totally about the electric motors and how you choose the electric motors. So we can see this topic at the time. Manual transmission. In electric vehicle, there will be no complexity, that much complexity in the transmission, because in electric vehicle, electric motor generates high torques at the low speed itself. So you won't be needing any big transmission to make at the low speed itself high torque. You need like that. You don't have to make it. So you just need one single speed transmission or a two-speed transmission to supply to the wheels. So it won't be complicated as an IC engine, because in IC engine, you will get very less torque at the starting. So to match the torque and speed only, they use the transmission. Here, in the motor itself, you can control it. You just need one single speed transmission. You don't need multiple levels of transmission, like 6-speed or 5-speed transmission. You don't need for electric motors. And clutch is not required. We are not going to disengage and engage the engine for idle, and all. You don't have to disengage like that. So here there is no idle in the electric motor, so there is no need of clutch. Comparison between EV and ICE vehicles. So what is the comparisons between the EV and the ICE? So energy source. In big regenerative braking power charges to the main battery or outside. It charges the main battery. Rectifier is nothing but you will convert that from the motor you are getting AC voltage, right? So you have to convert that into DC. Then only you can charge the battery. So the rectifier work is that. So it will convert that AC voltage into a DC voltage. Which type of gearbox required? You require just a single speed gearbox, like a one gear reduction gearbox. That's all. Most of the vehicle will run by one gear reduction. So comparison between EV and the ICE vehicle. Energy source. This energy source is nothing but runs on which source it's using to run the vehicle. So it's ICE vehicle runs on. So I think here the topic heading is changed, I guess. So this will be a EV, this will be ICE for the first point. So EV vehicle runs on electricity stored in the batteries. ICE vehicle runs on gasoline or diesel fuel. So yeah, I think the heading changed. This EV vehicle has to come here, ICE vehicle has to come here. So yeah, that is the problem here. In emissions, the EV has zero tailpipe emission. There will be no emission. There is no engine to create emission, making them environmental friendly, and the air pollution will be very less. ICE vehicle has a exhaust emissions. Air pollution will be more. And charging. So you can charge at home, you can charge at public stations, you can do the fast chargings, those kind of things you can do. But availability of infrastructure is minimal and it's increasing right now. In ICE, refueling at gas station, there is wide infrastructure for EV vehicles. Generally, it's a low maintenance. So very low maintenance due to fewer moving parts and no need of oil change and those things. ICE vehicles or engine vehicles has a high maintenance. There are more moving parts in the engine vehicles and frequent oil change is needed. Noise. So in EV vehicle, there will be a very minimal noise. So engine noise won't be there. In ICE, there will be a huge engine noise. Yeah, range. So EV vehicle, the thing is, it has saturated point. Like you can't. There are very few vehicles. So, for example, like let's take Ferrari or a Lamborghini. They use 450 HP or 500 HP. Let's say if you need a 1000 HP vehicles. So you have to use two motors or three motors or four motors to get that 1000 cc, 1000 HP. In engine, you have going to use only one engine, like increasing the number of cylinders. So that capability will be more in ICE engine. You can increase the cylinders and you can increase the power gradually. Acceleration. In EV vehicle, you will get the instant torque. The starting torque will be high, so you will get the acceleration very good. But in IC engine, the acceleration when compared to EV is very minimal. Why? I will explain the graph. Infrastructure. ICE, you have a huge widespread infrastructure for gas stations. EV, it's increasing. The infrastructure, the charging station is increasing. Cost. EV vehicle higher upfront cost, the cost of the vehicle will be high, but operational cost will be minimal. In ICE, the upfront cost will compared to EV is less, but the thing is the fuel operating cost will be high. Efficiency in ICE vehicle, efficiency is very less. You get a max efficiency of 40 to 42%. So max you won't get 40%. It's sometimes, so you just get 25% efficiency. In EV vehicle, you will get 90% efficiency. So yes, rated power is nothing but the continuous power. So continuous power will be higher in EV vehicle. You will get more continuous power. Continuous power is nothing but you have to run the 24 bar 7 and 365 the way the engine can run and the motor can run without any effect. So that is the power the motor can run. So that will be easy in a motor. That will be in engine electric motor. Some capability issues. Ideal speed. Ideal speed is there in IC vehicles. You have to maintain the ideal speed to run the vehicle. To when it's standby, it has to be in idle. The time the fuel will be consumed and emissions will come out. There is no idling in electric vehicle. It can go to zero. So and you can just start directly, running directly. Torque. High torque or power at certain RPM. Like in engine, you will get that high torque in one particular RPM range. So in a motor, you will get that high torque from the starting. For example, in the below picture, in the below graph, you can see the first one is the ICE engine vehicle, second one is the motor. So the first one and the straight line curves lines are there, right? Not the dotted line, the straight line. You can see that IC engine at the zero speed, we can zoom in. So the zero speeds at the 500, the 1000 and all, the torque is very less. And the time where it's coming is the torque is coming at 1700 RPM. The peak torque is coming at that point and it's reducing. The torque will go down. So for this only, they are in engine vehicles, they will use the transmission to match the torque to improve the uh, to improve the acceleration of the vehicle. What is the upfront? Upfront means the initial the price of the vehicle. What will be the starting price of the vehicle? For EV, it's high, right? So that is no, the thing is in this tabular column, like some points is correct for EV, some points is correct for AC. It's like mixed up. Like I will tell them to change and make it proper in this. So the both the tabular columns, because like you mentioned, right, the torque. The torque is the torque column is right in the CV vehicle, but some of the columns is not, and right in the even the efficiency is right in the CV vehicle. So in this page is right. This before page is not right. So I will tell them to make it proper. So it's not a problem. Rated power is nothing but the continuous power. The motor can run continuously at the same power. For example, you can see the motor power as a 20 kilowatt. The 20 kilowatt is the peak power. At that power, the motor can run for certain seconds only. For example, the motor can run only 5 to 6 seconds continuously at that 20 kilowatt. Okay, that is the peak power. So the rated power is nothing but the power is 11 kilowatt or 10 kilowatt. At that power, in the same motor, the 20 kilowatt motor, the 10 kilowatt power is the continuous. At that power, the motor can run continuously 24 hours continuously, 24 bar 7, it can run continuously. That is called rated power. It's a continuous power where the motor can run at one particular power. At that power or below that power, it can run. The max power, the continuously the motor can run. Continuously the motor can run is the rate of power. So yeah, this is the engine graph. This is the motor graph. You can see in the motor graph the torque curve, the violet color, purple color. So at the speed from the zero itself, so you will get the peak torque. Till the certain RPM, you will get the peak. So only they are saying in the EV vehicle, the acceleration will be more when compared to the AC engine vehicle. That's the thing, electric vehicle architecture. So we know the architecture. What is the electric vehicle architecture basically? Will come from rear. Rear means lost. We will come from the lost. We will come from the differential transmission. That is the thing which connected to the rear wheels. Okay. So transmission differential, then motor will be there. How the motor will run? So you need a battery energy source from it. So battery energy source is high DC voltage, you need inverter to convert that to AC voltage. So motor controller or inverter is used here. Then you have the battery. So battery with BMS is there, and it's everything is connected to the power distribution unit. Power distribution unit is the common unit where the high voltage or the systems will be connected in it. One single unit, all the high voltage systems will be connected. So battery thermal management unit will be there. Onboard charger is there to charge the battery, and LV battery is the auxiliary battery is connected to the DC-DC converter. So from this battery, high voltage battery, through the power distribution unit, it will be converting the DC-DC converter. Through the DC-DC converter, you will convert that into 12 volts. Yeah, this is the architecture we saw and we discussed. Yeah, there will be some mistakes, or you can use the motor 56 volts and battery 48 volts also, but that is the motor controller. So you can, if you can use it, if the motor is 56 volts and you are using 48 volts, that will be a problem. So you can't achieve that speed. The voltage is proportional to speed, right? So if you are supplying 48 volts to the motor, 56 volts or 70 volts motor, so you can't achieve the, if the max speed of the motor is let's say 8000 RPM, you can achieve only 7000 RPM with this battery voltage. So to achieve the 8000 RPM, you need that much voltage. This is the architecture what we saw. I will show one video for regenerative braking. It would be more explanatory. So how it works. Yes, I will put it up. Two inverter model. What is it? Two inverter model. I didn't understand. So we will see this video, and after that I will answer the two inverter model. I have to clearly understand the questions. So what is happening is so she is pressing the accelerator, and she just left the accelerator. This is called one pedal drive. One pedal drive means when you press the accelerator, the vehicle will run. When you take the foot from the accelerator, it will start braking. That means engine braking. That is a motor braking. So she took out her foot from the accelerator. So what will happen is, so here in this graph, you can see that orange thing is the acceleration power. So it's the acceleration power, and the green, you can see in the green, that green is the regenerative power, which is supplying to the battery. Why it's happening here is she just took out her foot from the accelerator, so she is getting the regeneration back. So you can apply the brake for completely stop the vehicle. For normal stop and all, you can do with the one pedal. Just take out the foot, and the vehicle will slowly stop. That will recover the energy from the motor. Yeah, I will explain about that. It will be more than the normal charging or not. I will explain about it. Maximum braking in regeneration is depends on the motor. Like if the motor torque is 450 Newton meter, 200 Newton meter, the maximum brake torque will be for 200 Newton meter. That's whatever the motor torque will be, that is the regeneration torque. Whatever the motor force will be, that will be the regeneration force. Now we are going to see the working of regeneration. Let's assume this is the Tesla first model is they are using induction motor, right? So let's assume this is the induction. So now they are supplying the input current to this outside coil is there, right? That is the stator, and the inside this grills are there, right? This is the rotor. Okay. So now they are supplying the voltage and current to the stator, and the coil is energized, and it will hit the rotor. So now the motor is rotating, the rotor. So now what will happen is, yeah, now what will happen is like when the vehicle is braking. Now when the vehicle is braking, what will happen is this part, right, the rotor part. There is no electricity passes from the battery. Okay, this medium, this blue line won't be there. So, but when braking, So the rotor will be rotating because it's directly connected to the transmission, and the transmission is connected to the wheel. Okay, so at that point, it gives the reverse voltage and the reverse current. The reverse voltage and reverse current, what it will do is that will supply to the battery. How it will, the reverse voltage and the reverse current, how it supply is through the inverter. So I will show the inverter. So here. So while braking, the rotor will rotate, right? There is no supply from the battery to the stator. So, but the rotor is still rotating while braking for certain distance. So at that point, there is no current is passing from the this battery. So what it will do is the rotor will give out through the stator part some voltage and the current that will give the back voltage and the back current to the battery. How it will give to the battery is through this inverter. Inside the inverter, there will be a rectifier. So you can see it in this video. So now what is happening? The braking is happening. So there is a reverse voltage and current. So that is the reverse power flow. How it's what will happen inside the inverter also they will show. So this is the rectifier. Inside that inverter, there will be a rectifier. So this is the rectifier. The motor will supply while braking the reverse power flow to this rectifier, which is inside the inverter. That will supply. That will supply to the. That will convert that AC voltage into the DC voltage. That DC voltage will supply to the battery. So here you can see this two wires, right? That is the DC voltage which supplies to the battery. So this is how, so it's called rectifier. So this is how the regenerative braking work. So while there is braking, the motor will have a reverse power flow. Like the reverse voltage will be there. That reverse current will be there. That is called a reverse power flow. That you can see these three wires, right? From that, from the motor, it will connect to the inverter. In the inverter inside, you will see that rectifier. From these three wires, you will get the reverse power flow, and that will rectifier will convert that AC voltage into DC voltage. This DC to DC is there, right? That is a DC-DC converter. There will be a fluctuation in the voltages. Okay, this DC-DC converter, what it will do is it will control that output voltage. Like if there will be some if there is a battery is 100 volts, you will get from the reverse power voltage, you will get 80 volts, 90 volts, 110 volts. This DC-DC converter will convert that into 100 volts, and it will give to give to the battery through these two wires. So this is how the regenerative braking works. Okay, I hope you guys understand the regenerative braking, and I guess like today's session we totally talked about how the topology of the vehicles will be, and how the motor will be fixed in what location, and what is hybrid, what is series hybrid, parallel hybrid. I hope some new information, new learnings you guys have learned today in today's session. Can you tell the two DC AC inverter is present? Like two DC AC inverter. If there is a two motor present, you need two inverters for that. Which one? This one, the DC AC inverter. So yeah, this DC AC inverter is nothing but it will convert the battery DC voltage into the AC voltage. So, like you can't do the regenerative braking in this because there will be no rectifiers and those things will be there in this inverter. So, what this is the difference between this electronic controller and the DC-AC inverter. So, you will in this electronic controller you will have the rectifiers, and it will you will control the speeds, accelerations, everything in this electronic controller. But in this DC-AC converter, you will inverter, you can't do the regenerative. When compared to electronic controller, this is little bit basic, you can say. So for we have a control electronic controller, right? That we saw here, electronic controller. So that you are pressing the pedal, the accelerator pedal, that information will go to the VC, the electronic control unit. The electronic control unit will give the signals uh, to the electronic controller. That can be a PW, pulse width modulation signals. Like the signals, it will given to the signals will be given to the electronic controller. That electronic controller will decide for this throttle pressing pedal, like let's say 30% pedal, how much speed has to go, how much torque it has to go. So for that torque, how much current this electronic controller has to supply. So that electronic controller will send the information to the BMS, which is in the battery. I need this much current from the battery. Okay. So that much current will be passed through the controller and the controller will supply to the motor. This is how it works. There are many like Grand Vitara, they are using hybrids. The Toyota and Maruti, they combine together and releasing the common powertrains. But yeah, Toyota, you can say the Toyota Cruiser, Hyrider, they're using Innova, they're using the hybrids. Um, what else? What else? Hyundai, they are not using. There are many companies which are using. I will list down car companies. I will let you know. Many companies are using the hybrid. To develop a EV, it's easy. Like you're going to get parts from everywhere, but to make it efficient, to bring it to the market is difficult because there are so many players in the market. So at least grants is not so easy. You will get the minimal grants, like 20 lakhs is the max grant you will get. So like from the government, but not everyone is getting that. So to bring a scooter in the market, like let's say moped in the market, it will take at least 3 to 4 years to develop, test it, get a regulation, bring in, get the people, customer acquaintance, and then bring in the market. It will take this much time. Data will be displayed. Yeah, BMS data will be displayed in the dashboards, like how much is the state of charge, how much is the state of current, everything will be displayed in the dashboard. The BMS will be send information to the VCU, and VCU will send information to the dashboard, and it will show through the CAN communications. Like it's not too early to ask, we can say. If you read, now I explained about the advantages and disadvantages. And if you read the advantages and the disadvantages, you will get the new way of looking. Yeah. So when you read, when you see the materials and when you read the materials, you will get to know if I place the motor in this position, what disadvantages are there. So for that, I have to use parallels method or series method. So series method, if I use, why I can't use that in the long off-roading purpose, long highway purpose? Why I can't use that? So those kind of questions you will itself get, and you will itself can answer those questions. If you can't able to answer the question, you can ask me, and I can answer those questions.
Just a quick info, guys. Intellipaat offers electric vehicle course training. Through this course, you will learn vehicle fundamentals, battery technology, battery sizing, mechanical subsystems, charging infrastructure, and much more from the top 1% of industry experts around the world. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, the link of which is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of EV.